In this video, we'll explore how AWS cloud deployments are orchestrated. Cloud developers typically deploy applications consisting of a three-tier architecture. These include a web tier, an application tier, and a database tier. The goal is to achieve and maintain a consistent, robust, and rapid deployment process that addresses deployment requirements, not just of the software, but also of the infrastructure across the entire software development lifecycle. The typical software development release lifecycle consists of 5 distinct integrated phases. I like to think of this as a software product assembly line. The 5 phases are the source phase. In this phase, code changes are checked into a source code repository. Quite often, code reviews and approvals, or a combination, are required before the code is deployed to a target environment. In the build phase, the source code gets built and tested for quality in the build environment. During this phase, you'll commonly find a lot of unit testing, a lot of automated unit testing. During the test phase, software is typically deployed to a pre-production or test stage that is identical or as close to identical to production as possible in order to execute tests that either can't be done or should not be done in the build environment. This may include integration testing, security, load, and interface testing. In the deploy phase, the application gets deployed to production. A common strategy here is to mitigate risk while deploying an application to production. And in the monitoring phase, the application is monitored to ensure that there aren't errors or issues with the software in production. And this monitoring may continue indefinitely in a continuous feedback loop for continuous improvement. One thing to keep in mind here is that many of the activities that take place in these phases are automated as much as possible. The AWS cloud environment provides services for all these phases, covering the entire software development lifecycle. One of the first considerations when deploying infrastructure and code is to define what the environment variables look like. Typically, the software development lifecycle includes manual release, test, and deployment activities. Quite often, traditional deployments also don't synchronize the patching, updating, versioning, and infrastructure changes. So testing can sometimes yield different results in test and production environments due to differences in configurations. AWS Cloud offers several services for deploying applications rapidly and for managing the different environments and tiers. For example, Elastic Beanstalk allows us to automate all aspects of our deployments and their environments, automatically managing the different AWS services like auto scaling groups, EC2 instances, database, and others for us. When we talk about the CI/CD pipeline, we're talking about integrating continuous builds, tests, and source code deployments. The continuous integration part involves continuously integrating changes into source code repositories. The goal here is for the team to improve the quality of the software being developed and deployed, while at the same time liberating developers and allowing them to focus on developing, thereby becoming more productive. The continuous delivery part sees all code changes being automatically prepared and available for one-touch deployment. Elastic Beanstalk integrates within the software development lifecycle and the CI/CD pipeline, offering the ability, for example, to extract code from a Git repository and deploy it all the way to production. AWS has a number of code services, and these consist of various services for orchestrating and automating the software release lifecycle. These include the AWS CodePipeline, which enables us to model and visualize the release process for quick and reliable updates. AWS CodeCommit, which is a managed source control service from AWS for hosting private Git repositories. AWS CodeBuild compiles source code, executes tests, and generates software packages that are ready to deploy without the need to manage build servers. And AWS CodeDeploy can automate code deployments to Amazon EC2 instances, or even on-prem servers, regardless of language or operating system. When deploying to the cloud, the objective, of course, is to deliver high performance and high availability for our users. AWS Cloud Services help us deploy highly available and scalable applications. The process flow looks like this. We deploy applications to multiple availability zones and AWS regions for availability and redundancy. We integrate health checks and our failover strategy, which is significantly automated on AWS Cloud. We can define a stateless application to be used to store session state in a cache server, for example, and we integrate various AWS services to achieve our availability, scalability, and performance goals. For example, incorporating elastic load balancing and auto-scaling groups. For simplifying cloud deployments, AWS offers several services, including AWS Elastic Beanstalk, which automatically takes care of scaling and managing our application infrastructure, AWS OpsWorks, which is a configuration and deployment management tool that works with Chef or Puppet infrastructure configuration management software, and AWS CloudFormation, which is infrastructure as code for AWS resources. We, of course, are going to be diving deeply into Elastic Beanstalk in this course, and we'll explore CloudFormation in another course later on. Auto-scaling groups consist of a set of EC2 instances with identical properties as a logical grouping of resources. AWS monitors resources in our auto-scaling groups and automatically scales capacity, with the goal being to optimize performance of our applications with cost. Scaling policies can dynamically scale the number of instances in the group up or down to meet changing loads and conditions, all the while periodically performing health checks on instances, terminating unhealthy instances, and replacing them with healthy ones. And EC2 autoscaling combines with AWS autoscaling to scale resources for other AWS services. In this video, we'll explore AWS Elastic Beanstalk. Elastic Beanstalk is an easy-to-use service for deploying and managing applications, services, and architectures on AWS resources. Elastic Beanstalk streamlines the management of application deployment, reducing management complexity and overhead by automatically taking care of capacity provisioning, load balancing, scaling, and monitoring the health of the application and its underlying infrastructure. With AWS Elastic Beanstalk, we build full-stack environments for web tiers as well as worker tiers. Elastic Beanstalk can deliver a pre-configured infrastructure for different environments. For example, a development environment that is relatively low cost and using a single instance, all the way up to full-fledged production environments with load balancing and auto-scaling. A typical software development lifecycle process includes development teams managing their source code changes in a source code repository within an iterative, cyclical process. Elastic Beanstalk allows developers to create an application, upload the created application version as a source bundle, while providing information concerning the application. Elastic Beanstalk can integrate with an existing Git repository or with AWS CodeCommit to retrieve the source bundle. The source bundle comes from a source repository, or the bundle can also be retrieved from an Amazon S3 bucket. Some important Elastic Beanstalk concepts include the application itself. Elastic Beanstalk manages applications as environments along with all the resources required to run them. Every application managed with Elastic Beanstalk is a logical collection of application versions, environment configurations, environment variables, and components. Application versions are iterations of the application in the form of deployable source code, and applications managed with Elastic Beanstalk can have several versions, each version using an Amazon S3 object to store the bundled source package. Each Elastic Beanstalk environment is a separate and distinct version of the application with the necessary resources to run it. Now, although each environment can only run one application version at a time, you can run multiple environments with the same application on each, while incorporating customizations and configurations specific to the environment. The environment tier defines the type of application running in the environment along with the required resources to run it. For example, a web server environment tier or a worker environment tier. And the environment configuration defines a set of parameters and configuration settings that determines how an environment and its related resources operate. You can update an environment's configuration, and when you do, Elastic Beanstalk automatically takes care of applying the changes. Elastic Beanstalk can also be used to manage Docker containers for running applications. Docker containers are self-contained environments complete with configurations and software required to run the application. You can also run a single or multiple container deployment. If using a multi-container deployment, Elastic Beanstalk uses Elastic Container Service to launch a cluster of containers. We can create advanced environment configurations by using configuration files, which are files with a .config extension bundled with our source code. The configuration files must reside in a .eb extensions directory off the root of the source, with an option settings section in the configuration file defining the values for configuration options, while a resources section can be defined in the config file, allowing us to customize an environment's resources or specify additional AWS resources over and above those provided by configuration options. Configuration files are YAML or JSON formatted documents, but Amazon recommends YAML for readability. Elastic Beanstalk automatically integrates with or takes care of managing other AWS services. One of these services is AWS Config. AWS Config is a tool that helps us visualize configuration history and how they change over time. We can integrate AWS Config directly or in our application's Elastic Beanstalk environments. Elastic Beanstalk environments can integrate with Amazon CloudFront, which is content delivery and distribution through its global edge locations. For example, after deploying our application on Elastic Beanstalk, we can use CloudFront to cache static content for our application. For caching purposes, we can integrate Elastic Beanstalk with ElastiCache service clusters to improve application performance. Elastic Beanstalk integrates with Amazon RDS or Amazon DynamoDB. To configure this, we use the same configuration files as for our other service option settings. We must create connections to the database, which require that we configure password management in Elastic Beanstalk. Elastic Beanstalk also integrates with Amazon S3 to store static content or other content that we want to include in our application. For example, we can harden database connection information by storing it in an Amazon S3 bucket. Elastic Beanstalk also integrates with AWS Identity and Access Management, or IAM, using roles to provide access to services required for our application's architecture. IAM roles also automate the management of services for our application, and it also allows, for example, the launching of code with inline policies. In this video, we'll explore the Elastic Beanstalk CLI. The Elastic Beanstalk CLI is a command line interface specifically for Elastic Beanstalk. With the CLI, we have a full list of interactive commands for creating, for updating, and for monitoring Elastic Beanstalk environments from the command line. We can use the Elastic Beanstalk CLI as an alternative to the Elastic Beanstalk console. To install the Elastic Beanstalk CLI so that you can create, configure, and manage Elastic Beanstalk environments, Amazon recommends using one of the Elastic Beanstalk CLI setup scripts available from GitHub. Once you've installed the Elastic Beanstalk CLI, you will initialize an Elastic Beanstalk project by configuring a project directory. You use the init command to initialize the project directory, and then you use the create command to create a new environment. The Elastic Beanstalk CLI is an open source project, and the code is located on GitHub in the AWS/AWS-Elastic-Beanstalk-CLI GitHub repository. Now, the AWS CLI, so that's the AWS CLI, not the Elastic Beanstalk CLI, but the AWS CLI, it also provides direct access to the Elastic Beanstalk API and is excellent for scripting, but it's somewhat cumbersome to use from the command line due to the number of commands required for each operation and the number of parameters that need to be provided for each command. Now, some common commands used with the Elastic Beanstalk CLI include ebinit, and again, this is to initialize an application or a project. It sets the default values basically for the application. Then ebcreate creates a new environment and deploys the application to it. ebdeploy deploys the application source bundle from the initialized directory for the running application. Then ebclone clones an environment to a new environment, and ebcodesource configures the Elastic Beanstalk CLI to deploy from an AWS CodeCommit source repository, or it can also disable the AWS CodeCommit integration and upload the source bundle from the local machine. Okay, when you first initialize a project, the Elastic Beanstalk CLI prompts you to select a region. Then you provide your access key and secret key. Now, if you've already configured AWS CLI with the access key and the secret key, then it will pick that up automatically. Then you specify the name of the project, and then you select the platform or language that you're going to use for your web application. In this demo, we'll install the AWS Elastic Beanstalk CLI. Okay, we're going to install the Elastic Beanstalk CLI using setup scripts available from GitHub. And we're going to clone a GitHub repository in order to do that. I've signed in to AWS Management Console in my browser, and I've also opened a second tab, and I've navigated to git-scm.com. This is where we can acquire the Git installer. This page has detected that I'm running Windows, so I'll click Download for Windows, and in the opening dialog, I'll click Save File. Now I'll click the download icon on the browser toolbar, and I'll click the downloaded executable to install Git. If a user account control dialog appears, click Yes. And when the setup wizard appears, click Next. And in fact, we're going to accept all the defaults except on the last page. So let's just click through here. And we don't want to enable experimental support for sudo consoles. So we'll actually uncheck that checkbox and click Install. Okay, the installation proceeds, and it shouldn't take too long. And done. Now I'm going to uncheck the View Release Notes checkbox and click Next. And now I'll open an elevated PowerShell prompt. Now I've pinned the PowerShell icon to my taskbar. So if I right click, I'll select Run as Administrator. And in the user account control dialog, click Yes. Now I'll maximize the window. And I'm going to go to my working directory, which is at C:\users Joe AWS projects. Now I'll clear. Now you need to set up your global username and email. And to do that with Git, you type git config -- global user.name and your username. Now it doesn't have to be surrounded in quotes unless it has a space in it. I just prefer to do it that way anyway. Okay, now I'm going to clear, and now we set up the user email. So that's git config -- global user.email and your user email, and press enter. Now I'll clear again. Okay, now I also have a requirement for Python, but I've got Python and pip already installed in this machine. So to check what versions though, I'll type python -- version, and I've got Python version 3.7.4, which is good. Now I'll clear. Now pip -- version, and I've got the most recent pip package manager for Python. Okay, so now we'll clone the Git repository for the AWS Elastic Beanstalk CLI setup. And to do that, I'll type git clone https://github.com/aws/elastic-beanstalk-cli-setup.git and press enter. All right, done. Now if I do a listing, I'll see that I have an AWS Elastic Beanstalk CLI setup directory. Okay, so now I'll clear. And now, because I have Python installed, to install the Elastic Beanstalk CLI, I'll type python./AWS-elastic-beanstalk-CLI-setup. And in that directory, I'm going to navigate to the scripts directory. So I'll type scripts and / and ebcli_installer.py. Now pressing enter. To complete installation, we need to ensure that EB is in the path on this machine. And because we're using PowerShell, I'm going to highlight the second command. So I'll right click to copy that to the clipboard. Now I'll clear as well. Now I'll right click to paste that command into the terminal and press enter. And now if I type $env:\path and press enter, I still won't see that directory in my path. And the reason for that is because I have to reload PowerShell. So I'm going to close PowerShell by clicking the X in the top right corner, back down into the taskbar, right click and select Run as Administrator again. Click Yes to the User Account Control dialog, maximize the window, CD to my working directory, press enter, I'll clear again. Now, one more time, I'll type $env:\path. And now I'll see that the directory is now listed in my path. So now, if you do experience virtual environment issues, maybe because you don't have the virtual environment installed, and to do that, it's just a simple pip install virtual env. Okay, and I already had it installed, so it didn't reinstall it. Now, the other thing that you may encounter is an error with a message similar to something like execution of scripts is disabled on this system. In that case, you have to set the execution policy to remote sign for PowerShell and then rerun the bundled installer. Now, for that, we type set-execution policy remote sign. Now, I'm just pressing tab to auto-complete these commands in PowerShell, which is one of the beautiful things about PowerShell. Okay, so I'll press enter, and I'll confirm that I want to change the execution policy by typing Y and done. So I'll clear one more time, and now I'll type EB -- version, and it reports that EB CLI 3.18.1 is installed along with Python 3.7.4. Okay, so now with Elastic Beanstalk CLI installed, I can start creating environments and managing environments here in the terminal with the command line interface. In this demo, we'll create an Elastic Beanstalk web server environment with the CLI. Okay, I've opened Visual Studio Code, and I'm open in the Explorer in Visual Studio Code to the AWS project subdirectory, and I've opened a terminal prompt to this directory as well. First, I'll need to create a directory for my application. So I'll type mkdir web app. That'll be the name of my application. Now I'll cd into web app, and I'll clear. Now the first thing we need to do is initialize the directory for the application, which essentially creates the application. So to do that, I'll type eb init. press enter. Okay, and now we have to select a default region. For this demo, we'll go with 2, US West-1. So I'll type 2 and press enter. Now the application name by default is web app. That's the directory that we're in, so we'll just leave that as is. And now we choose a platform. I'll type 6 for Node.js. And the platform branch, Node.js 12, running on 64-bit Amazon Linux 2, which is the default. So I'll just press enter. Now a message appears telling us that we can't set up code commit because there's no source control set up, which is fine. We have no source control set up at this point. Then we're asked, do we want to set up Secure Shell or SSH for your instances? We'll press N and press enter. And now the application's been created. So this directory has been initialized for Elastic Beanstalk. So I'll clear. And now to create a new environment for my application, I'll use the eb-create command. So I'll type eb-create, and I'll add the -- single flag, which sets it up for a single instance deployment. No load balancing with this particular deployment. So I'll type eb-create -- single, and I'll press enter. Now for the environment name, the default is web app -dev. We'll leave that as is, press enter. And we'll also use the default for the DNS CNAME prefix. We'll press enter. We don't want to enable Spot Fleet requests, so we'll press N and press enter. And now the current directory doesn't contain any source code. I just created it after all. And Elastic Beanstalk recognizes that, and instead is going to launch the sample application for us. It also gives us the option now to download the sample application into the current directory. So I'm just going to press Y to do that and press enter. Okay, so Elastic Beanstalk is creating the application. It's creating our dev environment for us. And we can expect status messages until it's successfully deployed. Okay, now over in Explorer, if I expand the web app directory, I'll see that indeed the application has been downloaded. Now, .elastic beanstalk was actually created when we created the application. So if I expand that, I'll see config.yml, which is our configuration. So we've got our environment, we've got the application name, we've got the platform, the default region, and so on. Okay, and now looking at the status, I see now that the Elastic IP has been created for this deployment. So now let's go down into the taskbar. I'll click to bring up my browser, where I've signed into AWS Management Console. Under Find Services, I'll type Bean to bring up Elastic Beanstalk. I'll click on Elastic Beanstalk. And now I need to choose the right region. We chose US West 1, Northern California, so I'll click on US West 1, Northern California. And now in the left navigation menu, I'll click Environments to see that the web app -dev environment that we just created from the command line interface has a status of pending, so it's being created. Notice the tier name is also web server. Okay, now if I click on Applications in the navigation menu, I'll see our application and all of its associated environments. Right now there's only one. So now let's click to bring up that environment. So it has been deployed successfully now. So if we scroll down, we can see the info and the events that occurred, which are echoed back on the command line interface. So if I go back to the command line interface, I'll see that we have the same information, the same events. Okay, so now let's clear. Now a couple more EB CLI commands, for example, EB status. So EB status gives us the status of the deployment. So we can see right now the status is ready, the health is green, so it's healthy. Okay, and now we can open the environment in a browser by using the eb-open command. So I'll type eb-open, and the environment is web app-dev. So I'll press enter, and that brings up the application in a browser window. Now I'm going to click to close this tab, and I'm going to go back down to the taskbar and go back into Visual Studio Code. Now one last command, so first I'll clear, is eb terminate. Now this will terminate the deployment, but if I want to delete everything in it, all the resources within it, I just specify the -- all flag and press enter. Now, it tells us that there's one running environment that will be deleted and one application version. So if I type the application name, then it's going to go ahead and delete everything associated with the web application. So I'll just press enter to cancel the termination request. So we've successfully created an Elastic Beanstalk web server environment using the command line interface. In this demo, we'll create an Elastic Beanstalk web server environment in the AWS Management Console. Okay, I've signed in to AWS Management Console. Let's go to Elastic Beanstalk Service. So in Find Services, I'll start typing Beanstalk, and then I'll click on Elastic Beanstalk when it appears. Okay, so I have one environment right now. That's a development environment. I created this with the command line interface. If I click on the environment to choose it, there are several actions that I can choose from. So if I expand actions, I can load a configuration, save a configuration, swap environment URLs, clone the environment, restart app servers, rebuild the environment, and terminate the environment from here. I can also create a new environment right here. Okay, now over to Applications. So I'll click Applications in the left nav menu, and I'll click to select the web app application. And when I click Actions here, I have several options. I can create an environment here. I can delete this application. I can view application versions, view saved configurations, and even restore terminated environments. I can also create a new application from here. So down in the taskbar, I'll click to bring up Windows Explorer, and I'm going to navigate to my AWS projects directory, and I'm going to grab the files that I need for this application, and I'm going to bundle them or zip them up. So I need EB extensions, I need app.js, cron.yaml, index.html, and package.json. Now if I right click, I'll point to send to, and I'll select compressed zipped folder, and I'll call this bundle webapp-bundle-v1.zip. Okay, now down on the taskbar, I'll click to bring up the Beanstalk console again. Now I'll expand actions and I'll select Create Environment. Now the environment tier is a web server environment. I could also choose a worker environment, but that's more for long-running processes, which we're not interested in at this point. So I'll click Select to select Web Server tier. Now for the environment name, I'm going to choose Web App-Test. Now for domain, I could specify my own and hope that it's available. I can check the availability, so I'll just type webapp9999, check availability, and it's all good. But I'll delete that and I'll just leave this blank for an auto-generated value. Now for description, I'm just going to give it the description test environment. All right, under platform, this is a managed platform, and I'll choose Node.js. Now for platform branch and platform version, I'll leave the defaults. Now for application code, I can either leave the sample application selected, or if I had an existing version, I could choose that as well. But this version of the application is based on the sample application from Elastic Beanstalk. So I'll click to select Upload Your Code. Now I can choose a local file, a public S3 URL, and I'm going to click Choose File, and I'm going to go and select the bundle that I created earlier. So in the File Upload dialog, I'll expand AWS Projects and Web App, and I'll select my webapp-bundle-v1.zip, select Open, and it was uploaded successfully. Okay, scrolling down, I can also apply application code tags, but I won't at this point. Now I'll click Configure More Options, and here I can configure the options for my environment. So there's software, I can configure the instances, I can configure the capacity. Right now, I have a single instance deployment. I'm going to click Edit. Scrolling up, I'm going to select a load balance environment type. So I'll expand environment type drop down and I'll select load balanced. I'll set a maximum number of instances to 3. I'll leave the rest at their defaults, including all the scaling triggers. I will leave those at their defaults at this point. Okay, so I'll click Save. Okay, that brings me back to the environment configuration page. So now I can specify load balancer. So if I click edit under load balancer, I'll scroll up and I'll see that right now the load balancer is an application load balancer. And I'll leave that as is. Okay, so scrolling down, click save. Now I can also configure rolling deployments here, security, monitoring, managed updates, notifications. If this environment were part of a VPC, I would be able to configure the network. And database. So if I click on edit in database, I can configure a relational database service database engine. So for example, MySQL database engine managed by RDS, but I will not do that at this point. So I'll just cancel. Now back on the configure page, I'll click create environment. Okay, and Elastic Beanstalk is creating the web app-test environment. And this will take a few minutes. Now while it's working, I'll click on environment and I'm going to drill down into web app-dev. Now in the left navigation menu, I have some options when working with environments. I can go to the environment. This would open the environment in a new tab. I can also visit the configuration page from here in a list or table style. Clicking logs brings me to the log page where I can request logs. The health page shows me health status and metrics for the environment and for all EC2 instances in the environment. Monitoring allows me to access operational information about the environment. I can view any alarms which I could create on the monitoring page. I also have access to managed updates from here, events, and tags. And scrolling down in the left nav menu, I also have access to recent environments. Now back over in the environments page, the web app-test environment says pending still, and there it goes. It says OK. So let's click to drill down into the web app-test environment. Okay, and health is okay, so everything was successful. So if I click the URL, that'll open the application in a new tab, and I can see that the application successfully deployed. All right, so we've successfully created an Elastic Beanstalk web server environment using the Elastic Beanstalk console. In this video, we'll explore Elastic Beanstalk deployment modes. The Elastic Beanstalk console allows us to upload an updated source bundle and deploy it to an Elastic Beanstalk environment, or redeploy a version that was previously uploaded. The updates are usually fairly quick. However, there could be some downtime. Now, when a configuration change requires that instances be replaced, Elastic Beanstalk can update in batches. Doing the updates this way avoids downtime, allowing the changes to propagate. With a rolling update, capacity of the system is reduced only by the size of the configurable batch. The way it works is that Elastic Beanstalk removes a batch of instances from service and terminates them, and launches a new batch with the updated configuration. Then, once the new batch begins serving requests, Elastic Beanstalk starts updating the next batch. Now, let's consider the Elastic Beanstalk deployment policies. First, all at once. With all at once, a new version is deployed to all instances at the same time. So all instances in the environment are taken out of service for a short period of time while the deployment takes place. With a rolling deployment, the new version is deployed in batches. Now, each batch is taken out of service during the deployment phase, and this effectively reduces the environment's capacity by the number of instances in a batch. Now, rolling with additional batch deploys the new version in batches, but it first launches a new batch of instances, and this way it ensures that you maintain full capacity throughout the entire deployment process. Now, an immutable deployment deploys the new version to a completely new set of instances in a separate auto-scaling group in parallel with the instances running the old version. If the new instances aren't passing health checks, then Elastic Beanstalk terminates them and the old ones remain in place. Now, there's a new type of deployment, and that's traffic splitting. Now, this allows us to perform canary testing as part of the application deployment. With traffic splitting, Elastic Beanstalk launches a completely new set of instances, similar to how an immutable deployment works. It then forwards a specified percentage of incoming traffic to the new version for some specific period of time in order to perform an evaluation. If the new instances remain healthy, then Elastic Beanstalk will forward all traffic to them and terminate the old instances. If, however, the new instances aren't passing health checks, or if the deployment is aborted, traffic is moved back to the old instances and Elastic Beanstalk terminates the new ones. To configure deployments, there is a specific process. So basically, in Elastic Beanstalk console, we choose a region, then we choose the environment that we want to make the change to. Then in the navigation pane, we choose the configuration for that environment. And then in the rolling updates and deployments configuration category or section, we choose edit. And in the application deployments section, we select a suitable deployment policy and batch settings. Then we click apply. Okay, so to summarize, with the all at once method, the impact of a failed deployment means that there will be downtime. With a rolling update, the impact of a failed deployment is that a single batch is taken out of service. So really there's still zero downtime. However, you do have reduced capacity. Now, with rolling with additional batch, the impact of a failed deployment is minimal if the first batch fails. Otherwise, it's similar to a rolling deployment. With an immutable deployment, the impact of a failed deployment is minimal. And with a blue-green deployment, the impact of a failed deployment is minimal. In this demo, we'll configure Elastic Beanstalk deployments. Okay, I've signed into AWS Management Console and I've navigated to the Elastic Beanstalk console. I'm on the Environments page, and I'm going to choose the Web App-Test environment to work with. So I'll click on Web App-Test, and now in the left navigation pane, I'll click Configuration. And now scrolling down, I'll choose Rolling Updates and Deployments and click Edit. Okay, at the top of the page is the Application Deployments section, and we choose the deployment options from here. So for our deployment policy, if I click the down arrow, I can choose all at once, rolling, rolling with additional batch, immutable, and traffic splitting. I'll click immutable for this demo. Now with immutable, the batch size is going to be 100% because we're going to deploy a new version to a fresh group of instances by performing this immutable update. Scrolling down. Okay, now consider that rolling updates occur when settings are changed that require new EC2 instances to be provisioned. This includes changes to auto-scaling group configurations, for example. Now, we're not going to worry about this for this demo, so I'll leave rolling update type disabled, but if I click the down arrow to expand the drop-down list, we can have rolling updates based on time, based on health, and immutable. Okay, scrolling down, the Deployment Preferences section has options related to health checks. So I'll leave these at their default, and I'll click Apply. And now Elastic Beanstalk is saving our changes. So while it's doing that, let's go down to the taskbar. I'll click the Visual Studio Code icon to bring Visual Studio Code up. Okay, now previously I had made a web app bundle v1 Now what I'm going to do is I'm going to make some changes. Now these are going to be changes that we can deploy in our immutable deployment. So I'll click to open the index.html file, and locating line 79, instead of "this environment is launched with Elastic Beanstalk Node.js platform," I'm going to type "this is an immutable deployment." Now I'll press Ctrl S to save the changes. And now I'm going to zip these files up into a new bundle. So now down on the taskbar, I'll click to open Windows Explorer, and I'll grab EB extensions. So I'll hold down the Control key and click on EB extensions, then app.js, cron.yaml, index.html, and package.json, not web app-bundle-v1 though. Okay, now I'll right-click, point to send to, and select compressed zip folder, and this time I'll call it web app-bundle-v2. Okay, now back down to the taskbar, clicking on Visual Studio Code again. So now in the directory I can see v2 of our web app bundle. Okay, so down on the taskbar, I'll click the web browser icon to bring up my Elastic Beanstalk console. And now I'll click Upload and Deploy. In the Upload and Deploy dialog, I'll click Choose File. I'll choose web app-bundle-v2, click Open, and the version label is going to be web app-source-1. It increments it by 1 each time. We'll leave that as is. Now for deployment preferences, the application version will be deployed using the immutable policy it tells us. So I'll click Deploy. Okay, and Elastic Beanstalk goes and updates the environment. Meanwhile, while this is happening, if I click on the URL to bring this up in a new tab, I'll see that I'm still accessing the old site. So this environment is launched with Elastic Beanstalk Node.js platform. While it's updating with the immutable policy, the thing is that we won't have any downtime. Now this can take a little bit of time, so just be aware. Now if we want to, we can click View Events to go and view the events as they occur. So we can see, for example, at the top, created temporary auto-scaling group for the immutable stack. So basically what it's doing is it's creating this deployment on a new fresh set of instances. Okay, and it added the instances to the load balancer. Now it's waiting for the instances to pass the health checks, and when they do, then we'll be able to access the new web app or the updated web app. Okay, and now we see that the deployment has succeeded. The old instances are being terminated along with the temporary auto-scaling group. So now at this point, let's try to go to the environment. So from the left navigation menu, I'll click Go to Environment. And we see that this is the new version because I see the message, "This is an immutable deployment." So I'll close this tab by clicking the X on the tab and back to my events. And the environment update completed successfully. So we've successfully configured an Elastic Beanstalk deployment using the Elastic Beanstalk console. In this demo, we'll work with EB extensions to set configuration options in an Elastic Beanstalk environment. We can add EB extensions, which are simply Elastic Beanstalk configuration files, to our source code to configure our environment. These configuration files are in YAML or JSON format, and they have a .config file extension. We must place them in a folder named .eb extensions off the project root, and they get deployed with our application's source bundle. So, for example, I have Visual Studio Code open in my web app directory. Now under .web extensions, I've created a file called options.config, which is open in the editor. Now this is YAML format. Okay, and the syntax for options settings is as follows. So on line 2, we have option_settings, : then on the next line, we have our namespace, which in this case is AWS Elastic Beanstalk application environment. Then on lines 4 and 5, I set a couple of parameter values. Now there are several sections that we can specify in an EB extensions config file, not just option_settings. There's also resources. And the resources section is specifically for customizing the resources in the environment. For example, RDS resources. Note one thing though, that resources managed by EB extensions are removed when the environment gets removed. Okay, I've zipped up this new application into a bundle called webapp-bundle-v2.1.zip. So now down in the taskbar, I'll click the browser icon to bring up the Elastic Beanstalk console. And now what I'll do is I'll click webapp-dev and I'll make the change to this environment. So now I'll click upload and deploy. I'll click choose file. I'll take webapp-bundle-v2.1.zip, click open. Now for the version label, I'm going to specify a new label. I'm going to call it webapp-v2.1. And I'll click deploy. Okay, now Elastic Beanstalk is updating the environment, and when it's done, we'll go into the configuration for this environment and we'll have a look. Okay, so now it's ready. Now in the left navigation menu, I'll click configuration, and in the software category, now I have two environment properties, myparam1 and myparam2. So if I click edit, scrolling down, I'll see those parameters under environment properties. So we've successfully used EB extensions to set configuration options in an Elastic Beanstalk environment. In this demo, we'll perform a blue-green deployment. When you update application versions, AWS Elastic Beanstalk performs an in-place update. And for this reason, an application can temporarily become unavailable to users. We can avoid any downtime by performing a blue-green deployment. With a blue-green deployment, we deploy a new version to a separate environment, and then we swap the CNAMEs of the two environments to redirect traffic to the new version. Okay, I've signed into AWS Management Console and navigated to my Elastic Beanstalk console. I've got the environments page open. Now what I'm going to do is I'm going to select webapp-dev, and I'm going to expand actions by clicking the down arrow, and I'm going to select clone environment. Okay, scrolling down, the new environment name will be called webapp-prod, and the description will leave as is, and the rest of the settings are fine. We'll just click clone. Okay, so now the environment is being cloned. We'll just wait for this to finish, and then we'll add a new application to it. While we're waiting, let's go down to the taskbar. I'll click the Visual Studio Code icon to bring up Visual Studio Code. And so here's what I've done. In the index.html file, I've modified line 38 to have a background color of blue instead of green. It was previously green, but now I've set it to blue. And that way we can distinguish between the two applications. Now I've also taken the time to zip this up in a file called webapp-bundle-v2.1-blue.zip. Okay, so now let's go over to the browser again. So I'll click the browser icon in the taskbar. And now it's just a matter of waiting until the cloning operation completes. Now it reports that the environment webapp-prod has successfully launched. So in the breadcrumbs at the top, let's click on environments. Okay, so now we have our 3 environments. So I'll click to bring up the web app-prod environment. I'll click upload and deploy. I'm going to click choose file. I'm going to choose web app-bundle-v2.1-blue.zip and click open. And I'll click deploy. Okay, so now that's deploying to the web app-prod environment. Okay, now that's complete. So let's click on the URL to open in a new tab this new blue version. And we see the background is blue. Let's go back to the environments page. So I'll click on the dashboard tab and I'll click environments. And I want to take web app-dev and look at its deployment. So let's click the URL for web app-dev. So I'll click it with the middle mouse button to open this in a new tab. Okay, so there's our green deployment. So green deployment is old, blue deployment is the new deployment that we just made. Okay, now clicking on the Elastic Beanstalk environment tab. Now click to select the production environment web app-prod. And now click the down arrow beside actions. And now I'll select swap environment URLs. So what happens is Elastic Beanstalk swaps the CNAME records for the 2 different environments. So it redirects traffic from the new version to the old version and from the old version to the new version. Okay, so let's go ahead. We'll select swap environment URLs and make note that there is a warning. Swapping the environment URL will modify Route 53 DNS configuration, which may take a few minutes. Okay, so now scrolling down, the environment name is web app-prod. Now we're going to swap that with another environment. So under select an environment to swap, I'll click the down arrow under environment name and I'll select web app-dev and I'll click swap. Okay, so now the swap is happening. Now, generally this can take a couple of minutes. So let's go back now to the Elastic Beanstalk tab for our green dev environment. So if I refresh, lo and behold, it's now blue. And if I refresh the production version, we'll see now that it is green. Okay, so we've successfully performed a blue-green deployment on AWS. In this demo, we'll work with versioning in Elastic Beanstalk. Okay, I've signed into AWS Management Console and I've navigated to the Elastic Beanstalk console. I've navigated to Applications and I have one application. Now I'm going to click to open the application. Now in the left navigation pane, I'll click Application Versions. So for this application, I have 6 versions. Now, Elastic Beanstalk allows you to store up to 1,000 application versions. Once you reach this limit, you'll no longer be able to deploy. However, you can utilize a lifecycle policy based on the age of a version or the number of versions, and that will allow you to effectively and safely purge old versions. There's also an option not to delete the source bundle when deleting versions, and that way there's always backup. Okay, now to enable a lifecycle policy, click Settings, and now in the Application Version Lifecycle Settings dialog, click the Enable checkbox to enable the lifecycle policy. Now, as mentioned, in the lifecycle rule section, we can limit the application versions by total count. Right now, that's at 200, or we can set the application versions by the age of the version. Note also under retention that by default, we retain the source bundle in S3. Click the down arrow. I can also select to delete the source bundle from S3. And the service role is AWS-Elastic Beanstalk-service-role. Okay, I'm going to cancel this actually. So I'll click Cancel. Now, we deploy applications into environments. So all of these different application versions have been deployed on a specific environment. So if I click to go to one of the environments, say for example, in the left nav menu, I click web app-dev. I could click upload and deploy, and in the upload and deploy dialog, click choose file. And scrolling down, I'll click web app-bundle-v3. I just zip that one up, and I'll click open. Okay, so now notice something. At this point, the version label has automatically incremented to 2 for us. So right now I have a web app-v2.1-1. So I'll click to cancel here, and let's go back out to our application version. So I'll click application versions in the left nav menu, and note that here's our web app v2.1-1. Now that -1 counter was automatically added when I didn't specify a particular version label as well, just like web app-v2.1, the original, and web app-source-1 and web app-source. So if you don't explicitly set a version label and you have a prior version, then Elastic Beanstalk will increment that version automatically for you. So you will never have 2 versions with the exact same version label. In this demo, we'll clean up resources used by AWS Elastic Beanstalk. Elastic Beanstalk creates an Amazon S3 bucket for each region where we create environments. We'll look at that shortly. For now, let's start by deleting our application versions. So I've signed into AWS Management Console, and I've navigated to my Elastic Beanstalk console, and I'm on the Applications page. On the All Applications page, if I click the application name, that opens the Application Environments page for this application, named Web App. So I have 3 environments here. I have the dev, prod, and test environments. Okay, now in the left nav menu, let's go to Application Versions by clicking Application Versions. And on the Application Versions page, as expected, we see all the application versions associated with Web App. Now I want to delete all of these application versions. So I'll click the checkbox in the title bar. I'll click the Actions drop-down and select Delete. Now a message appears notifying of the application versions that will be deleted. Note the Delete Versions from Amazon S3 checkbox is checked, so I'll leave that checked. And I'll select Delete. And Done, so I'll click Done. Now in the left nav menu, I'll click Environments. Now with the environments, I'll have to check to select an environment one at a time, point to Actions, and select Terminate Environment. Then in the Confirm Environment Termination dialog box, I'll have to enter the name of the environment to confirm that I want it deleted. So I'll type web app-dev in this case and click Terminate. Okay, and Elastic Beanstalk goes and starts the process of terminating the environments. Now I'll go back to environments. I'll do the same thing with production. And test. Okay, and after some time, it will terminate the environments. Now, while we're waiting, let's go over to the S3 service. So I'll click Services, and under History, I'll select S3. Okay, so here are the Elastic Beanstalk S3 buckets that were created for my account. The bucket name is formatted as Elastic Beanstalk dash region dash account ID. So for example, I have Elastic Beanstalk dash US dash West dash 1. So the US dash West dash 1 is the region, and the account ID follows. Now, drilling down into this bucket, I'll see that not all resources were deleted. So my source bundle is still here. If I click the Permissions tab, and then I'll click Bucket Policy, scrolling down in the policy, I'll see that the S3 delete bucket action has the effect of deny. So in order for me to delete all the objects in this bucket and the bucket itself, I'm going to have to delete this policy, or at least remove the deny effect with respect to the S3 delete bucket action. To simplify things, I'll just delete the entire policy. So I'll click delete, and in the delete bucket policy dialog, I'll click delete. And now if I go back to Amazon S3 and click the checkbox beside the bucket, I can click delete. And in the delete bucket dialog, I'll specify the name of the bucket. So I'll just copy that. By highlighting it, right-clicking, selecting copy, and now I'll paste that into the confirm field and click confirm. And now that S3 bucket has been removed. Now the essence here is that Elastic Beanstalk uses these S3 buckets to store objects required for our applications, and when terminating an environment or deleting an application, Elastic Beanstalk will delete most of the associated objects from Amazon S3. However, to ensure that we minimize storage costs, it's important that we routinely delete objects that our applications don't need. And this means paying particular attention to objects that we must manually delete, like source bundles, rotated log files, and saved configurations. So, in this course, we've examined the AWS Elastic Beanstalk service and how to work with the deployment options that it offers. We did this by exploring how deployments are orchestrated on AWS Cloud and how Elastic Beanstalk is used to deploy applications to AWS. By exploring the differences between Elastic Beanstalk CLI and the AWS CLI, we explored how to install and use the Elastic Beanstalk CLI, how to create an Elastic Beanstalk web server environment in the CLI and in the AWS Management Console, and we looked at the different deployment modes utilized by Elastic Beanstalk. We explored how to configure Elastic Beanstalk deployments and work with EB extensions. We looked at how to use Elastic Beanstalk to perform a blue-green deployment, and we also explored how to use Elastic Beanstalk to update application versions and to modify an environment's configuration. In our next course, we'll move on to explore how to implement continuous integration and continuous delivery, or CI/CD, using AWS developer tools, including CodeCommit, CodePipeline, CodeBuild, and CodeDeploy. In this video, we'll explore how continuous integration and continuous delivery is implemented in AWS Cloud. CI/CD is continuous integration and continuous delivery. It's a software development practice that allows for rapid software changes while preserving system security and stability. CI/CD is critical to the delivery of software features in a rapid and reliable way. AWS offers CI/CD capabilities as a collection of developer services in AWS CodePipeline, CodeCommit, CodeBuild, and CodeDeploy. A common misunderstanding regarding continuous delivery is that it deploys every committed change to production as soon as all automated tests have been completed and passed. But the focal point of continuous delivery is not to apply every change to production instantaneously. Rather, it's to ensure that each change is ready to go to production. Prior to deploying any change to production, however, a decision process is applied which ensures that the production deployment has been properly authorized and audited. This final decision can be made by someone with the responsibility to do so, and then the deployment can be executed by the tooling. In this manner, the decision to go to production is a business decision rather than a technical one. Technical validation working this way naturally occurs, though, every time a commit is made. Let's consider how CI/CD is realized with AWS Code Services. To start, we leverage AWS CodePipeline to create a CI/CD pipeline, integrating a variety of sources, tests, deployments, or other components. AWS CodePipeline then can use AWS CodeCommit as a source, which at the commit level is the initialization point for the deployment process. Then, AWS CodeBuild enables code and packages to be collected from various sources in order to create build artifacts in a publishable state. And finally, AWS CodeDeploy allows the deployment of compiled artifacts to infrastructure. Also note that AWS CodePipeline is capable of not only deploying application code, but can also provision, configure, and manage the very infrastructure that is deployed on. Using the collection of AWS code services to provide an enterprise with CI/CD capabilities carries with it many benefits. First, it effectively reduces manual effort necessary for ensuring that code changes are fully tested prior to being released. When tests are automated, it means that they're consistently executed against each and every change made to the source. It also liberates developers from unnecessary manual tasks so that they can focus on developing software. That is, we're talking about improved developer productivity. It means that developers can check in code changes, and those code changes are automatically built and tested as part of an automated build test process. Another benefit is improved code quality, since changes are automatically tested immediately after check-in, and this means that more bugs are identified very early in the development process. Finally, changes are delivered faster with improved quality, reliability, and overall quicker turnaround to market. In this video, we'll explore the AWS CodeCommit version control service. AWS CodeCommit is a source code version control service for hosting private Git repositories in a cloud-based, highly available, and redundant manner. Benefits include the fact that encryption is automated both in transit and at rest. CodeCommit repositories can scale as required to securely and reliably handle rapid release cycles and sizable repositories. CodeCommit is integrated with various other AWS services, including identity and access management, enabling complete access control with IAM users, roles, and policies. And CodeCommit supports security connectivity with HTTPS and secure shell connectivity. Now, some AWS CodeCommit concepts. First, AWS CodeCommit uses AWS credentials to authenticate and authorize requests. When connecting to a Git-based repository using HTTPS, a username and password are required. These are passed to the repository when a request is made. In order to use CodeCommit with HTTPS credentials, those user credentials must be added to an IAM user that has permissions to access the repository. You configure a Git or CLI application to use the repository's HTTPS endpoint and the IAM user's username and password. When using SSH authentication, it means you don't need to install the AWS CLI to connect to a repository, but there are some additional configuration steps. First, the IAM user account must have the ability to manage their own SSH keys, and this requires that the IAM user SSH keys managed policy is added to the account. Then it's a matter of uploading the public SSH key and updating the SSH configuration on the workstation. Both of these HTTPS and SSH authentication methods rely on credentials over and above the IAM credentials. However, you can also use IAM credentials and AWS CodeCommit credential helper to authenticate to AWS CodeCommit. The credential helper works by translating IAM credentials to a format that AWS CodeCommit can recognize in order to perform Git-related actions. AWS CodeCommit integrates with development tools that support IAM credentials, and some of the popular IDE tools supported include AWS Cloud9, Visual Studio, Eclipse, and IntelliJ. AWS CodeCommit repository supports notifications which can be used to leverage other AWS services, and triggers, which offer similar functionality to webhooks that are utilized by other Git providers, for example, GitHub. Cross-account access is supported for scenarios where the repository exists within a separate AWS account, but additional configuration is required. In the repository account, a role must be set up with a policy for accessing the account and allowing users to assume that role. And in the user account, a policy must be assigned allowing users to assume the role created in the repository account. In a Git environment, branches are used to organize and group commits. Changes can be separated into logical groupings based on whatever feature or bug fix is being developed under that branch, or for a specific environment like dev, test, or production. The default branch defines the base branch when the repository is cloned. A commit is a point-in-time change applied to content in a repository. It's a way to track changes to a file, including the person who made the change, when it was performed, and any changed lines in the file. Files are objects under version control by AWS CodeCommit, which tracks modifications made to the file line by line. The Git client is used to push changes made to a file to the repository, and these changes are tracked along with any previous commits. Now, pull requests enable developers to review and merge code changes between branches. Pull requests, in contrast to branch merging, provide a way for multiple users to comment on any changes before they're merged with the destination branch. For example, say we create a new branch off the default branch for a specific feature. We make the changes to the files in the branch, then we commit and push them to the remote repository. At that point, we create a pull request for the changes in order to have them integrated with the default branch. Now, other users can view the changes and provide comments. Now, let's consider AWS CodeCommit migrations. CodeCommit supports migrations from existing Git repositories by creating a new repository, cloning the project to a local workstation, and then pushing this repository to CodeCommit. To migrate unversioned content instead of cloning a project, you create a new Git project by running git init in the directory containing the unversioned files in order to initialize the directory as a Git project, and then using git add dot to add all the files. The changes are then committed and pushed to CodeCommit. AWS CodeCommit also supports the migration of sizable repositories by supporting incremental migration. This mitigates any network connection issues that may arise when migrating very large repositories. In this demo, we'll create a source code repository in AWS CodeCommit. I've signed into AWS Management Console with my developer account. Now I'm going to navigate to CodeCommit. So in Find Services, I'll start typing CodeCommit. And when the results list returns CodeCommit, I'll click on it to take me to CodeCommit. Okay, now on the CodeCommit page, notice in the left nav menu that I have access to all the developer tools right here. I've got CodeCommit, but I've also got CodeBuild, CodeDeploy, CodePipeline, as well as CodeArtifact. Now, under CodeCommit, I have no repositories. So let's click Create Repository. Okay, now we'll give our repository a name. We'll call it Web App. And for a description, we'll say My Web App Repo. We won't add any tags at this point, so let's just click Create. Okay, now on the web app repository page, note how connection steps is expanded. So we've got connection steps right here. If I click SSH, it's the same thing for SSH, and for HTTPS Git remote code commit, same thing. We've got our steps right here. So let's collapse connection steps because we're not going to do that right now. Okay, and now for my web app repository, right now it's an empty repository. So if I click Add File, I can either create a file or upload a file. I'll select Upload a File, then I'll select Choose File, and in the File Upload dialog, I'm just going to choose index.html, so I'll click on it and I'll click Open. Now we have to commit the changes to the master, so I'll specify an author name. In the author name field, I'll enter my email address, and I'll specify a commit message. How about my first web app repo commit? Okay, and that's all there is to it. Now let's click Commit Changes and create this first commit. All right, now that redirects us to the code page under repositories where we can see the code for the file that we just added. And note on line 46, the background color is green. Note also at the top of the window, I have the commit ID, and I can view this commit by selecting the View Commit button. Now, in the left nav menu, also under repositories, we've got pull requests. So clicking on pull requests, I'll see that I have none at this point, and we won't create any right now. Now in the left nav menu, clicking commits allows us to view the commit that we just added. So any commits that we perform from here on will be listed here. I have a couple of optional actions. I can browse or copy the ID. I've also got the commit visualizer and compare commits. We won't be using those at this point. So let's go to the left nav menu again, click branches. Now we'll see that we have the master branch, which is the default branch. And recall that branches are used to organize and group commits, and that the changes that we make can be separated into logical groupings based on whatever feature or bug fix is being developed under that branch. So for example, we could create other branches for features we're working on or for specific environments like dev, test, or prod. Right now, we're not going to create any other branches, so we'll leave this as is. Now in the left nav menu, click Git Tags. We haven't assigned any Git tags at this point, so we'll move on to Settings. So in the left nav menu, click Settings. Now on the Settings page, I've got some tabs at the top. I've got General, Notifications, Triggers, Repository Tags, and Amazon Code Guru Reviewer. Under General is the repository name, the repository ID, as well as the ARN. Now click the Notifications tab, and now at this point I have no notifications. So let's go ahead and create one. Let's create a notification rule by clicking Create Notification Rule. We'll give this notification rule a name. Let's call this notification rule Web App Event Notification. Now we have a selection for detail type. We can select full or basic. We'll leave full, the default, selected. Scrolling down under events that trigger notifications. Now it's here that we can choose the events that'll trigger our notifications. So we have comments, we have approvals, we have pull requests, and we have branches and tags events. Let's just click Select All to select all of them. Now scrolling down under targets, we need to create a target to use for this specific notification rule. We can create a simple notification service or SNS topic, or we can choose AWS Chatbot. So let's leave the SNS topic target type selected, and we'll click Create Target. Now in the Create Target dialog, the target type again is SNS topic, and for the topic name, let's use one that's relevant, so we'll call it CodeCommit-Notifications-Web App, and select Create. And now we'll click Submit. And now the notification rule has been created. Okay, let's go back to the left nav menu and click Settings one more time. And now we were just at Notifications. Now let's click the Triggers tab. Now here we can define any triggers. So let's go ahead and select Create Trigger. Now in the trigger name field, we'll specify Web App Trigger. And we'll click the down arrow to expand the Events dropdown. Notice that we have all repository events, push to existing branch, create branch or tag, or delete branch or tag. These are the events that we can define from here. Let's just select all repository events. Okay, and now for branch names. Now this is optional. If I click the down arrow, I'll see that the only branch that I have right now is master, so I'll select it. And scrolling down, I'm going to choose the service to use, which is Amazon SNS, the simple notification service. For SNS topic, if I click in the field, I can choose whatever SNS topics exist in my account. I'll select the one that we created, CodeCommit-notifications-web app. I can also specify custom data. This is optional. We'll leave that blank and we'll just select Create Trigger. Okay, and now our trigger has been created. Under the Repository Tags tab, we can specify some repository tags. We won't at this time. And then under Amazon Code Guru Reviewer, we can associate this particular repository with Code Guru Reviewer. We won't do that at this point. So let's go back to the left nav menu, select repositories to find that our repository is listed here. Okay, so we've successfully created a source code repository in AWS CodeCommit. In this demo, we'll clone a CodeCommit repository. In this demo, what we're going to do is clone a repository to the local machine. We'll add some files to the project and then commit those changes back to the repository. To get started, I've signed into AWS Management Console and I'm on my IAM Management Console. The first thing that I need to do is I need to set up the proper credentials for my Git user in order to communicate via HTTPS from the local machine to my CodeCommit repository. So under IAM Resources, I have two users. I'll click Users. I'm going to use my jQuery user, so I'll click on my user. And now, if you're just creating a new user, you may need to add permissions. My jQuery IAM user is already a member of the administrators group, so I don't need to do this for this user, but I just wanted to demonstrate how to go about doing this. Click Add Permissions under the Permissions tab. Click Attach Existing Policies Directly, and in the Filter Policies search box, type CodeCommit, and you'll see 3 CodeCommit policies, one for full access, one for power user, and one read-only. Now, again, I don't have to do that because I'm an administrative user, so I'll just click Cancel to get out of here. Now, however, we still need to set up security credentials. So let's click the Security Credentials tab, and scrolling down, I have the ability to use SSH keys for AWS CodeCommit, in which case I would click Upload SSH public key, paste my public key, and then upload that to AWS. I'll click to cancel out of here because this is a relatively complex configuration process. And in fact, AWS recommends using HTTPS and Git credentials for connections to CodeCommit. So from here then, let's create the HTTPS credentials for AWS CodeCommit. And from here, I can generate 2 sets of credentials. I only need one, however, so I'll click Generate Credentials. And in the Generate Credentials dialog, my credentials have been created. I'll click to download the credentials. And in the opening dialog, I'll click OK. So now those credentials have been saved to my local machine. So I'll click Close. Now on my second tab, I've navigated to my CodeCommit repositories page, and I've got my web app repository in the list. What I'm going to do here is I'm going to click the HTTPS link to copy the clone URL to the clipboard. Okay, so now that's done. Now down in the taskbar, I'll click to bring up Visual Studio Code. And in Visual Studio Code Explorer, under the current AWS projects directory, I have a source directory and 3 files. These are the JavaScript related files for my web app. I already uploaded my index.html file for this project using the UI for AWS CodeCommit. Okay, so let's get started then. So down in terminal, I'll type git -- version and ensure that I have a relatively recent version, and I do. To clone that repo, I'll type git clone space, and I'll right click to paste that URL into the terminal. Now pressing enter, and Windows Security asks me for the Git credentials for my CodeCommit repository. Now I downloaded those credentials earlier. So let's go down to the taskbar. I'll click to bring up Windows Explorer where I've opened to my downloads. Now I'll right click, and in the context menu, I'll click Open with Code to open it in Visual Studio Code. So here are my username and password. I will copy them one at a time. So I'll highlight, right click, copy. Now let's click down in the taskbar to bring up the Windows Security dialog. I'll right click and paste my username in. Now I also need the password, so I'll highlight the entire password, right click, select copy. Again, down in taskbar, let's bring that Windows Security dialog back. And in the password field, I'll right click and paste that password in, and I'll click OK. The cloning operation is complete. Now I'll clear. Now if I do a listing, I'll see that I have a web app subdirectory, which didn't exist before. This is the subdirectory that the repository is cloned into. Now, doing a listing of the web app subdirectory shows that I have one file, that's the index.html file, which I copied to the repository when I created it using the CodeCommit UI. Okay, so let's clear, and now let's cd into web app. And again, I'll clear. Now I'll copy the files in the source subdirectory, which is up one level, over to my web app subdirectory that I'm working in right now. And to do that, I'll type cp ... /source *. And now if I do a listing, I'll see that I have brought over app.js, cron.yaml, and package.json. Okay, so now if I type git status, then I'll see that there are 3 untracked files. Now, in order to add those to tracking, I use git add. So that's just git add dot to add everything. And on Windows, you may see this line feed will be replaced by CRLF in the file names, and this is just fine. So I'll clear that. And now again, if I type git status, I'll see that I now have changes that can be committed. So let's clear, and now git commit -m for a message, and for the message I'll type added Node.js related content to repo, and I'll press enter. And Git reports that the master branch has been updated with 3 files. Okay, so let's clear, and now it's just a matter of git push, and it tells us that the CodeCommit repository has been updated successfully. Down in the taskbar, I'll click the browser icon to bring up the CodeCommit repository, and now I'll drill down into my repository. And there are now 4 files managed in this repository. And if I click commits in the left nav menu, I'll see that the first commit, my first web app repo commit, is listed. But here is the commit that I just did, added Node.js related content to repo. All right, so we've successfully cloned a CodeCommit repository and pushed changes to that repository. In this demo, we'll create a pull request in a CodeCommit repository. Okay, I've signed into AWS Management Console, and I've navigated to my CodeCommit repositories page. Now I'll click Web App to open my Web App repository. And the first thing I'm going to do is I'm going to create a new branch. So I'll click Branches in the left nav menu. I'll click Create Branch, and the branch name, Bugfix 0001. And in the Branch From field, click the down arrow and select Master. Now click Create Branch. Okay, so now we have our branch. So now let's click to open this branch. And we see all the files in this branch. So now let's click to open index.html and click Edit. Now generally we don't do this, but just for the sake of this demonstration, I'm going to edit it in line here. So the edit that we'll perform is we'll change the title. Instead of Web App, we'll change the title to My Web App. Now, scrolling down, we want to commit the changes to Bugfix 0001 branch. I'll specify an author name, an email address, and a commit message. And now I'll click Commit Changes. Now a notification appears saying that index.html has been committed to Bugfix 0001. Now I can create a pull request right here by clicking Create Pull Request, or in the left nav menu, I'll click Pull Requests, I'll click Create Pull Request, and for source, I'm going to select Bugfix 0001, and for destination, I'll select Master, and I'll click Compare. And the comparison results in the notification from AWS CodeCommit telling us that it indeed is mergeable. Now, under Details, for a title, I'll just type My Pull Request. And for a description, which is optional, I'll just put Fixed the web app title, please review and merge. And scrolling down, I'll see the changes, and then I'll click Create Pull Request. Okay, so now we have a pull request. Now, at this point, we could view the activity associated with this pull request, any changes. So if I click the Changes tab, scroll down, I'll see the changes that were made. So red means that line was taken out or replaced, and green is the line that replaced it with. Now I can make new comments on changes if I want. I won't do that at this point. What I'm going to do is I'm going to merge these changes. Now I'll click Merge. And now I need to choose a merge strategy. So we'll leave the default, which is fast forward merge, and this is the default strategy in Git anyway. There's also squash and merge and three-way merge. Note also the checkbox, delete source branch after merging. We'll leave that checked because we do want to delete the source branch after merging. And we'll click Merge Pull Request. And success! Bugfix 0001 has been merged into master. So now if I go to my repositories, I go to Web App, I'll look at the index.html file. So I'll click to open it, and I'll see that the change to title has been merged into the master branch. Now in the left nav menu, if we click on branches, we'll see that the Bugfix branch no longer exists because we chose to delete it. Okay, so we've successfully created a pull request and merged that pull request in a CodeCommit repository. In this video, we'll explore the AWS CodePipeline CI/CD service. AWS CodePipeline is a continuous integration and delivery service that automates the build, test, and deploy stages of the software release cycle. You define a release process model, and anytime there's a change in code, AWS CodePipeline automatically builds, tests, and deploys the code based on that model. Several benefits are realized by automating the release process with AWS CodePipeline. First, manual effort is significantly reduced, and when tests are automated, they run consistently against every change to the source code repository. Developers can be more productive because they won't have to focus on anything other than developing software and checking in their source code changes to the repository. Another benefit is improved quality, since bugs are found and addressed as early as possible in the development lifecycle, and it can also result in faster and more frequent delivery updates since everything is automated. Now, let's examine the AWS CodePipeline workflow. When developers commit changes to a source repository, CodePipeline detects the changes, and those changes are subsequently built. Any configured tests are run, and once complete, the build code gets deployed to the staging environment for further testing like integration or load testing. Once those additional tests have completed successfully, a manual approval action is performed. CodePipeline then deploys the now tested and approved code to the production environment. CodePipeline may deploy applications to EC2 instances, using other services on AWS like CodeDeploy, Elastic Beanstalk, or AWS OpsWorks, or it can also deploy container-based applications using Amazon Elastic Container Service, or ECS. Developers can also use the integration points provided with CodePipeline to plug in other tools or services, including build services, test providers, or other deployment targets or systems. In essence, a pipeline can be as simple or as complex as your release process requires. Now let's consider some AWS CodePipeline concepts. First, an action. An action defines a set of operations to perform on application code, also known as a revision, passing through a pipeline. Pipeline actions can be configured to run in series or parallel. Now, these are run sequentially, but if an action does fail, it will not proceed further through the pipeline. The stage containing the failed action may, however, be retried. Valid action types include source, build, test, deploy, approval, and invoke actions, and each action has a specific set of providers. Approvals control whether a particular revision may proceed to the next stage in a pipeline. The revision cannot proceed unless manually approved by an IAM user or role. An approval action is essentially a manual gate that, if passed, allows a revision to proceed to the next stage. But if it's not approved, meaning that it was rejected or maybe it was timed out by CodePipeline, the revision will stop right there. The objective of this type of action is to provide an opportunity for a manual review of the code or to perform any other number of quality assurance tasks before proceeding through the pipeline. Artifacts comprise the set of data worked on by pipeline actions. This includes objects like application source code, dependencies, built applications, templates, and so on. Artifacts may either be produced or consumed by actions, so you could have input artifacts as well as output artifacts. A build action defines tasks that build output artifacts. Tasks like running unit tests and compiling source code. Valid action providers for build actions include AWS CodeBuild, CloudBees, Jenkins, as well as others. A deploy action takes compiled or otherwise prepared assets and installs them on target environments, for example, EC2 instances, serverless functions, or on-prem instances. Valid deploy action providers include AWS CloudFormation, CodeDeploy, Amazon Elastic Container Service, S3, and others. An invoke action executes AWS Lambda functions, providing a means for running code as part of the pipeline execution, which may be used for tasks like backing up data, interacting with third-party products, executing test interactions, or updating IAM roles to provide permissions for new resources. A pipeline represents the general workflow defining how software changes proceed through a release process. A revision refers to the item of work proceeding through a pipeline. A revision could be a change to source code or data stored in a repository, or a change made to an archive version on S3. A pipeline may see multiple revisions flowing through it simultaneously, but a single stage may only process one revision at a time. A source action is triggered when a change is detected in the source, like a commit to AWS CodeCommit. A source action specifies where the source files are stored and where they're updated. When modifications occur to the files in the source repository or archive, it triggers deployments to a pipeline. AWS CodePipeline supports AWS CodeCommit, Amazon S3, and GitHub for source providers. If GitHub is the source provider for CodePipeline, then we must authenticate to GitHub when creating a pipeline. We provide GitHub credentials which serve to authorize CodePipeline to connect to GitHub in order to list and view repositories that may subsequently be accessed by the authenticating account. Best practice recommendation here is to create and use a service account rather than using personal accounts. Test actions are used to run tests on source and compiled code. For example, unit tests run against compiled code or against a running application, and linting runs against source code. Test action providers include AWS CodeBuild, BlazeMeter, Ghost Inspector, and many others. Transitions connect the different stages in a pipeline. Transitions may be manually disabled, halting all revisions in the pipeline once they have completed the stage just prior to the disabled transition. Once the transition is enabled again, the last successful revision resumes. If more than one revision completes before the next stage is available, those revisions are batched. The tasks that must be completed in order to build and execute a simple pipeline include creating a pipeline. We give it a meaningful name and then choose the source. It's at this point that you also select the build provider. This could be CodeBuild, Jenkins, or Solano CI, for example. You also select a deployment provider here, although this is optional if you choose a build provider. Once the pipeline is created, then when you update the source, the pipeline automatically begins to execute. If a pipeline action experiences a failure, you can usually retry that action in the console or using the AWS CLI. It won't be able to retry an action if the pipeline has been modified since the action failed, or if there are other actions in the same stage that are also incomplete, or if a retry attempt is already in progress. In situations where environments exist across 2 or more AWS accounts, a cross-account pipeline can be implemented into a single CI/CD workflow, effectively creating a cross-account pipeline. In this demo, we'll create a pipeline with AWS CodePipeline. To get started, I've signed into AWS Management Console. I've navigated to CodePipeline in my first tab in my browser. In the second tab, I've got my web app-env environment open in Elastic Beanstalk. And in the third tab, I've got my web app repository open in CodeCommit. And we'll examine these as we move along. So let's go back to the CodePipeline tab. Okay, with CodePipeline, we're really starting to get into continuous delivery here. Let's go ahead. We've got no pipelines right now. We'll click Create Pipeline. Now, in step 1, we choose our pipeline settings. We'll give the pipeline a name. So in the pipeline name field, I'll give mine the name Web App Pipeline. We'll allow AWS to create a new service role that will allow CodePipeline to interact with all the other development tools and services like CodeCommit CodeBuild, CodeDeploy, S3, and so on. We'll leave new service role selected. Alternatively, we could choose an existing service role, but we don't have one, so we'll leave new service role selected. Now, the role name is provided for us, and the Allow AWS CodePipeline checkbox allows AWS CodePipeline to create a service role so that it can be used with this new pipeline. So we'll leave that checked. Now, if we expand advanced settings, we won't change anything here, but it's important that you understand the options that exist here. So for example, in Artifact Store, we could choose the default location, which is a default S3 bucket in our account. Leave that selected. Alternatively, we could choose a custom location. And for the encryption key, we'll use the AWS Managed Customer Master Key for CodePipeline. Alternatively, we could choose a customer managed key, but we'll select the default AWS Managed Key option. Okay, scrolling down, click Next. Now in step 2, this is the Add Source stage. This is where we provide the sources for the pipeline. So let's click the down arrow, and we've got several options. We got CodeCommit, ECR, S3, a Bitbucket Cloud in beta, and GitHub. We'll choose AWS CodeCommit here. And this opens up some other options for us. We have to choose the repository name. So clicking in the field, we've only got one repository, that's web app. I'll select it. And for the branch name, again, we've only got one branch, that's master. So we'll select master. Now, scrolling down, the change detection options allow us to choose a detection mode that will automatically start the pipeline when a change occurs in the source. We'll leave the default as it is the recommended option. This is Amazon CloudWatch events. Otherwise, we could choose AWS CodePipeline, which checks periodically for changes. But CloudWatch events happen immediately and automatically. So we'll click Next. Step 3 is the Add Build stage, and this is optional. It's here that we choose the tool to use for the build project. We'll leave this for now, and we'll skip it. We'll see this later in the course. So let's click Skip Build Stage. And in the Skip Build Stage confirmation, click Skip. Okay, now, step 4 is the Add Deploy stage, and this is something we can't skip here because we skipped the Add Build stage. And as the note indicates on this page, a pipeline must have at least 2 stages where the second is either a build or deploy stage. Okay, so let's click the down arrow under Deploy Provider, and we have several options. We have CloudFormation, which we'll see later, CodeDeploy, Elastic Beanstalk, OpsWorks, Service Catalog, Skills Kit, ECS Blue Green, and Amazon S3. We'll choose AWS Elastic Beanstalk because we've already got a couple of Beanstalk environments. Now for the region, we'll leave US East, North Virginia selected. For the application name, click inside the field and select the name of our Beanstalk web app. So we'll click Web App. And for the environment name, we've got 2 environments. We've got a production environment and my original ENV environment, which was the first environment I created when I started working with Elastic Beanstalk. So that's the one that we're going to choose. So let's click on Web App-env, and we'll click Next. Now, step 5 provides us with an opportunity to review the pipeline settings that we've chosen. So under pipeline settings, the pipeline name is Web App Pipeline. The artifact location is a new Amazon S3 bucket. The service role name is provided here. Then we've got the source stage, which is AWS CodeCommit. The repository is web app, and so on. We skip the build stage. And for the deploy stage, we're going to use AWS Elastic Beanstalk, and the application name is web app. The environment is web app-env. Before we create the pipeline, which will kick off the pipeline process, we're going to click the web app-env tab. And now I'm going to click to open this web application in a new tab. And we'll see that the background is blue and the title is web app. Now, over in CodeCommit, which is our source, recall that that's what we selected for our source, and we're talking about the web app repository here, and looking at index.html. If I scroll down, first on line 4, the title is My Web App, and on line 46, the background color is green. So the background color should be green, and the title should be My Web App once we're done with our code pipeline and it starts automatically and updates our version for us. Okay, so let's go back over to Code Pipeline and we'll click Create Pipeline. Okay, and success, the pipeline has been created. As we scroll down, at this point, the source stage hasn't run yet, as it reports as didn't run. And now its status changed from didn't run to succeeded just now. Scrolling down, we'll see that deploy is in progress. Okay, and now our deployment has succeeded. So now if we go back to our web app-env environment in Elastic Beanstalk in the second tab, I'll refresh things, and we'll see that we have a new version, and it comes from Code Pipeline. So now, if we click to open web app-env in a new tab, we'll see that the background is green and the title will be My Web App. Another option is to just go to the same tab that we just had open and we'll refresh it. So I'll click refresh and we see the background is green and the title is My Web App. Awesome. So we've successfully created a pipeline with AWS CodePipeline, and we've watched it do its thing by deploying an application with Elastic Beanstalk. In this demo, we'll use AWS CodePipeline to deploy an application to production with a manual approval action. All right, I've signed into AWS Management Console. I've navigated to my Code Pipeline page for my web app pipeline. Now I've also got a second tab open to code commit to my web app repository, and I also have my Elastic Beanstalk dashboard open with my web app-env environment open. Okay, so back to Code Pipeline. To get started, let's click Edit to edit this pipeline. Now, we have the source and we have a deploy stage. This deploy stage deploys to dev. So we want to deploy to production. So let's click Add Stage below our deploy stage. And for a stage name, we'll call this Deploy to Production. And click Add Stage. Now, scrolling down, I'll click Add Action Group. And for an action name, we'll specify Manual Approval Action. And for the action provider, we have approvals, we have build, deploy, invoke, as well as source and test action providers. We're going to select the first one, which is manual approval. We can also specify an optional SNS topic, a URL for review, comments, or variable namespaces. We'll leave these optional values blank for now, and we'll click Done. Now, that's the manual approval. Now we're going to add an action below that one that is going to actually deploy to production. So we'll click Add Action Group. So these are going to run sequentially, right? So in action name, we'll specify Deploy to EB Production. So this is going to deploy to Elastic Beanstalk in production. And for action provider, we'll click the down arrow to open the list, and we're going to select Elastic Beanstalk. The region is US East. For input artifacts, click the down arrow, and we'll select source artifact, so that's going to come from the source. And the application name is going to be web app, so we'll select web app. For environment name, we'll click in the field, Now we've got two environments here, web app-prod, web app-env. -env is our development environment, so we'll select web app-prod. Now for variable namespace, that's optional, we'll leave that blank and click Done. Now we can review our deploy to production stage, and when we're happy with that, we click Done. Now scrolling back up to the top, let's click Save to save our pipeline. And now in the Save Pipeline Changes dialog, let's confirm by clicking Save. Okay, so the pipeline was saved successfully. So now we have source, we have deploy, which deploys to development. Then we have a manual approval action, which has never run yet. And then we have deploy to Elastic Beanstalk in production. This hasn't run yet because there haven't been any changes to the source that would trigger this pipeline starting. So let's click to go to CodeCommit. And here's my web app repository. And we'll click on the web app repository. This opens up to the code page. We'll click index.html. And now we'll change the title again just to production. So I'll click Edit. And on line 4, we'll remove everything after production. Now scrolling down, commit the changes to the master. So for author name, I'll enter my name. For the email address, I'll enter my email address. And for a commit message, I'll specify change title to production. And I'll click Commit Changes. Okay, and the changes have been committed to master. So now let's go back over to CodePipeline. And now we see that the pipeline has started. So we can see that it's running. So it's now in source. So it's in progress at the moment. Okay, now the source completed. Now the deploy stage. So this deployment will be to development. Okay, and our deploy stage also succeeded. So now scrolling down, I'll see that the manual approval action hasn't happened yet. Okay, now the status has changed and it's now waiting for approval. We'll need to do a review, but first let's go over to the web app-env dashboard tab. And now let's click to open our development environment in a new tab. And we see that the background is indeed red. I changed the background to red in a previous commit. And the title is production. Excellent. So that's development. Now, to deploy this to production, we need to go back to CodePipeline. First, I'll dismiss the success notification, and I'll click Review. And now I'll type code is approved, and I'll click Approve. So now it shows that the manual approval was approved just now, and we see that deploy to Elastic Beanstalk production is in progress. So once that's done, we should be able to go to our production environment and see those changes cascading down to our production environment. So let's go over to our Elastic Beanstalk dashboard. I'll click Environments, and I'll click Web App-Prod Environment. We see now that there's a new running version. Now if I go back to CodePipeline, I'll see that deployment to Elastic Beanstalk production has succeeded. So let's go back to production. Let's go ahead and let's open this in a new tab by clicking on the link, and the background is red and the title is production. So we've successfully deployed an application to production with a manual approval action. In this video, we'll explore AWS CodeBuild Managed Build Service. AWS CodeBuild is a fully managed build service that compiles source code, runs unit tests, and produces build artifacts that are in a ready-to-deploy state. CodeBuild provides pre-configured build environments for most common programming languages and many popular build tools like Apache, Maven, Gradle, as well as others. CodeBuild also allows us to customize build environments to use our own build tools. Other benefits of using CodeBuild include the fact that it is a fully managed service, so there's no need to set up, patch, update, or manage our own build servers, and it also scales on demand to accommodate peak build requirements. Now let's examine how CodeBuild works. We start by creating a build project, which defines the build, including the environment that will perform the build, any tools that will be required in the environment, the build steps, and any outputs. The build specification is a YAML formatted buildspec.yml file that provides the build specification to a build project. We may also have multiple build specification versions. As a best practice, AWS recommends using the latest version if possible. Optional custom environment variables can also be added to build jobs in the form of key value pairs. Phases are mappings that specify what commands to execute during each stage of a build job. When using a build spec file, the commands can be separated into phases like install, pre-build, build, and post-build. An artifacts mapping tells AWS CodeBuild where any output artifacts will be stored. An artifacts mapping is only required if the build job results in actual outputs. We can also configure caching for a build project, in which case a cache mapping in the build spec indicates which files to upload and store on Amazon S3 to be used in subsequent builds. AWS CodeBuild provides prepackaged build environments, and a build environment is basically a Docker image using a pre-configured operating system, programming language runtime, and any other tools that CodeBuild will need in order to execute the build tasks. AWS CodeBuild supports build environments for Android, Docker, Golang, Java, Node.js, PHP, Python, Ruby, and .NET Core. CodeBuild maintains its own repository of prepackaged and pre-configured build environments. We can also use public Docker Hub images or container images from Amazon's Elastic Container Registry. Now, with respect to CodeBuild options, when a build is initiated, CodeBuild copies any artifacts into the build environment. AWS CodeBuild uses Buildspec to run the build process. When builds are run manually, many properties of the build spec may be altered before running the build job, including the build timeout, any environment variables, any output artifacts, including the artifact type, name, or location. Other options include the source branch, version, and git clone depth if using CodeCommit, GitHub, or Bitbucket, for example. And another option is the source version on Amazon S3. In this demo, we'll create and configure a build project with AWS CodeBuild. Okay, to get started, I've signed into AWS Management Console and I've navigated to my developer tools and I've expanded CodeBuild. In the left nav menu, I've selected Build Projects. Right now, I have no build projects, so I'll click Create Build Project. Okay, and the first thing that we need to do is give the build project a name. I will just call it Build Project. And for an optional description, I'll specify test for existence of text on homepage of web app. Now the build badge is optional. We can leave that unchecked. We can also specify additional configuration in the form of tags. We'll leave that as is as well. Now under the source section, the source provider right now is AWS CodeCommit. If I click the down arrow, I see that I have other options like Amazon S3, GitHub, Bitbucket, GitHub Enterprise, and no source. We'll leave AWS CodeCommit selected as our source. For the repository, we have one, It's called web app, so clicking inside the field exposes web app. I'll click to select web app. Now for reference type, we'll leave branch selected. So this is the source version reference type that contains our source code. And it's a branch, right? So that's what we're going to use. So now under branch, we'll click the down arrow and we'll select the master branch. We can also optionally specify a commit ID, which can shorten the duration of the build, but that's beyond the scope of this demo. We'll leave that empty. Okay, scrolling down, we can also specify additional configuration options like git clone depth and git submodules. We'll leave them as is for now. Now, under environment, for the environment image, we'll let AWS CodeBuild manage the image for us, so we'll leave managed image selected. We could alternatively select a custom Docker image. For operating system, click the down arrow. We have a choice of Amazon Linux 2, Ubuntu, or Windows Server. We'll choose Ubuntu. And now under runtimes, click the down arrow. We'll select standard. It's the only option that we have at this point. And for image, click the down arrow. We'll select the most recent image, so standard 4.0. And now for image version, we have options to either always use the latest image for this runtime version, or we can specify a particular image for this runtime version. We'll leave always use the latest image selected. And the environment type is Linux. We could also specify Linux GPU. And under privileged, we'll leave the privileged checkbox unchecked at this point. And now under service role, we'll let AWS create the service role for us. Alternatively, we could choose an existing service role. The role name is populated for us. We have additional configuration options here as well. So expanding additional configuration, we've got a timeout, we've got a queued timeout. We also have a certificate option. By default, do not install any certificate is selected, and we'll leave that selected as well. We could alternatively install a certificate from our S3 bucket. We could also select a VPC that our CodeBuild project will access. We'll leave that at its default, which is blank for now. For our compute infrastructure, we're not going to be performing any tests that are compute intensive, so a 3 GB 2 vCPU compute infrastructure is good. We'll leave that checked. We could also specify environment variables, but we won't do that at this point. We could also specify parameters. We won't specify that at this point either. Now, the build spec. So for build spec, we can use a build spec file, and that's the default, or we could insert build commands. We'll leave the use a build spec file selected. Now, under that, we've got a build spec name, which is optional. So by default, CodeBuild looks for the buildspec.yaml file in the source code root directory. But if we have an alternate location or name, we could specify that here. So we'll leave that empty right now. For artifacts, we can choose no artifacts, or we could click the down arrow and push artifacts to Amazon S3. We won't change that right now. We'll leave no artifacts selected. Note that we could also specify a cache or an encryption key. We'll leave those configuration options as is for now. Now, under logs, we've got CloudWatch logs. So we'll leave the checkbox checked for CloudWatch logs. And now we're ready to click Create Build Project. Okay, and now our build project is created. So we have one build project. Now, under build history, there are no runs at this point. So we can click Start Build from here. So I'll go ahead and do that. I'll click Start Build. And this brings me to the Start New Build page, and I'll click Start Build here. Okay, so the build has started. So we see the notification that the build has started. And it's in progress. If we scroll down, we can see the build log. So we'll just watch the build log as the build project progresses. Okay, and we see that we have an error. YAML file does not exist. So what happened here is that the build project is looking for buildspec.yaml file in the source code root, but it doesn't exist. We didn't create it. So that's why this build failed. So scrolling up, you can see the status failed. And again, from the logs, we can see exactly why it failed. Nevertheless, we've successfully created and configured a build project with CodeBuild. In this demo, we'll create and use a buildspec.yml file to provide the build specification to an AWS CodeBuild project. To get started, I've signed into AWS Management Console. I've navigated to my CodeCommit repositories console. So I'll click the web app repository name to open my web app repository. Now, here's what I've done. I've created a build spec file. So I'll click on the name of the file. Now, this is a Git repository, right? So when I uploaded this, it kicked off the pipeline process, which actually failed. So what I'm going to do now is I'm going to make another modification. I'm going to change line 5, which is Node.js, from 12 to latest. But let's examine what we have here first in our build spec. So first, we specify the version 0.2, and this is the most recent build spec version. Then we have phases. I have my install phase, and what I'm doing here is I'm specifying the runtime version of Node.js. Right now, it's 12. We're going to change that to latest. And the command is echo, and I'm just specifying install latest Node.js. If a command contains a character or a string of characters not supported by YAML, then you have to enclose the command in double quotes. Now, although none of these commands are actually unsupported, I prefer, when I specify an echo command, to enclose the text part, the string, in double quotes. Okay, so that's the install phase. In the pre-build stage, I'm running the npm install command to install node dependencies. Then in the build stage, really, I've got nothing to build. So that's why in line 14, I'm echoing nothing to build here to the console. Now, line 15 is the post build, and here are my commands. On line 17, cat index piped into grep background, because I want to determine where the word background appears in my index file. And then on line 18, I specify build completed on the date, and the date is enclosed in backticks. And then line 19, I specify my artifacts, and the double asterisk / asterisk on line 21 simply means that all the files and folders after the build are going to be considered as the build output, the artifacts. So let's click Edit, and we'll edit line 5 from Node.js 12 to latest. This is an alias, and it will actually default to Node.js 12. Okay, so let's commit the changes to master. So I'll enter my author name, my email address, and my commit message, altered Node.js version, and I'll click Commit Changes. Now this will trigger my pipeline to start. So now let's click on Pipeline to expand Pipeline in the left nav menu and click Pipelines. Okay, and most recent execution indicates that it's in progress. So let's click Web App Pipeline to open it up and see that the source succeeded just now. So right now we're at the first deployment stage, which is deployed to development, or it could easily be deployed to test. Now, once that's done, I have a manual approval gate before deploying to production. And I'm doing that so that I can fire off a manual build. Now, you really want to automate things, but this is just a way to demonstrate how CodeBuild actually works. Okay, so the first deploy is still in progress. Now it's succeeded, and now we're waiting for approval. So now let's go over to Build. So in the left nav menu, I'll click Build and click Build Projects. I'll click the name of my build project, and I'll click Start Build. And on the Start New Build page, I'll click Start Build. I don't want to change any configuration settings. And now my build has started. So scrolling down, I have my build logs. Now, it may take a couple of moments for entries to start accruing in the build log. But if I click Phase Details, I can see that the build was submitted successfully, queued successfully. Now it's provisioning. Reports right now, there are no reports to display. There are no environment variables. and the build details themselves. Okay, so now I'll quickly go back to phase details and see that provisioning succeeded. Now the build process is downloading the source, and that was successful. So everything was successful up to post build. And here's the reason: command execution error. Error while executing command cat index piped into grep background. Reason exit status 1. So there is a problem here, and the problem is actually very obvious. There is no source file called index. It's index.html. So that's why this build failed. So now if I look at a build history, I can see that I've had some builds that failed. I had one that succeeded, right? And this is generally what happens when you're first designing a build project and a build spec, right? Now let's go back to CodeCommit and let's fix that problem in the buildspec.yaml file. So in the left nav menu, I'll click Source. I'll click Repositories. Then I'll click Web App, the name of the repository. I'll click to open buildspec.yaml. I'll click Edit. And now here's the offending line: cat index piped into grep background. So this has to be index.html because we want to examine the index.html file to see where the word background appears, right? So now let's commit our changes. So I'll enter my author name again, my email address, and a commit message. And now before I commit those changes, in the left nav menu, I'll expand Pipeline, and I'll middle mouse click Pipelines to open Pipelines in a new tab. So that way I can follow it. Now, right at this moment, it's in progress. And it's in progress, why? Because it needs the manual approval. So let's drill down into the pipeline. Let's reject the deployment. So I'll click Review. And for comments, I'll specify there was an error in the build spec, and I'll click Reject. We've effectively rejected the deployment to production. Okay, so now let's go back over to my Code Commit tab. Now I can commit these changes, and that will fire off another pipeline process. Okay, so let's click on the Code Pipeline tab, and I'll close this notification. We'll see that source succeeded. So now we're deploying to dev. And now, once again, when that has completed, we'll be sitting waiting for approval. And that should happen momentarily. The deployment succeeded to dev. Now we're waiting for approval. In the left nav menu, I'll click Build. I'll click Build Projects. I'll click on the name of my build project. I'll click Start Build. And I don't want to change any settings, so I'll click Start Build here, and the build starts. Scrolling down, I'll click the Phase Details tab, and note that the build was submitted successfully, the build was queued successfully, it's now provisioning. Okay, so provisioning has succeeded, now it's downloading the source, and things start happening very quickly after this. So I'll click on build logs now so we can watch the build logs accrue. All right, so the build log has now been populated with information. All of my phases have run properly, and everything has succeeded. Now, we can see the command that was erroneous before on line 49, cat index.html piped into grep background. I can see that in my index.html, there are two background entries. So one has background color red, and one has the background color with hex code. So we successfully created and used a buildspec.yaml file to provide the build specification to an AWS CodeBuild project. In this video, we'll explore AWS CodeDeploy Managed Deployment Service. The AWS CodeDeploy service automates software deployments to a variety of compute environments like Amazon EC2, AWS Lambda, Elastic Container Service or ECS, as well as on-prem instances. AWS CodeDeploy scales to match deployment requirements and helps simplify and accelerate the release cycle, avoiding downtime during application deployment and handling the complex details of application updates while eliminating many of the risks related to error-prone manual deployments. Something that's important to fully understand is the concept of a code deploy revision. A revision is a code deploy artifact. A revision contains application files to be deployed as well as an AppSpec configuration file. Application files may include compiled libraries, configuration files, installation packages, as well as other content related to the application deployment. The AppSpec configuration file defines the steps that CodeDeploy will follow as it deploys a specific revision. A revision must include source files and scripts inside a root directory, and the AppSpec.yml file must also be located inside the root directory, but must be located at the root level, not within a subdirectory under the root. Deployment is defined as the overall process of copying content and executing scripts on instances within a deployment group. AWS CodeDeploy supports two types of deployments, and they are in-place deployments and blue-green deployments. An in-place deployment involves having revisions deployed to new infrastructure, and once the deployment succeeds, the new infrastructure replaces the old code in a phased rollout. AWS CodeDeploy supports blue-green deployments. How these blue-green deployments proceed depends on the target compute platform, but essentially involves shifting traffic from the old environment to the new environment. A couple of things to be aware of here. First, on-prem instances don't support blue-green deployments. An on-premises instance is any physical device that isn't an Amazon EC2 instance that is capable of running the CodeDeploy agent and connecting to public AWS service endpoints. The CodeDeploy agent is a software package that, when installed and configured on an instance, makes it possible for that instance to be used in CodeDeploy deployments. One other item of note here is that AWS Lambda deployments are all blue-green deployments. Deployments may be stopped using the CodeDeploy console or by using the AWS CLI. Stopping deployments to EC2 on-prem instances may result, though, in deployment groups being left in an undesirable deployment state. In such scenarios, it may be necessary to roll back to the last good deployment, and this can be configured to roll back automatically. Automatic rollbacks in CodeDeploy are accomplished by redeploying the last good working revision to any instances in the deployment group. Rollbacks may also be performed manually. A deployment group is a collection of instances. Now, when working with Amazon EC2/on-prem instances, instances can be added to a deployment group based on tags or EC2 autoscaling group names. When deploying AWS Lambda functions, the deployment group stipulates what functions will deploy the new versions. Deployment groups have alarms associated with them that trigger automatic rollbacks if a specific number or percentage of functions or instances fail the deployment. Deployment configuration is a set of rules, including what constitutes success and failure conditions for a deployment. The deployment configuration's rules and conditions differ depending on the target deployment platform. EC2/on-prem deployments support in-place and blue-green deployments. Deployments to the AWS Lambda compute platform support shifting traffic using a canary, linear, or all-at-once strategy. With a canary strategy, traffic is shifted in 2 increments, with a certain percentage of traffic shifted in the first increment and the remainder in the second increment. With a linear strategy, traffic is shifted in equal increments, and with all at once, all traffic is shifted from the old Lambda function to the new updated Lambda function simultaneously. In addition, Amazon Elastic Container Service supports canary, linear, or all at once traffic shifting strategies. In this demo, we'll create IAM service rules for CodeDeploy. We must create some service rules for CodeDeploy because CodeDeploy is going to be accessing a number of different AWS services for us. So to get started, I've signed in to AWS Management Console. In the Find Services field, I'll start typing IAM, and I'll click the link to manage access to AWS resources. And this brings us to the Identity and Access Management dashboard. In the left nav menu, I'll click Roles. And in the main work area of the console, I'll click Create Role. Now, the type of trusted entity is an AWS service. So we'll leave the AWS service tile selected. Now, under Choose a Use Case, if we scroll down, we'll find CodeDeploy. So click CodeDeploy, and then we select a use case. We have 3 use cases here. The first option allows CodeDeploy to call AWS services on our behalf. That's the one that we'll use. So we'll leave this selected. But we also have an option to use CodeDeploy with ECS as well as for Lambda. So let's click the first use case and then click Next Permissions. Now this comes with a managed permissions policy. I'll expand it by clicking the arrow beside it. And with Policy Summary selected, if we scroll down, we'll see the services that this policy applies to. So there's CloudWatch, EC2, autoscaling, load balancing, resource group tagging, as well as SNS. Now let's select Next Tags. We won't add any tags, so we'll select Next Review. And for a role name, in the role name field, I'll provide something very meaningful, like CodeDeploy call AWS services role. We'll leave the role description as is, and I'll select Create Role. And that role has been created. Now we need to create a second role. And the second role is going to be for the EC2 service. And this is required because the EC2 instance that we're going to access is going to be running the CodeDeploy agent. So the instance must be able to access S3 in order to grab our code. So we'll need to give it read-only access to our S3 buckets. So let's click Create Role. Again, the type of trusted entity is AWS Service. And under Choose a Use Case, we'll click EC2. This allows EC2 instances to call AWS services on our behalf. So we'll click it and then select Next Permissions. For a policy, let's search for S3. So in the search field, I'll just type S3. And we need read-only access. So let's check the checkbox beside read-only access. We'll select Next Tags, Next Review. And for a role name, we'll give this a descriptive role name as well. Let's call this CodeDeploy EC2 S3 service role. And everything else stays as is. We'll click Create Role. Okay, and now that service role has been created. So now that both service roles have been created, we can now confidently use CodeDeploy to access AWS services on our behalf and to have our EC2 instance be able to access our S3 buckets in order to grab our code. In this demo, we'll install and configure the AWS CodeDeploy agent on an EC2 instance. Okay, I've signed into AWS Management Console. I've navigated to the Instances page on my EC2 dashboard. To get started, I'm going to select Launch Instance. And I'll choose the Amazon Linux 2 machine image. I'll click select. Now I want the free tier eligible T2 micro. So I'll select next, configure instance details. Now, first here we have to choose the IAM role that we created for our EC2 S3 service role. So if I expand the drop-down list for IAM role, I'll select CodeDeploy EC2 S3 service role. And now scrolling down, if you wanted to use a launch configuration using user data, you could do so here by entering a script. That way it would automatically install and bootstrap the CodeDeploy agent. I'll show you what that script looks like. So down on the taskbar, I'll click the Visual Studio Code icon to bring up Visual Studio Code. Now these are the commands that we're going to enter manually. But for user data, if we wanted to, we could use this script, which came from AWS, and that would bootstrap, again, your CodeDeploy agent. But we'll do this manually. So we're going to use the commands in this readme.txt file. Okay, so let's go back to the Launch Instance Wizard by clicking the browser icon on the taskbar. And now I'll select Next, Add Storage. I'll click Next, Add Tags. I'll add a couple of tags. The first tag will be name. And for the name, we'll specify App Server. We'll add another tag, and we'll call this tag Environment. And for the value, we'll specify dev. Now select Next, Configure Security Group. We'll click Add Rule to add a rule for HTTP. So we'll click to expand the drop-down list and select HTTP, and select Review and Launch, then Launch. Now we have to choose a key pair in order to connect to this instance. I'll just select my EC2 key pair. I'll check the I acknowledge checkbox and click Launch Instances. And now that instance is starting, I'll click View Instances at the bottom of this page. And now when App Server comes up, we'll SSH into it and we'll install the CodeDeploy agent on the instance. Okay, and now the App Server has booted up and is running. I'll click the checkbox to select the App Server. I'll click Connect, and we'll just use the EC2 Instance Connect browser-based SSH connection. So I'll select that option and select Connect. Okay, and now we're connected to the server. I'll maximize this window, and to get started, I'll type clear to clear. Now let's go over to Visual Studio Code. So on the taskbar, I'll click the Visual Studio Code icon to bring up the commands that we're going to use. So basically, we're going to update yum packages and then install Ruby. So I'll highlight these two commands, right-click, select Copy. Now down on the taskbar, I'll bring up the browser with our SSH connection into our EC2 instance. I'll press Ctrl-V to paste those commands in. So first, it's updating all the yum packages. Okay, so now that that's done, I can run the second yum command, so I'll press Enter and install Ruby. Excellent. So now I'll clear by typing clear. All right, so now we need to grab the CodeDeploy agent from Amazon AWS.com. So first, I'll type pwd and see that we're in the EC2 user home directory. So I'll type clear one more time. And now we'll use wget to download the install. So that's just wget https://aws-codedeploy- and now the region us-east-1.s3.amazonaws.com/latest/install. And this will download to a file named install right here in this current directory. Okay, and now we have to make the install binary executable. And to do that, I'll first clear, and then I'll type chmod +x:/install. Okay, and now we can run that install. So I'll type sudo /install auto and press enter. All right, now it's clear. And now let's check the status of the service and make sure that it's running. So to do that, I'll type systemctl status CodeDeploy-agent and press enter. And it reports that the CodeDeploy agent is active and running. All right, so we've successfully installed and configured the CodeDeploy agent on an EC2 instance. In this demo, we'll create an application specification file that can be used by AWS CodeDeploy. Our application is going to use the EC2/on-premises compute platform. And so our AppSpec file will be named AppSpec.yml. So that's AppSpec.yml. This file has to be at the root directory of your software application's source code. With the AppSpec file, CodeDeploy decides what to install on our instances based on a revision in Amazon S3 or GitHub, and what lifecycle event hooks we want to have run during the deployment. These hooks are scripts that run during specific deployment lifecycle events. The other thing to recognize is that the AppSpec file must be a YAML formatted file, and again, it must be placed in the root of the directory structure of our application's source code. What we do here is we bundle the completed AppSpec file with all the application content into an archive file, and the bundled archive file, also known as a revision in CodeDeploy, is uploaded to an Amazon S3 bucket or a Git repository. At that point, we can use CodeDeploy to deploy the revision. Okay, I've got Visual Studio Code open, and I've got my AppSpec as well as all of the scripts that I'm going to be calling from my AppSpec file. So the first line is version :0.0. This section specifies the version of the AppSpec file. This is required, and at this time, the only value that's allowed here is 0.0. Now on line 2, I specify the OS, which is Linux. On line 3, I specify files. Now this section specifies the names of files that should be copied to the instance during the deployment's install event. And then we have our hooks. Okay, and in the hooks section here, we specify scripts to run at specific deployment lifecycle events. And an EC2/on-premises deployment hook is executed once per deployment to an instance. You can specify one or more scripts to run in a hook. Each hook for a lifecycle event is specified with a string on a separate line. So for my before install event, basically I'm going to call install dependencies. So let's click on install dependencies.sh tab, and basically I'm just installing HTTPD, which is my web server. Now back to AppSpec. Also in before install, I'm starting the server. So I'll click start server.sh tab, and I'm using system control to start HTTPD. And notice that each script has the shebang, the familiar shebang. Okay, back to AppSpec. Then in application stop, we try to specify a way to gracefully stop the application when we want to update, for example. So for that, I'm calling stopserver.sh, and stopserver.sh is simply using system control. It's first deciding whether or not there is actually a running HTTP daemon. So I specify an is running HTTPD variable on line 2, and using backticks, I'm going to call pgrep HTTPD. So if HTTPD is running, it will show up here as a process. Then I can stop it gracefully. Now back over to appspec.yml, and then for the after install event, basically I'm going to call postdeployment.sh And in all cases, I've set the timeout at 3 minutes or 180 seconds, and I'm using run as root. So now for post-deployment, click the post-deployment tab. And basically what I'm doing is I'm just searching for a specific string, which is defined on line 4, and I'm replacing it with another specific string called str to replace. So I'm going to replace Elastic Beanstalk with CodeDeploy, basically. Okay, and that's all there is to it. So basically, again, your AppSpec file must be named appspec.yml. It must be a YAML formatted file. It must reside in the root of your source directory structure in order for it to work for your deployment. In this demo, we'll create a deployment with AWS CodeDeploy. Okay, to get started, I've signed in to AWS Management Console and I've navigated to the Getting Started page under CodeDeploy. The first thing to do when defining a deployment is to create an application. So I'll click Create Application, and I'll give the application a name. I'll call it My CodeDeploy Application. Now for a compute platform, I'm going to choose EC2/on-premises, and I'll click Create Application. Now on the application page, I'll select Create Deployment Group. Now on the Create Deployment Group page, I'll give my deployment group a name. A deployment group is essentially a group of instances that we want to deploy our application on. So the name I will give mine is CodeDeploy Instances Group. Okay, scrolling down, for a service role, I have to choose the CodeDeploy call AWS Services role that I created previously. CodeDeploy call AWS Services role. Now for deployment type, I'll leave the default in place selected. And for environment configuration, we're going to be using an Amazon EC2 Instances environment configuration. Now, when I check the Amazon EC2 Instances checkbox, it opens so that I can start adding groups of tags for the instances that I want in this deployment group. We are going to deploy to a single instance in dev. And so that machine is tagged with an environment tag, and that environment tag has the value of dev with a capital D. So that's what I'll use here. So I'll click my mouse inside the field, I'll click environment, and the value is dev, DEV. And under matching instances, it reports that there's one unique matched instance. Okay, so for deployment settings, for the deployment configuration, we're going to select CodeDeploy default all at once. This is fine because we're in dev, we've got one machine, and we're going to deploy the code on that one server. So it really doesn't make any sense to choose one of the other options or to go with a custom deployment configuration. All at once will do just fine. For load balancer, we've got a single instance, so we're going to disable load balancing by unchecking the Enable Load Balancing checkbox. And that's all we have to do here. Now we'll click Create Deployment Group. Okay, and now we can create our deployment. So I'll select Create Deployment. And under Deployment Group, I've got the CodeDeploy Instances group that I just created, selected. Now, under revision type, the application is going to be stored in Amazon S3. And right now I have to go and grab that revision. So I've got another tab open to my S3 Management Console. So I'll click to select that tab, and I'll click Upload. I'll click Add Files. And I don't have the zipped file here just yet. So I'll select all of the files and folders here except for the .git folder. So I'll click on Scripts, hold down the Shift key, and click on package.json. Then I'll right-click, point to Send to, select compressed zipped folder, and the name I'll give this is my CodeDeploy application.zip. We'll leave that zip file, the archive file, selected, and we'll click Open. Now keep in mind that the AppSpec file has to be a YAML formatted file, and it has to be named AppSpec.yml, and it must be placed in the root of the directory structure of our application's source code. Okay, so now I'll click Upload, and this file is now uploaded to my existing bucket called mycode-deploy-demo-bucket. Now I need the path to this resource, this archive file. So I'll click the checkbox beside it, and on the fly in, I'll select Copy Path. Now I'll go back over to my Code Deploy tab. In the revision location field, I'll right-click and select Paste. And under deployment description, I can enter a deployment description if I want. I'm good with just leaving it blank for this demo. And we have some additional behavior settings that we can set, some overrides and rollback configurations, but we're not going to worry about those for now. We'll just click Create Deployment. Okay, and the deployment has been created. Now I'll scroll down and I'll click View Events. We want to watch the events happen. So the application stop event happened, download bundle happened, before install, install, after install, the application start event happened, and the validate service event happened. So all of our deployment lifecycle events succeeded. So our overall deployment succeeded. So now if I go to my EC2 management console, I'll click to select my application server. I'm going to grab the public DNS by clicking the copy to clipboard icon beside it. Let's open up a new tab, and I'll right-click and paste that public DNS, and that brings up our deployed application. And I know this is our deployed application because I replaced Elastic Beanstalk with CodeDeploy. So if I go back over to Visual Studio Code, look at postdeployment.sh, I'll see here that basically I've got a search string defined as Elastic space Beanstalk and a replacement string which is defined as CodeDeploy, and I just replace Elastic Beanstalk with CodeDeploy. So we successfully created a deployment with CodeDeploy. In this demo, we'll create an AWS CodeStar project. To get started, I've signed into AWS Management Console, and I'm going to navigate to CodeStar. And to do that, in Find Services, I'll start typing CodeStar, and when the CodeStar link appears, I'll click it. Now, here we can start a new project. Now, before we do that though, what is AWS CodeStar? Well, it's a service for creating and working on software development projects on AWS. With CodeStar, you develop, build, and deploy applications on AWS within a specific project. In CodeStar, the project essentially creates and integrates all the AWS services for our project development toolchain. AWS CodeStar also provides a number of project templates that define what the development toolchain will look like, including whether it'll have source control, build, deployment, virtual servers, as well as other services. And CodeStar also handles the permissions required for team members so that project owners may easily grant team members with role-based access to a project as well as its associated resources. So it's just a wrapper to make the entire build deployment process easy. Okay, so let's click Start a Project. Now, in the Create Service Role dialog that appears, CodeStar is essentially asking for permissions to administer AWS resources and IAM permissions on our behalf. IAM users, like my user, with CodeStar full access, are going to be able to create and manage CodeStar project resources and grant other IAM users in this account access to those resources. Now, AWS CodeStar asks us if this is okay. And of course it is. We're going to select Yes, create role because we want to make things as easy as possible for us. Now, as an admin user, I already have CodeStar full access. So I can specify, yes, create role. Okay, and now that role is created. Now we choose a project template. We also have a number of different filters that we can apply on the left-hand side. Now, for example, scrolling down, I see a web application with AWS Elastic Beanstalk. Well, this is something we're fairly familiar with. So I'll click to select it. And now for a project name, let's just call this My CodeStar Project. Now, scrolling down, we're asked which repository do we want to use. And we're provided with the opportunity to choose either CodeCommit or GitHub repository. And we have a default repository name. Let's click Next. And now we are presented with a visualization of the code pipeline with the various tools based on the template we chose. So now let's click Create Project. And now we have to specify a key pair. I'll select my EC2-key pair, and I'll check the I acknowledge checkbox and click Create Project. Now, since this is my first time here, I'll specify my display name. I'll just enter my initials, and I have to type my email address. And I'll click Next. And now we have to choose how we're going to edit our code. So we've got access to AWS Cloud9, command line tools. We can also use Eclipse as well as Visual Studio. We'll skip this for now. Okay, and now CodeStar is setting up the project. So this is my dashboard. If I go to the IDE, I don't have any integrated development environments right now, but if I did, I could choose them here. Then I've got a location for my code. Now if I click Code, that's going to open up my repository. So it opens up CodeCommit. I'll click on the CodeStar tab to go back to CodeStar. Now if I click Team, I can add team members here. I've also got extensions that I can add. And if I click on Project, that gives me all of the documentation on my specific project, including the ability to delete the project and a utility to help me connect more tools. So the key takeaway from this demo is that there are two things. One, the user who is going to create team members and add team members has to be an IAM user with administrative privileges. And AWS CodeStar is going to fully manage our entire project for us. And based on the project templates that we define, what our development tool chain will consist of. In this video, we'll explore AWS Cloud9 Integrated Development Environment. AWS Cloud9 is Amazon's Integrated Development Environment, or IDE. It provides a rich code editing experience supporting several programming languages and runtime debuggers. It also includes a very useful built-in terminal. Cloud9 includes a set of tools for writing code and for building, testing, running, and debugging software. The AWS Cloud9 IDE is a browser-based IDE, so we can run it in a web browser on our local machine. With Cloud9, we configure and interact with a Cloud9 environment. A computing resource connects with that environment. Now, this could be, for example, an Amazon EC2 instance, or even one of our own servers. We look at environments in more detail shortly. Now, any work we do is stored in an AWS CodeCommit or other remote repository. An AWS Cloud9 environment describes where we store our project's files and run any tools in our toolchain while developing applications. We can store the project's files locally on the instance or server We can clone a remote repository, for example, an AWS CodeCommit repository, into our environment, and we can work with local or cloned files, or a combination within the environment. Some of the things we can do with Cloud9 include writing code in several programming languages, and we can also work with the AWS Cloud Development Kit. We can work with running Docker containers, interact with code repositories, collaborate with other developers, interact with various technologies, including database and website technologies. We can work with serverless applications, Amazon's API Gateway, and AWS Lambda. We can also leverage other AWS products and services like AWS CodeStar and CodePipeline. Key items that we work with in a Cloud9 IDE include builders, runners, and debuggers. Now, a builder tells AWS Cloud9 how to perform a build on project files. We use a runner to run our code, and we can optionally invoke a debugger as well. We can change the built-in runner to run our code differently than how it was originally defined, and we can create a run configuration to run our code with a custom configuration including command line options, debug mode, environment variables, and the current working directory. Cloud9 also provides the flexibility to create our own builders and runners. Cloud9 provides native support for building, running, and debugging code. Build support is accessed from the menu bar, and we can also add support for tool or programming languages not listed. Run support is accessed again from the menu bar and with the Run button on the IDE's menu bar. And Cloud9 also offers built-in debugging support, which is available through a debugger panel. In the debugger panel, we can create watch expressions, view the call stack, look at local variables, and work with breakpoints. Overall, it's a very comprehensive and sophisticated IDE. In this demo, we'll create and configure an AWS Cloud9 IDE project. Okay, to get started, I've signed into AWS Management Console. In Find Services, I'm going to start typing Cloud9. And when I see the relevant link appear, I'll click on Cloud9. And that brings me to the Cloud9 homepage. So let's go ahead and click Create Environment. And now we'll set up the environment by specifying an environment name. Let's just call this Cloud9 ENV. And we can enter an optional description here. Now let's click Next Step. Now, we choose the environment settings here. So the options are to create a new instance for EC2 or to connect and run in a remote server. We'll leave the default create a new instance for our environment. The instance type, we'll leave T2 Micro selected because it's free tier eligible. Now scrolling down for platform, we have Amazon Linux and Ubuntu Server 18.04. We'll leave Amazon Linux selected. And there's a cost saving setting. So what happens here is we can specify a certain amount of time to auto hibernate our environment and thereby reduce charges. So we'll leave 30 minutes as the default. Now for the IAM role, Cloud9 creates this service link role for us. And this allows Cloud9 to call other AWS services on our behalf. Now we can also specify network settings. We have tags, but we're going to leave those as is for now. Let's click Next Step. And now we can review our environment. And if all is good, click Create Environment. And now Cloud9 goes off and creates our environment. Now keep in mind that it has to spin up a new EC2 instance, so it can take a couple of minutes. Okay, so now our environment is all set up. Now one of the nice things about Cloud9 is that you've got a full-featured interactive development environment along with a terminal, and it's fully integrated with other AWS services. Now at the top we have a File menu, we have Edit, Find, View, we have a Go menu, we have a Run menu. So we can actually change our run and build configurations here. We have additional tools, windowing, as well as support. We can also preview and run our code from here. Now on the right-hand side, we've got our preferences. We've got environment members and group chat here as well. We've also got an outline. We've also got access to Lambda functions here and access to the debugger. And in the debugger, we can specify watch expressions, we can view the call stack, we can look at the value and state of local variables, and we can also work with breakpoints. So all in all, AWS Cloud9 is a very rich interactive development environment that integrates with other AWS services, including CodeStar and others. In this course, we've examined a number of different services in AWS developer tools and how they are used to implement continuous integration and continuous delivery, or CI/CD, in AWS. We did this by exploring how code services from the AWS developer tools are orchestrated to provide CI/CD, how the CodeCommit version control service, including creating and cloning a CodeCommit repository, works. We explored the CodePipeline service, including creating a code pipeline, as well as deploying applications. And we explored the CodeBuild service, including creating and configuring a build project and using a build specification, or Buildspec. We explored the CodeDeploy service, including creating both IAM service roles and an application. We explored how to install and configure CodeDeploy on an EC2 instance and create and configure a deployment with CodeDeploy. We examined the CodeStar service for managing software development projects on AWS, including creating and configuring a CodeStar project. And we explored and worked with the Cloud9 IDE for writing, running, and debugging code. In our next course, we'll move on to explore AWS CloudFormation and how it provides the ability to automatically provision and manage enterprise infrastructure.
AWS CloudFormation. CloudFormation is Amazon Web Services offering in the Infrastructure as Code world. Infrastructure as Code allows us to remove the dependency with deploying and managing our resources. We have a lot less human intervention. So we are going to use CloudFormation in our AWS Cloud to deploy our infrastructure, but the human intervention that do happen are bound using a declarative template syntax. So by using a predefined template and its syntax, you can easily build these templates and then pass objects down to each other. As a result, we can build our networking resources, our compute resources, our storage resources, whatever resources we need to deploy, we can deploy it using CloudFormation. Infrastructure as Code is generally defined as a means of provisioning and managing cloud resources such as compute, storage, networking that are human readable. Whether it's JSON or YAML, they are still human readable. And also very important is that they're still machine consumable. So when we create our human readable templates, we send them to a server and they will provision the resources. So that it needs to be machine consumable as well. AWS CloudFormation provides us this means by using a template. Whether we use a YAML template or a JSON template, we're bound to specific syntax. But with CloudFormation, we can create a template just as code, and we can use the drag and drop functionality and create our diagram, and in the back end it creates our YAML or JSON template script for us. By using these templates, we can create and update and delete our resources, or what we call a stack. So when we create a stack, maybe we create a VPC and the appropriate subnets, and we save that as a stack. We can then update that stack as we need to. If we delete that stack, it'll delete all the resources with it. So it's really a one centralized area for managing our resources, and it's much more streamlined than previous command line or scripts that we would usually run. What are some of the benefits of infrastructure as code? First of all, scalability. We can write our code and template once. We can send it over to a different AWS account and we can run it there as well. So we can write one good template and reuse it over and over as we see fit. Also, security. Infrastructure as a code gives us one main template to create our network ACLs or our security groups, route tables. We can all write that as code as well. So a lot of places, if you would deploy your infrastructure, you would have to set up the security afterwards or in some later steps in your resource provisioning. Here you can integrate your security right in your infrastructure as code. Next, we have stability. If you change something or you added something that you didn't want added, you can always roll back your changes to a previous stack. It's easy to fix when you break things, right? Maybe you choose US East 1, you meant to choose US East 2. It's very easy to go back in the template and change it. And CloudFormation will make that change in your resources for you. It's also transactional. It doesn't only create resources for you, but it also waits for it to start before it moves on to the next step. So a lot of dependencies take place. It makes sure that the provisioning of your VPC works before it starts to provision your subnets and so on. And finally, visibility. You can look at your code and you can see exactly what you're creating. Sometimes it's hard to see all your resources that you've provisioned because they're scattered over the place and there's not a centralized area to see it. But by using CloudFormation and infrastructure as code, you can see everything you're creating just in one human readable script. So what is AWS CloudFormation and what makes it so great? AWS CloudFormation allows us to provision or manage our infrastructure resources in our cloud environment. It allows us to use a common language to describe and provision our resources. It also allows us to use a simple text file to model and provision our resources in an automated and secure environment through multiple regions or multiple accounts. It's also available at no additional charge. You do not pay to use CloudFormations. You're only charged for the underlying resources it creates. Two big benefits of CloudFormation over regular scripts or using the command line to provision resources is that it's repeatable. So I can reuse a template in another environment or in another account. So maybe I want to run a complete hot standby for a disaster recovery scenario. I can take my templates that I've deployed my infrastructure on, bring them over to a different region, and automatically deploy them by using that same template. It's also good for blue-green deployments when you need two environments, exact same, and when you're upgrading to newer versions of your web applications or whatever the case may be. So it's repeatable, which is great for disaster recovery and deployment, and it's also versionable. So the fact that we're using a script means we can use a repository, source code repository, and that does tracking and version changes. So if we make a mistake and we don't like what we updated, we can roll back the stack and redeploy previous version. And it's also a nice little snapshot of your environment and your resources from the beginning right into the future. You can see a running change of your infrastructure through different versions of your scripts. AWS CloudFormation is also great for some of the three-tier hierarchy and some of the applications that has a lot of different moving pieces. One of these would be a scalable web application. So if we're creating a scalable web application, we're going to create a backend database. We're going to create a fleet of EC2 web servers for the front end that will incorporate into an auto-scaling group. And we'll also put an elastic load balancer in front of it so we can redirect traffic to the auto-scaling group. Normally, we would have to create our backend database, then create our EC2 servers, create a launch template, an auto-scaling group, then our load balancer. But by using infrastructure as code, we can create that all in one template. So we can see it all, we can identify it all, and we can launch it all at one time, as opposed to bits and pieces and then tying it all together. We can create our stack, and maybe down the road we realize that we want to change from a Postgres database to a MySQL database. We can change that in our template, and it'll get versioned, and we can deploy it. And if it doesn't work, we can roll back that stack and deploy a previous version. So we've got a lot more options now and a lot easier ways to recover from error. AWS CloudFormation also allows us to quickly replicate our infrastructure. Whether we're replicating for additional availability, we've outgrown our current infrastructure, or for disaster recovery purposes, or for deployment purposes, we can deploy and replicate our infrastructure to multiple regions and multiple AWS accounts. We can reuse the same template. So we create a template in one region or one account, and we can share it to another region or another account. This allows us to deploy our resources very consistent, and we can deploy them repeatedly. So maybe we are deploying a new environment in a blue-green deployment scenario. We can do this repeatedly for every deployment that we go through. AWS CloudFormation also allows us to control and track changes. Because we are using infrastructure as code, it is now considered source code, and we can use a repository to track changes and get better control over our infrastructure. This can allow us to upgrade incrementally, and it also gives us the opportunity to roll back infrastructure. So by using versioning systems, we can roll back to original settings, whether it's a previous version or the original version. By using this version control system, we know exactly what order our infrastructure has grown, and it gives us a snapshot to see how our infrastructure has changed over time. And this version control system uses templates, which are versioned with each change, and that allows us to quickly roll back our infrastructure or upgrade as we see fit. Now let's dig in and look at some AWS CloudFormation concepts, starting with stacks. Stacks refer to a collection of resources that you manage as one single item. Each part of the stack may contain a different layer, which may consist of networking resources or compute resources, database resources. The multiple layers are what makes it a stack, so to speak. You can also delete a stack, which will delete all the underlying resources it created, and you can update your stack to modify your resources. Next, we'll discuss change sets. Speaking of modifying your resources, when the time comes to update your stack, change sets really come in handy. Change sets give you the opportunity to preview any potential changes to your stack before you actually execute it. When you provide a new template or input new parameters, or both, you can quickly see if these changes are what you're expecting or if it will be a disaster averted. You have the ability to update your stack template before you create a change set or as part of the change set creation process. And at the heart of CloudFormation are the templates. Templates are where the structure of CloudFormation is enforced. By giving users the choice of YAML or JSON, we can enforce a human-readable schema and ensure consistency in our templates that will be consumed by machines to provision our resources. Digging a little deeper into AWS CloudFormation stacks, we know that stacks are simply a collection of resources that we manage as a single item. Created from a template, they're used to provision the resources you specify in the template. You can modify a stack by updating the template, or you can provide a brand new template. These modifications will affect your resources, because when you change the template, for example, to remove an EC2 instance, AWS will update the stack, then terminate the instance so the underlying infrastructure meets the requirements in the template. In addition to creating and updating stacks, you can also delete a stack, which will delete all the underlying resources it created. So only use this option if you're 100% sure this is what you want. And always back up your template file. AWS CloudFormation change sets. Many times we want to change our resources, but we're unsure of what the impact may be. Say, for example, we want to make a change to our EC2 instance and remove the DNS support. A change set would give us a summary of our proposed changes and then determine what may possibly be impacted further down the road. The beauty of being able to view our changes before we actually implement them is fantastic. It's a good habit to get into. Even the best cloud developer can accidentally delete a line of code from time to time, and it would be devastating if that line of code was to be a fleet of EC2 servers. Another area where change sets are great are databases. If you wanted to change the name of your database, for example, a change set would let you know that your current database will be destroyed and a new one's created. So in the rare case you don't back up your database, you would now have time to go and do that. But we all have backups ready to go, right? CloudFormation templates can be created in either JSON or YAML. Now, which one should you use? Well, really, a lot of it boils down to personal preference. If you have experience in JSON, then it would be the obvious choice. But if you're new to them both, here are a few things to consider. YAML in the context of a CloudFormation script is slightly easier to read than JSON. This isn't a knock against JSON, as it's often quicker and still interoperable with many more systems than YAML. YAML is essentially a superset of JSON. Nevertheless, YAML has a lot of extras, including comments that can be utilized in our templates. You'll often find that those who program in Python like to use YAML quite a bit because YAML uses indentation instead of brackets to indicate levels. And if you ever program with brackets, you'll understand that a lot of times you open up brackets, but you don't always close them, and it becomes the needle in the haystack trying to find that bracket that you failed to close off. So indentation uses indents, right? We use the tab button on our keyboard, and it's much more easier to read in code. Digging deeper into the AWS template, let's look at some of the components. We know the templates are written in either JSON or YAML, but what are the components that make up the template itself? First of all, we'll start with the description. The description section is designed to allow a developer to provide a textual description of the template's purpose, who created it, and any other pertinent information. The length is limited to 1024 bytes and only supports literal text. Next, we have parameters. Parameters are what can make your CloudFormation template go from good to great. Parameters allow you to provide inputs to your template. Suppose you have a template that launches an EC2 instance. Developers use it for testing various applications. Each developer has different hardware needs, but using a static script, the only way to change the instance size will be to change the underlying template. Using parameters in the template, you can prompt the user to specify an instance size upon stack creation from a pre-populated list. Mappings. Mappings are used in a template to create a lookup table. This is heavily used when mapping regions to AMIs. Your company may want to provide an AMI based on the user's region so that there's consistency across the board with all your users. You can also map an AMI to specific hardware architecture, whether it's 32-bit or 64-bit. So essentially, we're telling CloudFormation to look at our region, then find the region in the map we created in our template, and then map it to the AMI we specify. Next, we have metadata. The metadata section gives you the opportunity to provide more rigid details about the template. For example, you can provide metadata about how the template was created, which parts correspond to certain environments, and this metadata is sent to CloudFormation and can be used and referenced in other parts of the template. Moving on to more template components, the heart of the template components are the resources. Resources are the reason we use CloudFormation scripts. The resources section of the template specifies the actual AWS resources that we want to spin up and their corresponding properties. We follow a standard syntax that includes a logical ID as a resource key and specific subkeys such as type and properties. The type subkey is where we declare the type of resource, whether it's an AWS S3 bucket or an AWS EC2 VPC. And the properties section is where we add our details. For example, where we would add a CIDR block to our VPC. Next, we have conditions. The condition section in the template is used to create conditional statements which will determine when a resource is created or when a resource property is defined. Intrinsic functions are used in our CloudFormation scripts to evaluate specific inputs which are used in our conditions to determine a true or false result. A lot of people use conditions to set an EC2 instance type based on the environment selected via a template parameter. If a user selects production, the conditional statement is ran and the larger instance type is selected. If a developer chooses the dev environment parameter, a smaller instance will be chosen. Conditions, like parameters and mappings, add a degree of sophistication to your scripts. It's also important to remember that a condition can reference input parameters, mappings, or other conditions to determine the true-false value. And finally, outputs. Outputs are values that are output from a stack. These can be referenced in other stacks, nested stacks, API calls, or in the CloudFormation console itself. They're good to provide users with a meaningful information after a successful creation or update of a stack. For example, if a user created an EC2 instance, we may want to output that instance ID so we can use that in other CloudFormation scripts or in nested stacks or API calls. So I hope this video gave you some insight on the AWS template components and what we need to include to provision the resources that we want, and what other things we can use like conditions and outputs and parameters to really make a sophisticated CloudFormation script. And now let's move along into some more CloudFormation advanced concepts like permissions, designer, and metadata. AWS CloudFormation permissions. Any stack option that CloudFormation does based on your template is done on your behalf with the permissions available to you. So they'll use your permissions that's in your IAM user or an AWS role that you assign to it. The CloudFormation scripts will fail if the appropriate permissions are not available. In addition to using your IAM permissions, you can also assign an AWS role. This allows you to restrict what resources can be provisioned based on the authorization of the user or role. As a user, your IAM credentials will be needed to invoke a stack action like create, update, or delete, and it'll also need to have the IAM pass role permission to pass the role to CloudFormation. We can also create a service role that the stack will use to perform create, update, or delete actions. This role will be passed to CloudFormation, which will determine what operations it is allowed to perform. One important thing to note is that if you create a service role, make sure cloudformation.amazonaws.com is added to the trust policy in order to assume this role. Once CloudFormation can assume that role, it can perform the create, update, or delete actions. And it's important to note when you assign permissions for IAM users or AWS roles, you have the ability to specify conditions to control whether policies are in effect. For example, you can allow your users to create instances of only a certain size. AWS CloudFormation transforms. Templates tend to grow in both the number of lines of code and how complex they are. There are times when we'll want to use the same components across multiple templates, such as resources or mappings. By using transforms, we can use a set of macros to save a lot of time with regards to actually writing our templates. By using transforms, a change set is created for the stack, then transforms are applied to the template while the change set is being created. There are two types of supported transforms. The first is AWS Include Transform. The AWS Include Transform acts as a tool to import template snippets from Amazon S3 buckets into the template being developed. As mentioned, when a template is being assessed, CloudFormation creates a change set, and the template snippet that we want to incorporate is copied from the location we specified and added to the template. This can be used anywhere except the parameters and the template format version sections. The transform section will include a name, such as AWS Include, and any parameters such as the location of the S3 bucket where the snippet is located. Our second type of supported transform is AWS Serverless Transform. You can use the AWS Serverless Transform to convert AWS Serverless Application Model templates into the CloudFormation templates. AWS SAM is used to deploy serverless apps with API Gateway, Lambda, and Dynamo database. AWS CloudFormation transforms. Templates tend to grow in both the number of lines of code and how complex they are. There are times when we'll want to use the same components across multiple templates, such as resources or mappings. By using transforms, we can use a set of macros to save a lot of time with regards to actually writing our templates. By using transforms, a change set is created for the stack, then transforms are applied to the template while the change set is being created. There are two types of supported transforms. The first is AWS Include Transform. The AWS Include Transform acts as a tool to import template snippets from Amazon S3 buckets into the template being developed. As mentioned, when a template is being assessed, CloudFormation creates a change set, and the template snippet that we want to incorporate is copied from the location we specified and added to the template. This can be used anywhere except the parameters and the template format version sections. The transform section will include a name, such as AWS Include, and any parameters such as the location of the S3 bucket where the snippet is located. Our second type of supported transform is AWS Serverless Transform. You can use the AWS Serverless Transform to convert AWS Serverless Application Model templates into the CloudFormation templates. AWS SAM is used to deploy serverless apps with API Gateway, Lambda, and Dynamo database. Let's take a look at some AWS CloudFormation intrinsic functions. There are times when some values that we input into our template can't be determined until the stack is created. If we create an RDS instance, for example, we want to take the database connection string that's created and pass it to our EC2 instance through the user data field. The string cannot be referenced until the database is created, so we would need to use an intrinsic function to find this value after the fact. The fn base64 intrinsic function converts an inputted string into its base64 equivalent. The primary purpose of this function is to pass instructions written in string format to an Amazon EC2 instance's user data property, which should be in base64. Next, we have the fn CIDR block intrinsic function. When you create Amazon VPCs and subnets, you must provide a classless interdomain routing block to map a group of IP addresses to your resources being created. This function returns an array of CIDR blocks. The number of blocks returned is dependent on the count parameter that we specify in our declaration. Next, we have find and map. So after you create mappings in AWS CloudFormation templates, you can use the function find and map to query information stored within our mapping tables. Note that mappings have two key levels, and thus top level and second level keys must be supplied as inputs along with the mapping name itself. The getAttribute function, displayed as function getAt, allows us to query attributes from resources we created in our template. For example, if we create an IAM role to use when executing Lambda functions, we must provide the ARN of that role to Lambda so it can assume that role. You can use the function getAtQuery to find this value and present it to Lambda. Next, we have function getAZs. So for each AWS region, different availability zones with different names are available. The specific availability zones won't always match between different accounts. If one account is in US East and another is in US West, then there's going to be different availability zones. So by using the getAZs intrinsic function, we can return a list of availability zones for the region that our account is currently in. fnJoin, in some situations, we'll need to join string values together and concatenate them from multiple input strings. This is where the join function will do that for you. Sometimes when building JDBC connection strings, you'll need to concatenate multiple input strings together, and the join function will do that for you. fnSelect. When you pass values into your template, CloudFormation needs to be able to select these items from a list based on a position. This function allows you to choose an item based on the index. For example, if one of your resources contains a list of parameters, maybe a VPC with a list of popular CIDR blocks, we can use a select to have our template go to the resource and select the CIDR block from the list. fnSplit, or the split function, is counter to the join function. You can use split to create a list of strings by separating a single string by a known delimiter. fnsub allows you to substitute variables in an input string with specific values that you want. So in your templates, this can be used to construct commands or outputs that include values that aren't available until the stack is created or updated. And finally, ref. This intrinsic function will get a lot of use in your template, especially if you have multiple resources that intertwine with dependencies and relationships with one another. You may create a VPC with 4 subnets, for example. When you create the VPC, you'll give it a logical ID. There may be many times throughout the rest of the template that you'll have to reference this VPC logical ID. For example, when you go ahead and create the subnets, you'll have to specify the name of the VPC over and over. Instead, you can tell the CloudFormation script to reference the VPC name given above. So we create the VPC once, we give it a name. Then all the other resources, we just tell it, if you need this VPC name, reference the VPC I created. And finally, some condition functions. So AND returns true only if all contained conditions evaluated are true. FN equals will return true if both compared values are equal to one another, otherwise it's false. FN if will return one of two values depending on whether the specified condition evaluates to true or false, so it's your general if statement. FN not acts as a negation, returning the opposite of the condition, and OR will return true if any of the provided conditions are true. These conditions are much the same as you would use in a bash script or really any programming languages that have conditional functions. A little more about AWS CloudFormation and its built-in metadata keys. The first built-in metadata key that we'll use is AWS CloudFormation init. We use this to include metadata on an EC2 instance that you provision via CloudFormation. So when the template calls the CFN init script, the script reaches out for resource metadata that's stored in the AWS CloudFormation init key. This can be used to install packages on an EC2 instance, create users, or even create files. Next, we have the AWS CloudFormation interface. Have you ever noticed that your parameters display alphabetically by default? This can be misleading to users when they go and launch the stack, and a better option would be to have parameters presented to them in the order they're going to be used in the script. And this is exactly what this interface metadata key allows us to do. And finally, AWS CloudFormation Designer. This metadata section specifies the visual layout and representation of resources when you design templates in the CloudFormation Designer. Since it's only used by Designer, we recommend you don't manually modify this section as it's being used by the CloudFormation Designer. AWS CloudFormation Designer. AWS CloudFormation Designer is a graphical interface that allows us to design and deploy templates. It's web-based, it's available in the console itself, and it gives us the option to drag and drop resource objects. AWS CloudFormation Designer keeps track of resource positions and relationships with metadata information in the AWS CloudFormation Designer. Again, since no other service or component uses this information, it is safe to leave it as it is within your template. In this video, I'll demonstrate AWS CloudFormation, and we'll look around at some of the options and features and build a small stack. So first, we'll go into CloudFormation, and we'll click Create Stack. So we have a prerequisite here. Do we want template that we have already? Would we like to use a sample template, or do we want to create a template in Designer? If the template is ready, our options are down here. Is it located at an Amazon S3 bucket? Or we can upload the file ourselves. There's also many good sample templates you can use. So if we click LAMP stack, for instance, it'll create a Linux, Apache, MySQL, and PHP stack with a single EC2 instance and a local MySQL database for storage. There's also multi-AZ stacks, LAMP stack, Ruby on Rails stack, and a WordPress blog. In our case, we're going to create the template in Designer, and then we'll look at the corresponding YAML code or JSON code after we are finished. So we'll click Create Template in Designer, and it'll load up the CloudFormation Designer. So with the Designer, we can choose our resource types and drag them out, and visualize our resources and look at the template down below. we're going to create a small VPC with a single EC2 instance. So if we come down to our resource types and choose EC2, down at the very bottom, we will see VPC. So we can drag VPC over to the designer, and you'll see that it updates our script automatically. Each component has a tab, and you can also click template to see the view template. So I'm going to come down to our resource. Here's the name that's automatically given. I'm going to call that Tech VPC. Come over, refresh my screen. And under properties, I want to add a CIDR block. So you'll notice that this is in JSON. So we need to use quotes. So I'll say CIDR block, colon, and we'll give it 10.0.0/16. I'll refresh my designer again and validate my template, and the template is valid. Next, we want to add an EC2 instance. So we'll come and we'll drag an instance out into our VPC, and it automatically highlights the name it was given to us. So we can call this Tech EC2, refresh the designer. So with our EC2 instance, the only thing that is required to specify is the image ID. So I'll go ahead and I'll add that change and give it an image ID. So now that I've specified my image ID, I reload again, make sure it looks good. I validate my template. Template is valid. At this point, I've got an option. I can save my template to a local file or an Amazon S3 bucket. I can undo some changes. I can create my stack, or I can close. I'm going to go ahead and create the stack. And it'll bring us back to that first page again. You'll notice that now it says template is ready, and it automatically uploaded my template to an S3 bucket. I click next and give it a name. We'll call it Tech VPC EC2. We have no parameters defined in our stack, and we'll get more into parameters. We click next. Is there any tags we want to add? So here's where we would add any specific tags to track our resources, and we can add any permissions that we want to add. Under advanced options, you'll see some stack policy. Do we have a stack policy created? We can upload. A stack policy will define the update actions that can be performed on designated resources. So if one component fails, should we roll back? Should we carry on? Speaking of rollback, more rollback configuration, monitoring time, so how many minutes of the operation completes that CloudFormation should continue monitoring after it's deployed, and any applicable CloudWatch alarms we've created. We've also got notification options using SNS to send us notifications on the stack, and more stack creation options. Rollback on failure is enabled, so if anything fails, it'll roll back. Timeout being the number of minutes before a stack creation times out. And do we want termination protection? Do we want to prevent the stack from being accidentally deleted? We're going to leave the default values and click Next. It gives us an overview, review everything that we selected in the previous screens. And when we're ready, we click Create Stack. Now you'll notice under Events that the logical ID of my stack is in the status of Create in Progress. If I refresh, now you'll see that the stack is currently Create in Progress. So it went through and it created the VPC, it'll create the EC2, and then when it's all finally done, Create is complete. You can refresh. We've got confirmation that the EC2 and the VPC are created. And if we look under the Resources tag, we'll see that indeed an EC2 instance was created. We can click on it, And it shows us our new EC2 instance that we created using an M1 small because we didn't specify an instance. So if we go back into CloudFormation and click on our applicable stack and back to resources, you'll see the VPC was also created. Under outputs, we had no outputs defined. We had no parameters defined. The template is also here for you to see, and any applicable change sets down the road would be viewable here as well. You can also delete, update our stack, edit our termination protection, view any stack drift, detect any stack drift, or come over and create another stack. Once we're finished, and come back to CloudFormation, you'll see our stack that we created, its status, and now all your resources are created and ready to use. I hope you found this video informative on some of the introductory parts of CloudFormation. And now that you can go ahead and create your own stack, we'll move on to some more advanced topics to see how really powerful CloudFormation can really be. In this video, we'll create a CloudFormation stack using a YAML template. So we'll go ahead and create our stack, and we'll come back to our prerequisites. Again, you can use any editor to create your YAML template, whether it's Notepad or Notepad++. I prefer to use the designer in CloudFormation because I can see and visualize my infrastructure, and I can also validate my templates. So I'll go ahead and click Create Template in Designer, wait for it to load up, and now we have our place to write our template. You'll notice there's two tabs, Components and Template. I'm going to click Template, and you'll also notice there's two languages, JSON and YAML. This comes in handy if you inherit a CloudFormation template in JSON and you wish to convert it to YAML, or vice versa. So it's nice you have a couple options. This time I'm going to choose YAML. You'll see it successfully converted the template. And now instead of dragging my resources out, I'm going to write some YAML code, and then we'll deploy it. So we'll deploy a VPC and one EC2 instance inside that VPC. So we talked about YAML being indentation based. It uses indentations to indicate levels. So our first level, and always make sure you're under template, is going to be resources. We go down and we indentate out, and we indicate a new level, and we're going to create a VPC. We'll call it Tech VPC. Now I need to specify the type. What type of resource is this? So it's AWS, EC2, VPC. You'll notice the single quotes and the double colons in between each item. So I come down, and now we need to give some properties. So I indent out again, and I want to give it a CIDR block 10.0.0.0/16. And we also want to create another resource, our EC2 instance. So we come down under the same level as Tech VPC. And our EC2 instance, we're going to call it EC2 Production. We must specify the type so AWS knows what we're trying to provision, which is EC2 instance. And we also need to specify an image type. What image are we going to use? Is it a Linux distribution? Is it a custom image? So under properties, we must specify image ID. And we'll give that image ID an AMI. And we'll also specify instance type that we want to T2 micro. So at this point, we'll go up and we'll refresh our designer. We'll see our VPC. We'll see our EC2 instance. I validate my template. Template is valid. Now we can go ahead and create our stack. You'll notice the stack has a template uploaded to an Amazon S3 URL. We can call our stack tech VPC EC2. We have no parameters to define. We can specify tags, any permissions, some stack policies if we wanted to define what actions we can perform on what resources. And maybe we can't restart an EC2 and so on, or can't remove an EC2. Some rollback configuration, how long should we monitor it after we create, and some possible CloudWatch alarms. We also have notifications for an SNS or simple notification service topic, and more creations about rollback. Do we want to roll everything back if one thing fails? Do we want some timeout before stack creation times out? And do we want some termination protection? I'm going to leave all these on their default. Here's our review with everything that we selected in the previous steps. And we create our stack. You'll see now that the create is in progress. It has been user initiated. If we refresh, you'll see the VPC resource was created and the EC2 resource was created. We will look at resources. You'll notice the VPC was created. The EC2 is still in progress. And now the logical ID of tech VPC is created. And we're just waiting for our EC2 to be created. And you can always come back to check your resources. Okay, now the EC2 is created. Come back to our events. You can see it is created. And the stack as a whole has been created. So if we come into EC2 now, we should see our EC2 instance running. Here's our EC2 instance running on our T2 micro. So with YAML, again, indentation is good because it helps you indicate levels and it's a little bit easier to read than brackets. I always have issues when I open a bracket and I don't close it, or vice versa. With YAML and indentation, I find it personally a little easier to write these templates. And once you start using it a lot more and understand the resources and the types and the properties and some of the basic schema, it really starts to make a lot of sense, and you can really deploy a lot of resources really quick using a CloudFormation stack YAML template. In this video, we'll explore some of the ways that we can manage, update, and delete our stacks. So I'm going to come into my stack name tech VPC EC2, which if we go over to resources, it consists of one VPC and one EC2 production. So here's where we can really manage our stack. We can delete it here, which will delete all the resources created with it, or we can update it. We also have some drift, so we can detect the drift and view the drift results, meaning like, did this stack change over time? We can also edit our termination protection or import resources into a stack. Maybe we have an S3 bucket that we want to incorporate into our template and use it in our stack. This is how we go about doing that. In our case, we're going to update our stack, and we have three options. Use a current template and make changes to it. Replace the current template with one we already have stored, or edit the template in Designer. So I'm going to go ahead and edit the template in Designer again. You'll see that the URL is an S3 bucket, which is where it was automatically placed when I created the template. So I click View in Designer. And my template is here, consisting of a VPC and an EC2 instance. So in my case, we want to change, maybe our micro instances weren't doing it for us, and we need to scale up vertically to a larger instance. So I'm going to go ahead and change the T2 micro to a T2 large. Validate my script. The script is valid. Now I can deploy the stack. You'll see it still has the Amazon URL. I click next. Same things apply. We're not adding any parameters. We're not changing any of our options. We could if we wanted to. Maybe we created a new SNS topic, or maybe we decided that we want to change our stack policy. In our case, we're just going to click next. We can come down. And here you'll notice one thing. It's called a change set. So it tells me what changes are in this template and stack compared to the original stack. So it's saying I'm modifying an EC2 instance, and the replacement is going to be conditional. So if I view the change set, you'll see my input, my template, and any JSON changes. So it converts it to JSON as well and shows you those changes. So we can go ahead and execute and watch it change. Now you'll notice that it says update in progress, and you get a banner that comes along and tells you this CloudFormation script has been executed. So the update is in progress. The EC2 is actually now being updated. If we come and look at our resources, you'll see the EC2 is being updated. And if we quickly go over to our EC2, we should see our micro being in the process of shutdown. And now it's back up as a T2 large. So it's not a new instance. Our name is still there, but the instance type has been changed to a large. So if we come back to CloudFormation again, and we refresh our page, you'll see the update is now complete. We can click on it. We can look at our events. We can look at the change sets. We can look at our template. So that's an easy way to update resources using CloudFormation stacks. Very easy. Just a few keystrokes. Now what happens if we want to detect any drift? First of all, we'll initiate drift detection. It gives us a blue ribbon above the top. We can close it. And we can click View Drift Results. So drift detection enables you to detect whether a stack's actual configuration differs from its template configuration. So did we create a T2 large and then someone comes behind us and changes it to a T2 medium? Right? So we'll know if the actual resources match our template. And in this case, it's fine. The EC2 production is in sync. The tech VPC is in sync. So it goes back and looks and says, okay, the template says this EC2 instance should be a T2 large. Is it a T2 large? And it is, and it's in sync. And same with the VPC. It'll go out and say, this VPC should have an IP addressing scheme of 10.0.0.0/16. Does it have it? And if we added more properties, it would also check those properties as well. So we'll go back to our stack and we'll finally delete the stack. So when we delete our stack, it explicitly warns us deleting this stack will delete all stack resources. Resources will be deleting according to their deletion policy. So if we made any of them not be able to be deleted, then they would stay alive. But we didn't change any of those, so we're going to go ahead and delete the stack. you'll see that blue ribbon comes up again, tells us the delete is initiated. If we come under events, you'll see the delete is in progress. So this is the logical ID for the stack. This is the logical ID for the EC2 resource, and this is the logical ID for the VPC resource. We refresh, the VPC is now deleted, EC2 is now deleted, and the whole stack is now deleted. So if we come back to EC2, we should have nothing running because it's been removed. And if we come into VPC, we should have no VPCs. I've got my default VPC, the 172.31.0.0, but the one we created with the 10.0.0.0 size 16 is now removed. So the beauty of using CloudFormation is that if I want to delete a VPC previously, I would have to go and individually delete the NAT interfaces, the internet gateways, any route tables that were associated, right? And it becomes a little cumbersome. But when you delete the stack as a whole, it automatically takes care of it for you. So now you'll see my stack is gone. And the only way I can recreate that now is to have that template saved somewhere. So saving your template somewhere in a repository is really good practice, because you may want to spin up another environment just like that down the road. And if you've got scripts available that you can just run, then it'll save you a lot of time. So I hope you enjoyed this video on managing, updating, and deleting stacks. And I hope you can use it to simplify your resource creation and removal. In this video, I'm going to identify some of the resource types that you can deploy with a CloudFormation template. Depending on what your needs are and what type of project you're using, there's a very high likelihood that you can deploy using a CloudFormation template. Some of the resource types that Amazon offers are, for starters, application auto-scaling. So if we want to auto-scale our applications, we can create those resources here. Amazon Athena, if we want to query some data. Also regular auto-scaling for our EC2 instances. We can deploy certificates using CloudFormation templates. We can also create CloudFormation custom resources and macros and other stacks via a CloudFormation template. Under our continuous integration, continuous deployment, we can use CodeBuild, CodeCommit, and CodeDeploy, create projects, store them in repositories, and then deploy these applications to specific deployment groups. We've also got availability to deploy Dynamo database tables via CloudFormation, and on the hardware type of things, the EC2 instances. So here we would create all of our VPCs, including VPNs, route tables, subnets, any internet gateways, and then we can deploy our instances and put our security network ACLs, security groups. So a bulk of the work in the hardware side of things will be done under EC2. We can also create in the Elastic Container repository and the Elastic Container services for our micro-credentials, and our Elastic Container services for our microservices. And under Elastic Beanstalk, we can deploy our application and our environment. Amazon will create it all in the background for us. We specify what we want. This can all be deployed via CloudFormation as well. We also have the ability to do some identity and access management, create users, roles, keys, add these users to groups. We have a lot of IoT and IoT analytics options. Kinesis We can create Kinesis streams and Kinesis analytics. We can also deploy serverless applications and functions, all via CloudFormation scripts. We can do some logging here, as well as CloudWatch logs and CloudWatch alarms. We also have the ability to deploy Amazon Neptune. We can also, if you're looking for a RDS solution, we can deploy that here as well. Redshift, Route 53, S3, of course. We can create buckets, create bucket policies. And we can also create our web access firewalls and workspaces from here as well. So pretty much everything we can possibly use in AWS, we can deploy from CloudFormation. As you can see, as we scroll through, there's just so much that we can deploy. And for most of us, the EC2, maybe Elastic Beanstalk, Dynamo, RDS, IAM, the VPCs, these are the things we want to be able to deploy with CloudFormation scripts. These are a lot of the common uses, but when you get into API development and API gateways and Internet of Things, you can also utilize that here. Your options are nearly endless with the resources that CloudFormation can help you deploy. In this video, I'm going to demonstrate how using parameters can really add a level of flexibility to your CloudFormation stacks, as it creates lookup tables for your user to be able to choose from different options when they deploy their stacks. So normally, if we deploy an EC2 instance, we would hard code the image ID, we would hard code the instance type, right? But now, maybe depending on the user and what they need it for, a user may want a T2 micro instance, or they may want an M1 small instance. They may want to deploy in US East 1A, or they may want to deploy in US East 1C. So by giving your users the options, using parameters, it allows much more flexibility when deploying your resources. So in this YAML template, I have an EC2 instance with an image ID and a VPC with a CIDR block. I could run this now, and it would create my EC2 instance and my VPC. The template is valid. I always like to check for validity of the template before I make any changes. So at this point now, we want to add some parameters. We want to add a parameter for an instance type. We'd like to add a parameter for an availability zone. And we'll add a VPC parameter if it wants to enable DNS support. So the first thing we do is come right back to our first line, make sure it lines up with resources, and we're going to call it parameters. This is where the indentation is very important. You'll get errors if you don't line up these levels properly. So first we want to use an instance type parameter. Its type will be string. Its default value will be T2 micro, but we also have to put in our allowed values. So these are the other values that will show in the drop-down list. Obviously, your default value has to be a part of this, and we can add our other values as we see fit. Once we're done, we can create a description. Say, please select the appropriate EC2 instance type, and we validate our template and move along. So now we want to add a new parameter, so we come back, make sure we're on the same level here, and we're going to call it availability zone parameter. Remember, anything that we can use under our resources as properties, we can also use as a parameter. So image ID, availability zone, anything that we put in as a property of a resource, we can create a parameter for that. So we're going to call it availability zone parameter because availability zone is a property of VPC. And when we add parameter to it, CloudFormation knows that we're going to use it as a parameter. I come down, my type is again string. My default this time, since I'm in the US East region, will be 1A, but my allowed values will also, again, obviously include 1A, but I'll put in 1B and 1C, and I'll put in a description saying please select the appropriate availability zone. And finally, we want to create a parameter for DNS for our VPC. So enable DNS support is a property of the VPC resource. So we'll say parameter. Again, it will be a string. The default we'll say is true. And under allowed values, we'll have true and false. And again, I'll put in my description. And you'll see again how this plays a part when we go to create the stack. Should the VPC allow DNS support for host names? We validate our template. The template is valid. Now we go ahead and launch our stack. We come to our first page. The template is ready. It's automatically stored in an S3 bucket. We click next and we give it a name, parameter example. And first thing we see are our parameters. So we can choose an availability zone. 1A, 1B, 1C, exactly what we put into our template. I'll choose 1B. Enable DNS support parameter. So should the VPC allow DNS support for host names? Again, it's very good to create very good descriptions so your users know what they're choosing. I'm going to say true. And now instance type parameter, please select the appropriate EC2 instance. I'm going to choose an M1 small. I click next. I get all the same values before. I'm going to leave them to default values. Click next again. You'll see the review. You'll see that there's 3 parameters, each doing the key and what the value is. And they'll be passed to CloudFormation to create these resources. So I'm going to create the stack. Create is in progress. The VPC creation is in progress. So is the EC2 instance. If you look under resources, you can see my VPC is being created. My EC2 is being created. Under parameters, here's the key. Here's the value. The EC2 is now created. The parameter example stack as a whole is now created. Now, if I come up to EC2, for instance, and I look for my running instance, it is indeed an M1 small, and it is in US East 1B. We go up to our VPC. We just want to confirm that DNS resolution is enabled because we had set it to true in our CloudFormation script via parameter. So if I come to the VPC I just created, DNS resolution is enabled. So that script, again, could have went multiple ways. Looking back on our template, we could have changed these values to C1 large or M1 extra large. We could have changed these values. We could have changed the allowed values or not had it at all, and it would just accepted the default. So I hope after watching this video you can understand why and how we use parameters, how important they are, and how it gives you options. And it's more dynamic. It's less static templates and much more dynamic templates because you may need an instance type that's different than your colleague. You may need to deploy an availability zone that's different than your colleague. So depending on what stage in deployment you're in. So it's good to be able to have that flexibility and dynamic ability to choose different properties for your resources. In this video, I'm going to show you how we use mappings to match keys to values. This is very useful when, for example, you want to match regions to AMIs, or you want to match specific AMIs to specific architecture, whether 32-bit or 64-bit. So in our example, we want to provide our developers with two different AMIs. We want a Linux AMI for our developers in US East 1, and we want a Windows Server AMI for our developers in US West 1. The developers in the East develop on their Linux machines, and the developers in the West are more .NET developers, and they need Windows Server. We still want to create one CloudFormation stack and one template. So we'll use mappings to look at what region, whether it's US East or US West, and depending on the region, we'll map a specific AMI to them. So in our current template, we have an EC2 instance with an AMI. We also have a VPC with the CIDR block. We still have parameters that we're passing. So we're allowing users to select a T2 micro, a T2 small, or a T2 large. And we're allowing users a parameter of whether they want to turn on DNS support or not. But now we have to incorporate the mappings. So first we have to go back to our top level, type in mappings, come down to our next level, indent, and give our map a name. So we're going to call it region to image map. Next we go down, we tab out one more, and we create our top level key. We call it US East 1. And then our second level key, then we tab down and we specify our second level key, which is going to be AMI. And then we specify the AMI we want the users to use when they launch in the US East region. Another beauty of this is that a lot of these AMIs are long. They're easily to make a mistake on. So by mapping these and taking it out of the user's hands, they'll always get the right image. So next we have to do the same for US West 1. AMI again is our secondary key. Then we type in the AMI that we want the US West users to use. Again, this is going to be a Windows Server machine, so our .NET developers can develop on the Windows platform. So at this point, we've got our mappings created. We've got a map name. We've got our top level keys and our secondary level keys. So the mappings are in place. We validate from here. Template is valid. The last thing we need to do is come up to our EC2 instance and tell it that the image ID is no longer AMI that we've specified statically. Now we're going to get you to actually go find it. So we need you to find it in the map. So we say image ID, find in map, and that tells it to go find that image ID in the map we created. But we obviously have to tell it what map. So it's the region map we created below. I like to copy and paste it so I know I always get it Correct. Then we have to reference our top level key. So we have to tell AWS what is our top level key and go look for it. So in our case, it's region. So we say AWS region. So now AWS will scroll through, look at what region I'm in, and then use the map to map it to a specific AMI. And then we specify our secondary level key, which is AMI. So we validate the template. Template is valid. So we're saying launch an EC2 instance for the image ID. Go find it in the map called region to image map. Reference the user's region, and then in the map, map it to an AMI. And down below, our map is here. Our map name, our top level key, and our secondary level key. So at this point, I'm going to copy and then launch the stack. And we're going to go ahead and we're going to call it Mappings East. We'll allow DNS support, and we want a T2 small. We'll click Next. We'll leave all the default values. Our reviews here, we can scroll through. We'll create our stack. So again, now that we're in US East 1, this template should spin up a Linux machine. So if we look at resources and we click our EC2 instance, even though it's still spinning up, we should be able to see what the image is. So we look down, and sure enough, we have a Linux machine. Now, if we move regions, go to US West 1, we'll come over into CloudFormation, and let's run the exact same template. So I'll go create it in Designer. I'll paste it in from the previous region I ran it in. You can see it's the exact same script. We'll validate it, and then we'll run the stack. Again, the only thing it's checking for is region. We're mapping our regions to an AMI. So even though we still have parameters and we're allowing the user to select parameters, in this case, these have no effect on the mappings. It's just the region we're logged into will be mapped to a specific AMI. So we enter a stack name. So we come over and we enter a stack name. We'll call it Mappings West. We see our parameters here. We click Next. We can accept all the default values. And let's launch the stack. So Mappings West is firing off. We should see the resources. So our EC2 is fired up. And now, unlike on the US East 1, where we had a Linux machine, since this is US West 1, we should have a Windows Server. So when we look, sure enough, we have a Windows Server machine that ends in 868. So if I come back to CloudFormation, you'll see under the template that sure enough, 868 maps to US West 1. So I hope you enjoyed this video on mappings, and I hope you use it to, again, map regions to AMIs or AMIs to 64-bit or 32-bit architecture. It's a great way of making all your AMIs or whatever you decide to use mappings for, a consistency across the board. We're not taking away users' options. We still have parameters here. They can still enter the size of the instance they need, but we're kind of restricting the AMIs so we can keep it consistent across developers all across the organization. In this video, I'm going to demonstrate the use of conditions in a CloudFormation template and to show you how it can give you a level of flexibility that you didn't have before. So in this case, in our example, we're going to provide a parameter to our users with an option of a test deployment or production deployment. We want to create a condition so that if it's a test deployment, we only deploy an EC2 and a VPC, but if it's a production environment, we deploy the EC2, VPC, a new mount point, and a new volume. So as you can see, we have our parameters. We can choose an instance type, an availability zone. We can choose deployment type, which we said is where our condition is based off of. So right now, if I deploy this stack, I'm going to get an EC2 instance, a VPC, a mount point, and a new volume. So we want to create a condition. We want to say if the user chooses production, spin up the EC2, the VPC, a mount point, and a new volume. If they choose test, then we only want the EC2 and VPC. So we can come down under parameters right before we get the resources, and we can create our condition. So I'm going to paste it in, and now we can take a look at it. So first thing we do is we create our conditions, top level key, and then we come down and give it a name. So we're create prod deployment is our name. Then our intrinsic function is an equals function. So fn equals, and now we're telling it to reference the deployment type parameter and bring back true if the deployment type equals prod. So that's great. I can deploy this now, and we still would get all 4 resources because we haven't set up the conditions on the resources themselves. So how do we tell the resources to only spin up if a condition is met? Well, we come down under the resources that we only want to spin up, and then we assign it a condition. And we're going to say your condition on being provisioned is only if the create prod deployment condition rings true. We can do the same for the new volume. Validate our template. And now we're good to go. So the template is now valid, and let's just take a quick look at what we did. So again, we created our conditions that says if deployment type equals production, then this condition is true. And if this condition is true, create the mount point and the new volume because we have a condition value under them. We don't have this condition value under the EC2 instance and the VPC, therefore they'll be created anyway. So let's go ahead and deploy our stack. We can call it conditions. Now let's choose a deployment type. I'm going to choose test. So we don't want the condition to fire. So we'll click next. We'll leave all the default values. You see our parameters are here. We chose test, so we should only get an EC2 instance and a VPC. So we go ahead and create the stack. Create is in process. You'll see our resources are the EC2 instance and the VPC. The VPC is now created. The EC2 instance takes a little bit longer, but you'll see it when it gets created under resources. It is now created, and we have a physical ID. Back under events, our whole stack has been created. And again, we only got our EC2 instance and our VPC because we set the parameter to test. So let's go ahead and update the stack. We're going to use the current template. We aren't changing any code. We're just changing a parameter. And we're going to change it to production. So this should kick off our condition as true. And we should now get an additional mount point and an additional volume. So we click next. We'll see our deployment type is now changed to prod. And you'll see a change set preview. We're adding a mount point and a new volume, so it already picks it up before we even update the stack. So now the update is in progress. The resource creation for the new volume is initiated. The new volume has been created. The mount point is now having creation in progress. Now it's completed. The update has been completed. We can look at the resources. We have an EC2 instance of VPC, and now we have a mount point and a volume because we changed our parameter to prod. If I update the stack again, use the current template again, and change it back to test, we can come down, look at our change set, and now we're removing the mount point and the volume. We can go ahead and update the stack. Once the stack is finished updating, the mount point should be deleted, and the volume should also be deleted. If we come back into our resources, the mount point is already gone, and the volume will be removed as well as soon as the delete is finished. So as you can see, the conditions really add that dynamic layer. You can use different conditions based on a ton of different parameters. We only used one. We just looked at the tip of the iceberg, but you can really create some sophisticated scripts using conditions. So now you can see our update is complete. We're back to our EC2 and our VPC resources, and we are all complete. So I hope you enjoyed this video on conditions, and I encourage you to create some really cool scripts utilizing these conditions and these intrinsic functions. In this video, I'm going to demonstrate how to use outputs in your CloudFormation scripts. The output section allows you to output values from your stack that you can use in cross-stack references, or, for example, just to give out information to the person who created the stack. So I could output an S3 bucket name for a stack, or I could output a DNS name for an elastic load balancer, right? Important information that the user might need to know. We can also create exports, which are optional, but they allow us to export resource outputs for cross-stack references. So let's look at this current stack I have. I have a VPC, I have a public subnet 1, a public subnet 2, and 2 EC2 instances, one in the first subnet and one in the second subnet. So if we come down and we examine our code, we'll see the resources are my tech VPC, which I have a CIDR block, the metadata section for our designer, which shows us where it's to be placed on the designer. I have a public subnet 1, an availability zone, and a CIDR block specified. And I also tell it that if you want to know the VPC that this belongs to, reference the tech VPC I created above. More metadata for the public subnet. Public subnet 2 is there with a different CIDR block and availability zone. And now we have our instances. We give it an image ID and a subnet ID, and we tell it to reference public subnet 1. And for EC2, we tell it to reference public subnet 2. I've also included a load balancer. So my load balancer, I want it spread over availability zones 1A and 1B, and I want it to listen on port 80. I also provide the user with some parameters to select an instance size. And here we have more metadata. So what we need to do now is to specify some outputs. So I want to output the load balancer DNS. And I want to output the 2 EC2 instances IDs. So we can come here under our resources and right before our parameters. And I'll paste in the code and we'll review it. First, I want to make sure the template is valid. It is. We can refresh the designer. Now let's look at the code we created. So we specify output, and then we get into actually creating our outputs. So the output section consists of the key name, outputs, followed by a space and a single colon. Then we can declare up to 60 outputs in the template. So the first output I want is a load balancer, DNS. Its description is the DNS of the backup load balancer, and now we need to find the value. So we use an intrinsic function called getAttribute, and we tell it get the attribute of the load balancer and its DNS name. We come down to our instance ID. We also have a description for EC2 instance 1. And now we're saying the value should be a reference of EC2 instance 1. So we want the instance ID of the EC2 instance 1, and we're telling the value to reference the EC2 instance we created above. We do the same for instance 2, but you'll also notice that we have two exports. So we validate our template one more time, and now we go ahead and deploy our stack. So you'll see template is ready. It's automatically in our Amazon S3 bucket. We can give it a name. We can go ahead and call it outputs. We choose our parameter. We'll choose a T2 micro. We click next. We have some permissions. We're not going to assign it a role. We're not going to get into the rollback configuration. We're going to go ahead and click next. You'll see our parameters are listed here. All the other options we left as normal. And we'll create our stack. You'll see that the load balancer creation is in progress and the VPC is being created. The load balancer is now created. And if we go up to outputs, you'll see we don't have any outputs yet because it hasn't hit that part of the template. We come back to resources. We can see our load balancer is created, the VPC is created, the subnets are being created. The subnets are now created. EC2 instances are now being created in progress. EC2 instance 1 is now complete. The EC2 instance is now complete. And our stack as a whole has been created. So let's go up to outputs, and you'll see we have 3 outputs. The key was the EC2 instance 1 ID, and it returned the value. Here's our description. The EC2 instance ID, here's the value and the description. Here's also the export names. So if we wanted to use a function to import these into a cross-stack reference, this is the export name that we would use. We also have a load balancer DNS name that we have that we can now use to direct our traffic to. So let's go into the template and do a deep dive into what we just created. So first we have to declare our outputs, and then we get into creating our logical ID. So this was our logical ID, load balancer DNS. A description is optional. We don't have to, but it's good for the end user to be able to see what the output is. So we just said this is the DNS name of the backup load balancer. Then we assign it a value. We use the intrinsic function, get attributes. For the load balancer, we want the DNS name. The value is a required field. It can include literals, parameter references, a mapping value, or like we did here, intrinsic functions. Then we come down to our EC2 instances. You'll see we're outputting the EC2 instance 1 ID. Our description, which is optional, but again, it's good to put in, is the instance ID of EC2 instance 1. We're saying for the value, reference EC2 instance 1. So it'll go up to the EC2 instance 1 that we created, and it'll pull the ID from that, and it'll provide it to us as an output. We also want to export this resource output to be able to use it in another stack or cross-stack reference. So we have to give it a name, and we're just giving it a literal name of EC2 instance 1. If we wanted to use that in another stack, we would use a import intrinsic function to import that into our stack. So it's a good way to reuse code snippets over and over again. So a couple things about the export fields. For every account, export names must be unique within the region. You can't create a cross-stack reference across multiple regions. You can use the intrinsic function import value to import only values that have been exported within the same region. And for outputs, the value of the name property of an export can't take advantage of the get attribute or reference functions. So just like we used here, reference for the value, you can't use that reference for a name, or you can't use a get attribute function in the export fields. You also can't delete a stack if another stack references one of these outputs, and you can't modify or remove an output that is referenced in another stack, so they're kind of codependent on each other now. We can also use intrinsic functions like join and sub under the export field if we want to append a domain name or a user ID or an AWS account to any of these values. So I hope you enjoyed this video on how to create outputs, how to use outputs, and how beneficial outputs can be to your scripts and to your end users who run them. In this video, I'm going to go over some intrinsic functions you can use in a CloudFormation script to really maximize the benefits of using CloudFormation and all the dynamic portions that go along with it. So I've got a script developed full of powerful intrinsic functions, and we can dive in and look through them. Then we'll deploy the script and we'll take a look at some of the outputs just to be sure that our functions did indeed work the way they wanted to. So you'll see if I drag down the map, we'll see we've got a VPC, we've got 2 public subnets, 2 EC2 instances. We also have way down below a new volume, a load balancer, and an access key. So I come back to our code, we'll see our VPC, our subnet, subnet 2, and so on. So a lot of these resources and parameters and outputs are using intrinsic functions. So let's browse down through. Under public subnet 1, you can see I use 2 intrinsic functions. I use a select function and a get availability zones function. The select function, we want to be able to select items from a list. So we're really nesting functions here. First, I'm getting the availability zones from my region, and then I'm telling the public subnet 1 to select item 0, which would be the first item or the first availability zone to come back, right? Position 0 in an array. To select that position and assign that as the availability zone. Get AZs will pull back the availability zones for each region that we're in and present them to the select statement, and we're telling the select statement to select position 0 and assign that your availability zone. So we're nesting get AZs and the select functions together. A little further down, when we assign the VPC ID, we're using a ref intrinsic function. So we're saying reference because we got resources. We don't want to keep putting in the VPC ID over and over again. We can just say reference, take VPC ID, and take the info you need from that. We did the same thing for public subnet 2. a nested get AZs inside of a select and a reference detect VPC for the VPC ID. Scrolling down a little further, you'll see on EC2 instance number 2 that I use, again, 2 more functions. The function base64 and the function sub. So the function base64 converts an input string into its base64 equivalent, and we want to use this to pass instructions to an EC2 instance. So in my case, I'm using the user data field, and I'm using the base64 function to encode my secret access key into a base64 so I can pass it to the EC2. I'm using this sub because we want to join string values with a predefined delimiter. So what we're doing is we're saying put in the access key equals and then substitute the actual access key value in. So we're using a sub and a base64. Now my access key comes from down here where I created the access key. So when we come up to the user data field, we're saying substitute and put in access key equals the value for access key. So we've used 2 more functions here. As we go down a little further, we see our load balancer was created, our access key as we saw before, and now we'll also see a new volume. So new volume, you'll notice, has a condition, and the condition is volume needed. So this volume will only be created if the volume needed condition is true. So if we look at the volume needed condition, you'll see I'm using 2 more intrinsic functions. I'm using the fn equals, and I'm using a reference. So what I'm saying is for the condition called volume needed, it'll only ring true if the instance type parameter equals T2 micro. And these are conditional intrinsic functions. I could also use this as a OR function, right? Function OR. So if instance type parameter is T2 micro or M1 large, I can use it as an AND. If the instance type parameter is T2 micro and the architecture is 64-bit, right? So again, these are conditional functions. So I'm saying we only need that volume if our instance type parameter equals T2 micro. So we come up, we look at the properties of our volume, we have a size, 100 gigs, and now look at our availability zone. We're again using another function called getAttribute. So we're saying to get the availability zone to put this in, go and get the attribute of EC2 instances 1's availability zone and place it there. So we're again using another function to get the attribute of EC2 instance 1 called the availability zone and using it as the availability zone to deploy the volume. We scroll a little further down, we can see our outputs. So we're using multiple intrinsic functions down in our outputs. For example, our first output called load balancer DNS, which outputs the DNS name of the backup load balancer. In order to determine its value, we use the function getAttribute of the load balancer, and we want the DNS name. So we're saying get the attribute of the load balancer called DNS name and return it to us. Moving down to the EC2 instance outputs, I've got an output called EC2 instance 1A ID, and we want the instance ID of EC2 instance 1. So we tell the script to go and reference EC2 instance 1 and get the ID. And if we want to export it to a cross-stack reference, we can use a function called join, which will allow us to concatenate multiple strings together to export. So say if we want to export these EC2 instance resources. If we just said EC2 instance ID, it wouldn't make a ton of sense. But so if we use the reference function and reference our stack name and join it with EC2 instance 1A ID or EC2 instance 1B ID, depending on the instance, then it gives us a little more info on that instance and what stack it came from. So we're again using a join and a reference. We do the same thing for EC2 instance 1B. Now we see some parameters and metadata. So our script takes advantage of multiple intrinsic functions. It uses select, getAzs, base64. We've used joins, equals, getAts, and reference. So let's take a look and deploy it. So let's take a look at our map and just refresh it, validate our template, and create our stack. So we'll go ahead and we'll call this stack functions. Now remember, we had parameters, so T2 micro, M1 small, and M1 large. And if we took an M1 small or large, the condition wouldn't be met for the volume. So let's take the T2 micro, leave the default options here. We click next, we'll see our parameter we chose. Again, all the default options. You'll see now you get a little pop-up that says, you're going to create an access key now. So we go ahead and acknowledge and create our stack. Our logical ID stack called functions has been created. The access key has been created. Our load balancer is now created. Our VPC has been created, and now we move on to subnet creation. Public subnet 2 is created. Subnet 1 is created. Now we're firing up the EC2 instances. EC2 instance 2 and 1 are now created. And look at that, our volume is created. So our function did work. The condition fired and the volume was created. Our volume is finished created and our stack as a whole is finished creating. So let's look at some of the resources. So our access key has been created. Our instances have been created. Load balancer, the volumes, our public subnets, and our VPC. So if we take new volume, for example, we should see its availability zone should be the same as EC2 instance 1A, which is US East 1A. So that worked. If we come back into our template again, we can look at EC2 instance 1. And if we go to instance settings, view change user data, you'll see the access key was indeed submitted for us. So we know that worked as well. So we go back to our script one more time and let's look at outputs. You can see the EC2 instance 1A and EC2 instance 1B, the load balancer, and its descriptions. Our export name is here. Functions was the name of our stack, and this is EC2 instance 1A ID and EC2 instance 1B ID. You'll notice these are literal strings in our outputs because we just wanted to know what the stack name was and what the literal name of this EC2 instance was, because we may want to use those resources in another stack somewhere along the line. So we just need a way to identify them. So if we come back to our template one more time, we can see the subnets successfully created its availability zones. We can see the EC2 instance successfully used the base64 and the sub functions to put the access key in the user data. And other functions like get attribute for the EC2 instance 1 availability zone, worked for giving our new volume an availability zone, and our join worked with our exports, and other functions like get attribute and ref were also used. So I hope this video helped you get a good handle on some of the functions you can use and when you would use them. And by using these functions, you can really make a much more dynamic, powerful, and flexible CloudFormation script. In this video, I'm going to show you the rollback feature and how it can be used to roll back your stack creation upon specific events, such as an alarm in CloudWatch, for example. So in our case, I've got a script. It allows the user to spin up an EC2 instance of T2 Micro with enabled detailed monitoring. I also have a VPC with a CIDR block of 10.0.0.0/16. So it's a pretty simple script for our designers to spin up. Problem is, we only want to use no more than 2 virtual CPUs per user account. So we've created an alarm in CloudWatch that monitors our resource usage. And if our virtual CPU number goes up above 2, we get an alarm. So we want to incorporate this into our rollback features. We want to allow our CloudFormation stack to create our resources and then let it wait over a period of maybe 5 minutes to check these alarms. And if our stack creation kicked off the alarm that says we've got too many resources running, then it'll roll back our stack. The reason we let it for 5 minutes is sometimes CloudWatch alarms are only updated every 5 minutes or every 1 minute for timing purposes. So we'll let it run for around 5 minutes, and if the resource count is too high, we'll roll back your stack. So it's a pretty simple stack, and we can do this at resource creation. So I'm going to go ahead and validate my stack, and now I'm going to deploy it. So the template is ready. I'm going to call it rollback. No tags, no permissions. We can look at a stack policy if we wish, but rollback configuration is where we want to go. So specify alarms for CloudFormation to monitor when creating and updating the stack. If the operation reaches an alarm threshold, CloudFormation rolls it back. So how long do we want to monitor for? We said we can allow it to monitor for 10 minutes. And what ARN is the alarm we want to monitor? So mine is called resources used, and again it just monitors the virtual CPUs that are in use under our account. So basically we're selling the stack that if you fire up, you've got 10 minutes to monitor this alarm. If your stack creation causes this alarm to fail, we're going to roll it back again. So under stack creation options, there's also another feature called rollback on failure. So if any part of the stack creation fails, should we roll it back? We can leave it on. If the stack needs to be deployed whole, this is a good option to select. How many minutes do we want to allow a stack before it times out? And should we have termination protection? So we're going to leave our rollback on failure enabled and click next. We come down. We see anything we put in. Now we can see our rollback configuration, how long we're going to monitor, and for how long these, and the ARN of the CloudWatch alarm. So let's go down, rollback on failure is enabled, and we create our stack. It's a pretty quick stack to create. The EC2 instance is already being created. And now it's complete. So you'll see our resources are an EC2 instance and a VPC. And now we just have to give it at least 10 minutes to see if the alarm fires. So I already pre-rigged this so that I already have 2 virtual CPUs running, and this stack should set off the alarm and eventually roll back. So it's just a matter of time within 10 minutes to get the alarm to trigger, and then our stack will roll back. As you can see, once all the resources are created, it doesn't completely sign off on our stack as a whole until that 10-minute threshold has passed and no alarms have been fired. Now you can see that the rollback is in progress. The reason being is that the following CloudWatch alarms were in alarm state, resources used, and the rollback was requested by the user. So the rollback is in progress. While that's happening, let's go take a look at that alarm real quick. And you can see that the alarm has indeed fired. Here's our alarm, resources used. It's in the alarm state because our resources are at 3 and the threshold was at 2, which as a result triggered our CloudFormation rollback. So as you can see now, the rollback is complete. And we can delete the stack if we wish, or we can leave it and go back and delete another stack and redeploy this one. As long as the CPUs are under 2, it'll not kick off the rollback. So I hope you enjoyed this video on the rollback feature. Rollback is a great feature, especially if you need the whole stack deployed as one, or if you want to try to roll back stuff based on alarm breaches, which is great. But it's also good to have version control of your CloudFormation templates, because there will be times when you'll have to do a rollback because the stack will fail and you'll want to revert to previous ones. So you should always keep your templates handy. A good repository of templates combined with rollback ability is a great function of AWS CloudFormation. So in this course, we've examined how to automatically provision and manage enterprise infrastructure with AWS CloudFormation. We did this by exploring how to model and configure AWS resources, CloudFormation concepts such as stacks, permissions, and templates, how to create a CloudFormation stack and work with a CloudFormation template, and how to manage, update, and delete CloudFormation stacks. We worked with CloudFormation resources and specified CloudFormation parameters and mappings for templates, how to define conditions for CloudFormation templates, how to declare optional outputs for CloudFormation templates, and how to work with CloudFormation intrinsic functions and rollbacks. In our next course, we'll move on to explore the concept of configuration as code and how it's provided using AWS technologies, including AppSworks, Elastic Container Service, Elastic Container Registry, and Fargate. AWS configuration as code. At the heart of AWS automation is AWS configuration as code. AWS CloudFormation uses AWS APIs to provision resources and configure your infrastructure via CloudFormation stacks. We can create, update, and delete our stacks, and CloudFormation leverages standard AWS APIs to perform the actions you specify in your template. That being said, there are some configuration that cannot be done via AWS APIs, or they're easier to configure with standard configuration management tools like Chef and Puppet. Chef, along with Puppet, is a DevOps innovator and has become one of the industry's top infrastructure as code tools. The AWS AppsWorks stack give users a serverless Chef infrastructure to configure their servers with Chef code, also known as recipes. It's important to understand that when you separate your infrastructure as code and your configuration as code, you now have the ability to update each at different times, providing you with a lot of flexibility in the change management area. Containerized environments. A container is a micro-sized virtual machine. You have your choice of taking a server and running containers, or a full hypervisor-based virtual machine. A container is simply just an isolated microenvironment. The key part of a container is that the container is entirely self-contained. It's got your program, all the support libraries, all your configurations. It's all in there, so it's going to always work the same. This really simplifies testing and deployment, especially when dealing with pushing stuff dynamically out to the cloud. The Amazon Elastic Container Service, or ECS, is Amazon's managed container service. It's used to run, stop, and manage your Docker containers. You have two options with regards to running your containers. You can use ECS container instances, or you can use the serverless option, Fargate. Both work with ECS. Our first step will be to define our requirements. This will include a task definition, which will in turn be launched as tasks, which are placed into our cluster via schedules. These task definitions is where our configurations are found, such as the container definitions, requirements, and any network settings. AWS CloudFormation can be used to launch ECS clusters, create task definitions, and it fully supports ECS as configuration through code. Now let's discuss AWS OpsWorks stacks. AWS OpsWorks stacks allow you to manage your servers and your applications not only in the AWS cloud, but also your on-premises location. Much like CloudFormation stacks, you can incorporate multiple layers such as load balancers, databases, and app servers. You can spin up EC2 servers, connect them to RDS instances, and set up the appropriate auto-scaling if you wish. OpsWorks stacks also support the ability to run Chef recipes with Chef Solo, which in turn allows you to install packages and frameworks, programming language, and configuration software. AWS OpsWorks is the sole AWS service that performs configuration management. Configuration management helps you to centrally define, in one point, versioned, and even maybe peer-reviewed the exact state of your infrastructure. This is to ensure that our infrastructure adheres to standards. On the top level, it describes things like we have 4 application servers, they're all running on a T2 large instance. In the intermediate level, we describe what these servers need. These 4 app servers need Apache and a connection to an RDS database. On the lowest level, it describes how to install and configure the software and all its packages. So if a server goes down, we know what the server did, we know how to reinstall the application, and we can get it back up and running very quickly. The beauty of OpsWorks stacks is that we can perform configuration management both on-premise and in our cloud environment. OpsWorks has 3 offerings: AWS OpsWorks for Chef Automate, AWS OpsWorks for Puppet Enterprise, and AWS OpsWorks Stacks. First, let's talk about Chef. Chef is open source configuration that's designed for a cloud environment. Chef translates system administration tasks into reusable scripts, otherwise known as cookbooks and recipes. As you know, OpsWorks Stacks has the ability to install and configure packages and deploy apps, and this is accomplished by the use of Chef cookbooks. Puppet is an open source system management tool created for centralizing and automating configuration management. It includes its own declarative language to describe system configurations. This is only available on the third option, Puppet Enterprise. So let's take a look at some of our features and see where they lie with different versions. So in order to manage our infrastructure, our OpsWorks stacks are our only option with that regard. Chef can be used, as we mentioned, with OpsWorks stacks and Chef Automate. Puppet, like we previously mentioned, only works with Puppet Enterprise. But what options allow us to use a code repository? OpsWorks stacks do not, but Chef Automate and Puppet Enterprise do support code repositories. OpsWorks stacks are the only option that supports built-in automatic scaling, although all three options support the Amazon EC2 auto-scaling option. It's just that the OpsWorks stacks has built-in automatic scaling and can take care of a lot of that for you. And with regards to compliance, Chef Automate is the only one that works that into its features to ensure compliance and regulatory acceptance. Now let's take a look at some AWS OpsWorks stack concepts. First, let's take a look at cookbooks. AWS OpsWorks Stacks uses Chef to perform its configuration. Chef itself is not in the scope for the AWS Certified Developer Associate exam, but it's good to know and to tie everything together. Chef is a Ruby-based configuration management language that AWS OpsWorks Stacks uses to enforce configuration management to your on-premise nodes. Cookbooks are normally belong to a repository or a Chef repo, and these are version directories that hold the cookbooks and their recipes. A single repository can hold one or more cookbooks. So when you set up that cookbook repository, upon stack creation, every cookbook in that repository will be copied to each EC2 instance in that stack. So that's something to remember. Recipes consist of the actual configuration we want to implement. They make exclusive use of nodes to execute in their run list. When you assign a recipe to a node's run list, it will execute in the order that appears in the recipe. So it's important to make sure that any prerequisites are executed in the earlier steps. With regards to security, you can also assign recipes to roles, which you then assign to a node's run list. In a typical Chef installation, we usually have one or more servers act as the Chef servers. They are responsible for managing multiple nodes across our company. This server will distribute cookbooks, manage node information, and export data to nodes as the Chef runs. Let's take a deeper look into an AWS OpsWorks stack. First, we need a stack name. Stack name is used to identify our stacks in the OpsWorks Stacks console. This name is not unique. So in order to combat that, AWS will assign a globally unique identifier, or a GUID, to the stack after you create it, which will then make that stack globally unique and you can reference that GUID. Next, we need an endpoint region. Each OpsWorks stack associates a stack with a global endpoint, or one or more regional endpoints. Each stack will only be available for the endpoint that it specifies. If you create a stack with a global classic endpoint, any instances created will only be available by OpsWorks stacks that use the global API endpoint in the US East region. Please be mindful, as this is a very important step. Resources are not available across regional endpoints. Next, we need an Amazon Virtual Private Cloud. Stacks can create and manage instances in Amazon EC2 Classic or an Amazon VPC, a Virtual Private Cloud. The benefit of selecting an Amazon VPC is that you'll be able to specify in what subnets to deploy your instances when they're created. And finally, a default operating system. AWS OpsWorks Stacks supports many built-in Linux operating systems and Windows Server. Let's take a look at the AWS OpsWorks layer. So what is a layer? A layer is a subset of resources or EC2 instances in our stack. Layers are generally based on a common function and act as groups around these functions. This is particularly significant as the Chef recipe code applies to a layer and all the instances that is in that layer. If there is an instance you don't want the code to apply to, it should not be in that layer. A layer is the point where node configuration is performed. So for example, what recipes to execute at each lifecycle hook, A layer can consist of one or more nodes, and any existing or new nodes must be a member of at least one layer and can be part of multiple. When a node is a member of multiple layers, it will run all the recipes you had previously configured for each lifecycle event for both layers in the orders you specify. So be mindful of that when you have nodes that are part of multiple layers. Elastic load balancing. Any elastic load balancers that are in the same region as a newly created layer will automatically associate itself with that layer. Any instances in that layer will associate themselves with the load balancer and will be deregistered with the load balancer if they become unhealthy or they are taken out of service. Elastic IP addresses are another thing you want to take advantage of. When you assign a public IP to your instances, they may change when the instance gets stopped and started again. You can configure layers to assign a public or elastic IP address to instances when they come online. Elastic IPs will ensure your public IP will never change regardless if the instance is restarted or shut down. Amazon EBS volumes. When you create stacks that include Linux instances, you can assign one or multiple EBS volumes to a layer. You must configure a mount point, the size of the volume, any RAID configuration you want to use, input/output per second, and your encryption settings. When instances are spun up in the layer, the AppsWorks stack will create an Amazon EBS volume with your specific configuration, then attach it to the instance. AppsWorks stacks then use a chef cookbook to mount the volume to the newly created instance. Linux stacks include the options to assign one or more EBS volumes to a layer. So that does give you the option to do a redundant array of independent disks or RAID configuration. Amazon RDS layers are essentially just connection strings to existing RDS instances. When you associate an RDS instance to a stack, it is assigned to that application that will be using it. The RDS layer delivers the connection information to the instances in the stack. A single RDS instance can be associated with multiple different applications, but remember you can't associate multiple RDS instances to one single application. So one application needs one database, but one database can serve multiple applications. And finally, Amazon ECS cluster layer. The Amazon ECS cluster layers provide configuration management capabilities to Linux instances in your cluster. To create this layer, you must first create your ECS cluster via the console or CLI or SDK, however you are creating your cluster. You must then register the cluster with the stack. Then it will appear in a drop-down list of available clusters from which you can create a layer. Once the layer is finished, previously created cluster instances will not be imported into the stack, so you'll need to register them as on-premise instances or create a new instance in that layer to replace the old one. This will ensure that the AppsWorks stacks will automatically always install Docker and the Amazon ECS agent before it registers the instance with the cluster. AWS AppsWorks instances. What type of instances can we use with AWS AppsWorks? First of all, we have three options. We can use 24/7 instances. These are the instances that will run 24/7 until we manually stop it. We can use time-based instances. These run on a daily and weekly schedule that you'll configure, and they're useful for predictive changes in a load on your stack. So if you know that on weekends you're running a gaming server and traffic really picks up on the weekends, then you can use time-based instances to increase your number of instances on the weekends from, say, 8 to 10 or 8 to 12, wherever your traffic is spiked. And finally, load-based instances. These will start and stop automatically based on metrics we select, like CPU utilization. And this is how autoscaling works. So if we set a metric of CPU utilization to be 70%, and if our instances have much higher load than 70%, then we'll spin up more. Once that CPU drops down below 70%, then we'll scale back down. So you can implement automatic scaling in response to predictable changes or sudden changes. So predictable changes will be time-based, sudden changes are load-based. Note that these must be configured ahead of time in the console or the CLI. And this is the major difference from EC2 autoscaling. The underlying Amazon EC2 instance will not be created until the time you specify or the load threshold occurs. But the AWS OpsWorks instance object must exist ahead of time. So for example, if the lowest demand throughout the day in your environment requires running 3 instances, then it would make sense to run 3 24/7 instances. But if we know that at 5 p.m. to 6 p.m. each day, we get a spike in traffic, then we can incorporate some time-based instances. And if we want to accommodate any unpredictable changes in traffic, we can implement a load-based. So we can kind of use a combination of all 3 for better performance and cost efficiency. AWS OpsWorks apps. An app refers to a location where you store your code and any other associated files. There are different options to use as an app location. These can be Amazon S3 bucket, a Git repository, or an HTTP bundle. Any credentials needed to connect to these apps are available to be included in the app's configuration. The deploy lifecycle event is used to copy application code from the configured repository and will then perform any deployment steps that are necessary. This is done automatically with built-in layers, but must be included in the recipe for any custom layers you create. Anytime you want to modify an app, you must modify it to point to the newest version. The repository that you point to must have a copy of the newest code, and it's important to note that instances that are currently running will not automatically update until they are restarted, but any new instances will update when they spin up. AWS OpsWorks Stacks. Users and permissions management. AWS OpsWorks Stacks offer the capability to manage users at the stack level, all without the use of IAM permissions, or Identity and Access Management. This is great to be able to provide access to stack instances without having to give a user access to your account. If you have third-party contractors, this functionality allows OpsWorks Stacks to give access to perform some management tasks and to access SSH and RDP. Managing permissions comes down to 4 permission types that we can apply to a user to provide stack-level permission. We can specify a deny, a show, a deploy, or a manage. A deny is when no action is allowed on the stack. A show is like a read-only, where the user has the ability to view the stack configuration but can't interact with it. Deploy allows the user to view the stack configuration and deploy the app, but not make any changes. And manage is when the user has the ability to view the configuration, deploy the app, and manage any stack configuration. For existing IAM users for whom you'd like to configure stack level access, you can import them into OpsWorks Stacks on the users page in the console. Once you import them, then you can assign stack level permissions. AWS OpsWorks Lifecycle. What is the lifecycle of the AWS OpsWorks Stack? First and foremost, we have the setup. Once the instance comes online after stack creation, or when an instance is stopped and started, the setup phase begins. After the setup completes successfully, it will invoke the deploy command. But first we have the configure phase, which initiates when a stack comes online or offline. When this happens, all instances in the stack will take part for the configuration lifecycle event. This is essentially all instances saying hello to each other. For example, if your stack installs an elastic load balancer, all instances in that same layer will need to update its configuration to include the new nodes or remove the old nodes. Once the instance or instances have come online, the deploy lifecycle phase begins. A deploy event is needed to deploy the apps that you have configured for this layer. This can include downloading application files from a repository, starting or restarting services, and any other tasks we need to make our application available to users. The deploy stage will only ever run once automatically, as to ensure that all our code stays consistent. On deploy is when you want to remove an app or delete it from the layer. This is essentially the cleanup phase where we remove the app and any other dependencies or leftover code. And the shutdown phase is used to perform some final tasks before we issue the shutdown command to the instance and finally shut down and take the instance out of service. We may be copying log files to S3. We may be taking some final snapshots. So this is the phase where we do our cleanup and we shut down our instance and we end that ops work cycle. Amazon Elastic Container Service. Amazon ECS is a highly scalable, high-performing container orchestration service that supports Docker containers and allows you to easily manage your containerized applications, which includes actions such as running and scaling your containers. By taking advantage of simple API calls, you can launch and stop Docker-enabled applications, get insight on the complete status of your application, and incorporate other AWS services such as Identity and Access Management, CloudWatch, CloudFormation, and CloudTrail logs. What is Amazon ECS? Amazon ECS streamlines the process for managing and scheduling containers across fleets of Amazon EC2 instances. This managed service negates the need to include other management tools for orchestration and scaling. It's taken care of for you. AWS Fargate takes this even further as it deploys your containers to a serverless architecture. ECS is also highly scalable and can react to changes in demand. Elastic Container Service can increase running container counts across your instances, and this goes hand in hand with high performance. You can quickly launch thousands of containers using ECS with no additional intricacy. Amazon ECS clusters. So what are these ECS clusters we talk about? We've been throwing around the term for some time now. Amazon ECS clusters are the foundational infrastructure components that are used to run our containers. A cluster is simply one or more EC2 instances that exist in our VPC. Each instance in the cluster must have the cluster agent installed. This is needed so the container can get its scheduling and shutdown commands from the ECS server and to engage in the health status reporting of the containers. One thing to note is that if you use AWS Fargate launch type, clusters no longer use EC2 instances because they're considered serverless. So due to that serverless nature, tasks are launched on the AWS infrastructure, and an Elastic Network Interface, or an ENI, is assigned to each one. That gives us the ability to provide network connectivity to the container without any need to manage the infrastructure that it runs on. An individual cluster can support both EC2 and Fargate launch types. That being said, a single instance can only belong to one cluster at a time. Amazon EC2 launch types support both on-demand instances and spot instances, which are great if you have a process or that server can be interrupted and pick up where it left off. It'll save you a lot of money with spot instances. And they allow you to reduce costs for non-critical workloads. So like I said, if you had something that was a workload that was running and it responded well to interruption and it just spun back up and kicked off where it left off, then a spot instances would be a good option to use. AWS Fargate. Fargate makes it even more simple to manage your containers in your environment and removes the necessity to manage your underlying cluster instances. All that you have to do is specify the computer requirements that your container needs, and AWS will automatically launch your containers. It's important to note that Fargate requires that your containers launch with an AWS VPC network mode. So you can't use the old EC2 Classic with Fargate. It must be launched in a VPC only. And if you want to enable log configuration, you must also require the AWS Logs driver to enable this. AWS Fargate configuration and setup is also available on the Amazon ECS console. AWS ECS tasks and containers. Amazon ECS launches and manages Docker containers. Now, Docker is not in the scope for the AWS Certified Developer Associate exam, but it's important to understand to grasp the concept of ECS. Container images are similar in concept to AMIs. Images provision a Docker container. So first we need a task definition. A task definition is a JSON document with instructions on what the containers will launch for your application or systems. This can include between 1 and 10 containers and their various requirements. These can also be used to specify which volumes to use. Containers really drive home the service-oriented architecture approach. We want to decouple our application. Instead of one behemoth monolithic application in a single container, it's more efficient to run smaller containers, each with a different functionality. We can have a load balancer container, we can have an order fulfillment container, and any other components of our overall application. Containers. Docker containers are lightweight, standalone, executable packages of software that includes everything we need to run in our application. So it's container, everything is contained. It's important to highlight the differences between containers and virtual machines. Virtual machines and containers differ in several ways, but the primary difference is that containers provide a way to virtualize an operating system so that the multiple workloads can run on a single operating system instance, whereas VMs, the hardware is being virtualized to run multiple operating system instances. So we're sharing the physical hardware. You should add containers to the same task definitions if they all share a common lifecycle, if they all run on the same common host or container instances, and the containers need to share local resources on volumes. Let's look at some Amazon ECS services. First of all, deployment strategies. Deployment strategies are used to ensure a minimum number of healthy tasks that are ready to serve requests, while other tasks in the service are being updated. We make use of the maximum percent parameter. This parameter will define the maximum percentage of tasks that is allowed to be running or pending. Conversely, the minimum healthy percent parameter specifies the minimum percentage of tasks that must be in a running state during deployments. ECS can also balance loads, so most applications use some form of a load balancer to distribute traffic. ECS supports 3 types of load balancers: the classic load balancer, the application load balancer, and the network load balancer. Classic load balancers require that any task being run behind it all exists on the same container instance, because a classic load balancer register and deregister at the instance level. This is not a desirable condition. So most times we use an application load balancer. They work at the application layer, layer 7. We can use dynamic host port mappings, and we can take advantage of path-based routing so that requests will be sent to a different task based on the path that was sent in the request. A network load balancer offers high performance option. It operates at the transport layer, layer 4, and allows you to route connections to containers running on ECS based on IP protocol data. AWS ECS schedule tasks. If you increase the number of instances in an ECS cluster, it does not automatically upsurge the number of running tasks right away. When you configure a service, you take advantage of the service scheduler, which will regulate how many tasks run on one or more clusters and is responsible for replacing tasks should any fail. This is great for long-running servers such as web servers. So we can do target tracking policies. These are used to scale the number of tasks based on a target metric. One of these metrics can be CPU utilization. If we set a target of 75% and the metric shoots above that target, Amazon ECS can automatically launch more tasks to bring the metric below the desired value. You can specify multiple target tracking policies for the same service, but in case of a conflict, the policy would result in the highest task count. Step scaling policies. Step scaling policies will scale in and out on a continuous schedule. If you set targets such as 75% CPU, 80%, and 85%, and so on, you can scale out at each target. Using this approach, one single policy can orchestrate multiple scaling activities as the metrics increase or decrease. Next, we have task placement strategies. So regardless on which method you use, task placement strategies are needed to govern on which instances tasks launch or which tasks are terminated. So how do we decide which instances we launch our tasks on? How do we decide which instances we remove tasks from? One task placement strategy is the spread task. This is used to distribute tasks across multiple AZs as much as possible. So if you ever get asked what task placement strategy is best for high availability, you want to look at the spread option. It does work on a best effort basis. If the strategy can't be honored, maybe there's insufficient compute resources in one of the availability zones, Amazon ECS will still try to launch the task on another cluster instance. Other strategies include bin pack, which will use CPU and memory availability on each instance to determine which instance can take the new tasks, and a random placement strategy, which use specific attributes that are evaluated at task placement. And finally, task placement constraints are used to enforce specific requirements on the container instances. So when a task launch, we want to specify the instance type as a T2 micro. That would be a constraint, a task placement constraint. Our tasks must be placed on T2 micro instances. Amazon ECS Service Discovery is used in conjunctions with Amazon Route 53 to create DNS entries automatically for tasks that your server manages. You must create a private server namespace for each cluster, and as tasks launch or die, these namespace updates are done automatically for you. Amazon ECS can link to private image repositories using basic authentication. This is good to connect to a Docker repository or any other private repositories using a username and password. So we'll use environmental variables such as ECS engine auth type and ECS engine auth data to actually set the authorization type and send our credentials. However, you should not set these properties directly. It's better to store it in this configuration in an S3 bucket somewhere and copy it to the instance with user data. It's more secure. The Amazon Elastic Container Repository is a Docker registry service that is fully compatible with existing Docker command line interface tools. The key points for ECR is that it's highly reliable, high uptime, and low cost. Additionally, if you do choose to run a container workload on AWS, you'll find that because the ECR is hosted in the same data center, it will pull down to your EC2 instances extremely quickly. The Amazon ECS Container Agent allows container instances to connect to your cluster. The Amazon ECS Container Agent is included in the Amazon ECS optimized AMIs, but you can also install it manually on any EC2 instance that supports the ECS specification. The ECS Container Agent is the agent responsible for monitoring the status of the tasks. If a new task needs to launch, the container agent will download it, and if any containers fail health checks, the container agent will replace them. And finally, service limits. There are some service limits in ECS. You can't spin up infinite clusters. So there's a maximum number of clusters per region, per account. There's a maximum number of container instances per cluster, for example, 10,000. There's a maximum number of services per cluster of 2,000. So you can view more of this on the AWS page, but just know that there is some limits to what you can do on ECS when it comes to the amount of clusters and the amount of services you're doing. So it's very high limits, and it's not something a lot of people run into, but it's something to be aware of. Amazon ECS implementation. How do we go about implementing our containers using Amazon ECS? First of all, we'll need an AWS account to access the Amazon console or the command line and to perform our ECS implementation. So if you're working in an organization and you're looking at implementing ECS, the first step would be creating an AWS account. Next, you'll need an IAM user. You don't want to log in as the root user, so whoever creates the account, if you create your AWS account, make sure you create an IAM user for yourself or the developer or whoever is going to use it, but don't give out the root account. Next, you need a key pair. So for every instance that you spin up, you need to specify the public and private key pairs so you can access the instance via SSH or RDP. Next, you'll need an Amazon VPC in which to launch your cluster. So it's a virtual private cloud. By using an Amazon VPC, which you can only use when you're using Fargate, you cannot use the EC2 Classic, for example. So with the Amazon VPC, it gives you the option of choosing which subnet that you want to use. Next, you want to create some security groups. So if you only want to allow, say, port 22 into your instances, or port 22, port 80, and port 443, then you need to create the security groups. The security groups are our instance level firewalls. And here's where you determine what type of traffic you want to allow and what type of traffic you don't want to allow. And finally, you should install the AWS command line interface, whether it's a Windows machine or a Linux machine, and you can easily do your ECS implementation from your command line on your computer. And it's very powerful, and it gives you a lot of great options for ECS. Let's look at some more components of Amazon ECS, starting with Identity and Access Management. IAM is the web service that we use to control access to our resources. So who can use the resources, which is the authentication part, and what resources they can use, which is the authorization part. In ECS, IAM can be used to control access at the container instance level using IAM roles. So we assign an IAM role to our instances. Or if we wish, we can also use it at the task level using an IAM task role. So IAM is an integral part of keeping your task and container instances secure. Next, we have Amazon EC2 auto scaling. We can automatically scale based on metrics that we decide, whether it's CPU or network in, network out, or some custom metrics like memory. We'll determine that. We can look at if we breach any CloudWatch alarms, or is the health status checked? Is it coming back with bad health, and should we replace it? We can also use schedules, time-based schedules. Elastic load balancing will help us distribute our load. So we can use the classic load balancer, the application load balancer, or the network load balancer. We said the application load balancer is much better because it supports path-based routing and has much more features because it operates at the application layer. Amazon ECR, or the Elastic Container Registry, is our managed registry service. It's secure, it's highly available, it's scalable. It supports private Docker repositories using resource-based permissions. And finally, CloudFormation gives developers an easy way to create and manage their AWS resources. So you can define your clusters, any task definitions, any services you want, you can use using CloudFormation. So you can really incorporate your infrastructure as a code with your configuration as a code. Amazon ECS using Amazon EC2. What steps do we need to take to use Amazon ECS with our EC2 instances? First, we must register a task definition. This is the design for our application. Every time we launch a task in ECS, we specify that task definition. Next, we create a cluster. So we know a cluster is a logical grouping of tasks. So whether it's the load balancer cluster or an order fulfillment cluster, ECS creates a CloudFormation stack that takes care of the EC2 instance creation, any of the networking or the IAM configuration for you. Next, we have to create a service. So an ECS service enables us to run and maintain a certain number of instances of a task definition simultaneously in our cluster. So if any of the tasks stop, fail, don't report back for a health check, the service scheduler will launch another instance of your task definition to replace it in order to keep that desired number of tasks in service. Once we create our service, we finish that, we should view our service, right? The service is a web-based application, so we can view the containers with a web browser. If we are using container web services, then we can hit the web servers from the web browser, just to make sure everything is the way it should be and our path-based routing is the way it should be if we're using the application load balancer. And finally, clean up. So when we're finished with the ECS cluster, clean up our resources that are associated with it, clean up our instances, any elastic IPs that aren't attached, because these will cost you money down the road if you don't clean it up right away. Using Amazon ECS with AWS Fargate is much the same, but remember that AWS with EC2 can use the EC2 classic environment, but AWS Fargate must use a VPC. A lot of this steps are the same for Fargate as it is with EC2 instances. First, we create a task definition. We configure our service that we want to use. So we select how to configure our services, and now we're using a service architecture. So we just specify what the compute requirements are. We configure our cluster. So we give it a name. Then we let ECS service take care of the networking side of it. We review it and make sure everything is the way it should be, same as we should do with anything we do, right? We review our task definition, our configuration, and our cluster configuration. Once we're happy, we can create it. We should view our service from the web or the web browser. And finally, we should clean up. So again, elastic IPs, NAT gateways, unused instances, these will add up to a lot of charges down the road, so always clean up. Accessing Amazon ECS. So how can we work with Amazon ECS? First and foremost, the management console. It's browser-based. It's an easy interface to move around. It gives you a lot of user detail, and there may be some examples. Next, we have a command line tool. So the CLI. We can issue commands from our system using the command line, and we can perform whatever tasks we want to use for ECS and AWS. It can be faster if you know your commands and you know your way around the command line. It can be faster than the console. We also have an Amazon ECS command line. The ECS command line is made specifically for ECS. It has a lot of high-level commands, and it's made to simplify creating, updating, and monitoring our clusters and tasks. So it's a CLI designed exactly for ECS. And finally, AWS provides SDKs or software development kits that enable you to access Amazon ECS from different programming languages, whatever programming language that you're using. the programming language of your choice. If you check out the Amazon website, you can see what SDKs that they support. And you can also take a look at some of the commands that you can run from the command line and just differentiate between the different ways that you can access the ECS. In this video, I'm going to discuss Amazon Elastic Container Registry, or ECR. So what is the Elastic Container Registry? ECR is a managed AWS Docker registry service. It provides secure, scalable, and reliable service for you to create a repository to push and pull your Docker images as needed. Some components of the Amazon ECR. First of all, we have the registry. The registry is provided when you create your account. From there, you can create repositories inside your registry and store your images. From there, we have authorization token. Our Docker client must authenticate with our ECR repository before we can use it. We can't start pushing and pulling Docker images unless we authorize with the registry itself. Next, we have repositories. The repository will contain your Docker or any of your images that you create. You can push to your repository. You can pull from your repository. Going hand in hand with the repositories are your repository policies. Who can access your repositories? What images can these people access? And speaking of images, an image is a crucial portion of ECR because it's the images are what you push and pull. You push and pull your container images to your ECR repository. So let's dive in a little deeper about your Amazon ECR registry. First of all, it's used to host our container images. We create our repositories in our registry, and from there, we can place our container images. It's highly available and highly scalable. It's in the cloud. It's an AWS managed service. It deploys containers reliably. So you can incorporate some continuous integration or continuous deployment into your ECR to deploy newer versions of your containers. And it manages images repositories. So Docker image repositories, and it can also manage your Open Container Initiative or OCI images. So these are both available to use with ECR. So let's take a look at the ECR authorization token and some of its components, such as the credential helper. Credential helper makes it easy for us to use and store our Docker credentials when we push and pull our images to our ECR. We can retrieve an authentication token. So once we receive our authentication token, we'll be given a permission scope that will match the principal that was used to retrieve the authentication token. So then we are limited to what we can do. And it also supports HTTP API authentication. ECR is a private registry, so we can't just push and pull images to it. We must provide an authorization token with every HTTP request. So we can also add the authorization header and pass that authorization token using an API. So this is where the secure part of the ECR comes in. Next, we can look at the Amazon ECR repository. One of the key concepts is API operations. APIs are used to monitor your repository, to create your images, to delete your image repositories. So you need to know who has access to these API operations, who can create repositories, who can monitor, who can delete. Should someone be able to do it all? Can someone only have a monitor operation? So it's important to know that. If they have access to these API operations, then they have access to these repositories. So we need to set permissions to control the access to these repositories in our registry. Maybe we give someone the permissions to monitor a repository, but not delete the repository. We give developers the option to create and monitor their repositories, but not delete it. So it depends on your fit for your organization. You can also take advantage of the ECR console, which can be found in the Amazon Web Services console. The ECR console allows you to create repositories using the console, view the repositories and the images inside. And finally, the Docker command line is another way that we can push and pull our Docker images to and from our ECR repository. Now let's look at the Amazon ECR repository policies. The first way we can implement this is with repository policies. Repository policies are used to control access to the repositories, and we can specify what IAM users or roles can access the repository and what they can do once they're inside the repository. We also have the option of using IAM policies. Normally, IAM policies are allowed to access services as a whole, so maybe it be used to access the entire Amazon ECR service. But it can also be used to fine-tune control of specific resources as well. So what goes into creating an Amazon ECR images? First, we have to look into our prerequisites. What is the launch type? Are we going to use an EC2 launch type? There's also a Fargate option for a serverless option. But if we're going to go ahead and use an EC2 launch type, then we're going to have to start creating some ECS tasks. We're going to spin up what they call Amazon ECS container instances. So they're EC2 instances with the CS instance role applied and the container agent running. So now these EC2 instances are also ECS container instances. We'll create some Amazon task definitions, which we use to give instructions to the container on what image to pull, what ports to expose, and so on. And we can push and pull to repositories after we create these images. So we can push it to our ECR repository and tag it with a V1 or V2, right? So the beauty of incorporating ECR with our ECS task definitions is when we create these images, we can push those to our ECR repository, and it's very fast because everything you're running is on Amazon infrastructure. So Amazon ECR setup, how do we go about beginning our ECR journey? First of all, you need to sign up for AWS. That's first and foremost. You can't use ECR without an AWS account. Next, you create an IAM user. Again, we don't want to use root users. We don't want to expose the root emails. So we hide the root emails, create an IAM user with some form of multi-factor authentication. From there, we install the AWS command line interface, and we go about installing Docker. So if it's on a Linux machine, we can install Docker using our command line. If we're on a Windows 10, we can install Windows Desktop for Docker, and we can pretty much incorporate Docker and our command line. We can pull images, we can create images, we can push these images, we can make revisions. So all the tools we need are done once we have our CLI and we have Docker for desktop or your own Docker on your Linux machine installed and working together. In this video, I'm going to demonstrate how to create a cluster using Amazon's Elastic Container Service. So once we're in the ECS console, we can come over to clusters, and we'll have an option to create cluster. So we're going to go ahead and create a cluster, and you'll see we have two options. We have the Fargate option, which just creates the cluster, and an optional VPC and subnet. We also have the EC2 options, the EC2 Linux and the EC2 Windows. These will create the cluster, the VPC, the subnets, and the auto-scaling group. So we're going to go ahead and choose the Linux. Now we have to give it a cluster name. So I'm going to call it the Tech cluster. Tech is our company, and this is our cluster, our main cluster. We can use on-demand instances, or if you have a workload that can take interruption, you can take advantage of the spot instance. We choose our instance type. I'm going to go with an M5 large. And the number of instances. So I want to create a cluster of 2 instances using the Amazon Linux AMI. We can choose our EBS volume size of 30 gigs and a key pair if we want to SSH in. Here's the networking part. We have an option to create a new VPC, or we can put it in the default VPC. I'm going to go ahead and create a new VPC with a CIDR block of 10.0.0.0/16 and 2 subnets with a /24. We can add more subnets if we wish. I'm just going to go with 2. And here's a security group. We're saying allow any traffic on port 80 from anywhere to come in and access our cluster. Here's your container instance role. If you don't already have one created, ECS will create one for you. And any tags you want to use, and if you want to enable container insights. I'm going to go ahead and click container insights so I can see CPU, memory, some insights onto my cluster itself. So the cluster has successfully started, the policy has been attached, and now you'll see the CloudFormation stack kick in. This is what ECS uses to create and provision your resources. You can see we have a desired number of instances. All the settings we set when we created the cluster are all down here to view, and you can see as things get created, they go from pending to a clickable link where you can actually go in and investigate the security group or the internet gateway. So the subnets are created. Now they're associating the root tables to the subnets. And then at that point, we should be complete. Now that our CloudFormation stack is complete, the cluster has been created. So let's go and view our cluster. You'll see we have an ARN where we can reference this cluster. It tells us the status is active. Do we have any container instances? Which we don't. We just have 2 EC2 instances with the ECS agent installed. All right, so if we come down to ECS instances, you'll see we've got 2, 1 in each availability zone, and they're both on separate EC2 instances. We come over, you'll see the CPU available, 2 CPUs, and each instance has roughly 8 gigs of memory. I can update my cluster, or I can delete my cluster. The options for updating are not very many. We can just change our capacity provider strategy. I'll cancel out of that, or we can delete our cluster. So right now I'm going to leave my cluster up so that I can eventually create some task definitions and then services over my ECS cluster. So I hope this video showed you how to create a cluster, some of the options available to you, and then how to view your cluster to confirm it actually deployed the way you wanted it. In this video, I'm going to demonstrate how to create task definitions that we can run on our clusters. A task definition is required to run Docker containers, and we can specify some parameters like the Docker image, how much CPU or memory we can use with each task and with each container in each task. So I'm going to use the cluster we've already created with our 2 ECS instances, which are hosted on 2 EC2 instances. So I'm going to go ahead and click Task Definitions. And I want to create a task definition that'll deploy an Nginx image. So I click Create New Task Definition, and we're given 2 launch capabilities. We've got Fargate, and we've got our EC2 instance. We're going to select our EC2 instance. And first thing we do is have to give it a task definition name. So we're going to call it Nginx install. It requires EC2, which we already have in our cluster. We can give it an optional task role, and we select our network mode. So we're going to leave the network mode as default, which will default to a bridge on our Linux machine. If we're using Windows, it would default to NAT mode. We could also choose AWS VPC. But we're going to go ahead and leave it on default, which is a bridge. We come down. We have to make sure ECS has permission to create and use a task execution role. And here is where we don't have to. It's optional for EC2, it's required for Fargate. Set a specified fixed size for our task. So I'm going to leave it empty for now and come back to it. So first, we have to add our container definitions. What are we going to use as a container? What image are we going to pull down? So our container name, we'll call it Nginx. And for our image, we want Nginx and we want the latest version. So here's where we set memory limits on our containers. So I'm going to give it a 1 gig memory limit and the port mappings. So this allows us to map ports from the host to our containers. So we're going to map anything that's coming in on port 80, send it to the container on port 80, because Nginx is listening on port 80. We could also say if anyone sends a request on port 3000, send it to port 80. It depends on how you want to map your ports. These are your 4 required fields you must fill out. The rest are a little bit more advanced features, health checks, right? From what interval do we want to perform health checks? How long is a timeout period? And more environmental, if we want to specify the CPU units, the GPUs. But for the DevOps exam, this is your 4 required fields. So we're going to go ahead and click Add. And you'll notice that our bar that specifies the task size is filled up. So we can come up here and we can say we only want this task to use 4 gigs of memory. But we are only using 1 container on this task, so we just set it there as 1 gig, which is plenty of memory for an Nginx server. So we've got some options for elastic inference, constraints. Again, these are advanced features. And we've also got a feature for volume. So if we want to add a volume for a container to use, we can use it here. I'm going to go ahead and create our task definition. It's been created successfully. So now we need to run this task to deploy these Nginx containers to our ECS instances. So if I go on Actions and run task, I'm left again with more options for running the task. So launch type is EC2. The task definition is family. So all task definitions will begin to a family. This is the Nginx family, and it's the first revision. We have a drop down for what cluster we want to run this task definition on, and how many tasks should we run. So if I run 1, then 1 of the 2 EC2 instances will receive this. If I select 2, then both of the EC2 instances will receive this. So I'm going to click 1 for now, and I'm going to give it a task group name of web server. So if we're running multiple tasks, we can use a task group name to group those by function. And the task placement, which is of importance for the DevOps exam, how do we want to place our tasks over our instances? Do we want to balance them over availability zones for high availability? Do we want to balance them using the bin pack method and still use multiple AZs for high availability? Do we want to just use the bin pack method? Do we want 1 task per host, or do we want custom? So I'm going to say 2 tasks to be run, and I want them spread over availability zones. So if I run my task, you'll see the task is now running. I've got 2 pending task counts. If I come down here, you'll see they're pending, and now they're running. So if I come over to my ECS instances, you'll see now that I've got 2 EC2 instances. Both are running containers. And if I come back to EC2, we should see our EC2 instances, and we should be able to copy it, and view it in the web browser. So we know this instance is running Nginx, and this instance is also running. So we ran that task over 2 containers spread over multiple availability zones. So if we come back and look in our task definitions again, you'll see that it's active. And if we come back into our cluster, you'll see that we've got 2 running tasks, 0 on Fargate and 2 on the EC2. If we look at this task, we get more information, task ID, the task definition, the container it's running on, the last state, the desired state. If you click on the task, it brings you a little bit more information, the container instance, the EC2 instance, the definition, and what containers it is running on. So that's how we deploy tasks. We deploy the cluster. Then we create our task definition, and then we run that task definition. Do we want to run it multiple AZs? Do we want to run it on the bin pack method? It's up to you. But we, using a task definition, just deployed Nginx containers to both of our ECS instances in multiple availability zones. In this video, I'm going to demonstrate how to create a service to ensure that you have the appropriate number of tasks running in your cluster. So we're going to go ahead and use the cluster we have created previously, the tech cluster. And right now we have 1 running task, and that's our Nginx server. So we can run another task and deploy it to the other availability zone, and we'll still have our 2 running tasks like we want, but how can we centralize that? And we can create a service from that, so that a service will ensure that we have the correct number of tasks running. Right now, we have no oversight if we're running multiple tasks. We have nothing that says we need 2 tasks. So in order to do that, we'll create a service from our task definitions. So first, I'm going to stop this running task. So we have a clean slate and we have no tasks running. Now I come over to services. And I want to create a new service for this cluster. So I click Create. I give it an EC2 launch type. Now we come back to our task definition. So really we're telling this service run these task definitions and make sure we have 2, in our case, running at all times. So it gives us oversight into our tasks. So I want to run the Nginx install task definition, revision 1, and I want to run it in the tech cluster. I'm going to give it a service name. It's going to be web servers. Now I have 2 service types. I have the replica type and the daemon type. A replica type, you specify your desired number of tasks. If you're running the daemon type, it'll place 1 copy per container instance. So we want to add a number of tasks. How many tasks do we want to run? So we want to run 2. Right? We want to run this task twice, so we have 2 Nginx servers. Next, we have the minimum healthy %, which is the minimum threshold that we should be running in our cluster, and the maximum %, which is a maximum upper limit threshold we should be running. We'll leave these as default. We have some deployment options, so rolling update or blue-green deployment. If you use a blue-green deployment, that will be invoked by AWS CodeDeploy, because we have to create the 2 environments for the blue-green deployment. We're going to leave it as a rolling update. And now we're given our task placement again. So how do we want to place it? Much like the same task placement for running a task definition, it's the same here. We have the same options. Do you want to spread it over availability zones? Do we want to spread it over availability zones using bin pack method? Do we want just the bin pack method? We can have 1 task per host, or we can set it up custom. I'm going to go with the AZ balance spread. So I want a task run on each of my instances on different availability zones. So I click Next. Is there any health check grace periods? That's only available if you have a load balancer. We're not going to implement a load balancer right now. We're going to go ahead and click Next. We're not going to adjust the auto scaling. We're going to leave the auto scaling as is. Click Next and we can review it. So we want 2 tasks of type replica. The service name is web servers. Use this task definition and deploy it on this cluster. So if we create our service, the service is created. We'll go in and view our service. Right now we have a desired count of 2. If we click events, you'll see that service web servers has started 2 tasks. And the beauty of this now is that this service can have oversight over all of this tasks. So it does this automatic scaling. If we lose one and our desired count goes below our threshold, it'll spin up another for us. And that's the beauty of services, right? So incorporating your task definitions into services. So if we click on each task now, it'll take us and it'll show us that it's running. It'll show us the container runtime environment. And if we were to go to EC2 and go to our running instances, we'll see that we do have an Nginx installed on both instances. So if one of these were to fail, the service would be responsible for bringing it back up to us. And that's the beauty of a service. So again, trying to bring this all together, we create our cluster. We create any task definitions that say what image we want to use, how much resources we want to use. Then we can run those task definitions, or we can incorporate those task definitions into a service, which will give us much better oversight. And it'll make sure our desired count is always equal to our running count. It'll do automatic scaling for us. It also takes into account different types of deployment types. So a service should be how we deploy our task definitions out to our containers. In this video, I'm going to demonstrate how to implement load balancing with your service to increase high availability of your container. So I'm going to use the cluster we have created with the 2 container instances. You'll notice I have no pending tasks, I have no running tasks. So the first thing I need to do is create a service. You can't implement load balancing after the fact. So you can't update a service and add the load balancer. You must create the service with the load balancer. If you don't already have a load balancer created, then you should pretty well do that first. So let's go into our load balancers and create a load balancer. We want to create an application load balancer, and we'll call it web server LB. It's internet facing, it's IPv4, and it's listening on port 80. I want it in 2 availability zones. I get a warning that I'm not listening on a secure port of 443. That's fine for our demonstrations. Port 80 is fine. So I click Configure Security Groups. I can select an existing security group from any old load balancers, or I can create a new one. It'll automatically give it the name and open up port 80. Next, we configure our routing. So we need to create a new target group. So we'll call this ECS. It's an instance type. It's port 80. Now we need to register our targets. So we come down to our 2 ECS instances, add them to registered, and review. Once this is done and everything looks fine, we click Create. Creates our load balancer. So now we should grab the public DNS so we can test it later. So if we come back into our cluster, we can go ahead and start creating the service. So I click Create on Service. We want an EC2 type. of Nginx is the task definition, revision 1. Deploy it to the tech cluster. We're going to call this service web server. It's of replica type, and we want 2 tasks. Because if we have a load balancer, it doesn't make sense to have only 1 task. We want to spread that load over 2. We'll leave the minimum and maximum healthy percent the same. It'll be a deploying rolling update. And we're going to balance it over multi-AZs. So we could use it over multi-AZs using the bin pack method, just a regular bin pack method, 1 task per host or custom. We're going to go ahead and keep it simple and use the AZ balance spread. And here's where we configure our network and load balancer. So if I come under load balancing and click the application load balancer, because that's what we used, it's good for path-based routing if you've got multiple routes, right, and multiple endpoints. Network load balancer, again, gives you more high performance based on layer 4. And then the classic load balancer is static host port mappings. So we'll click the application load balancer. We already have a service role. You may have to create a new one. It may create one for you, right, if you wish. I'm going to go ahead and use the one we already created. And under load balancer, you'll see the load balancer we created. So now we have to add a container to the load balancer. So the container name is Nginx, and it's port 80 on the host forwarded to port 80 on the container. So let's add it to the load balancer. The production listening port is going to be port 80. It's going to be on HTTP protocol. It can create a new target group for you, or you can use the one that we created when we created the load balancer. It says the target group protocol is HTTP, and the target type is instance, and the evaluation order is default, and the path pattern is all. So let's go to the next step. We're not going to adjust the auto scaling. We take a look at our review. Everything's fine. The network looks fine. Container port 80, listening on port 80. So let's go ahead and create our service. This should now create 2 Nginx servers, 1 in each availability zone, and put a load balancer in front of it to balance the load. So if we view our service, you'll see that the 2 tasks are running. So if we do a refresh and we look at events, you'll see that web service has started 2 tasks. So if we come over to our web servers, you'll see that Nginx is successfully installed. But now we should check out and make sure it's actually being load balanced. So we still have the load balancer IP, and sure enough, it load balances and sends it to one of our ECS containers. This could be this EC2 instance, or it could be this EC2 instance. But now we have 1 point of entry for users. So as you can see, now we have our desired count is 2, the running count is 2. If one went down, it would spin up the other one automatically. So tying it all together, we created our cluster. We created a task definition to say we deploy the Nginx container and use this specific amount of memory and CPU. Then we incorporated that task definition into a service so we can have oversight on all of our tasks. Are the desired count equal to the running count? Do we need to spin up? Can we incorporate health checks? These type of things is what a service allows us to do. And then incorporating it into the service allowed us to deploy a load balancer in front so we can load balance over multiple ECS containers. So now it's up and running. I can update it. I can add more desired count if I wish. I can set up more auto scaling if I wish. I'm going to leave it as it is right now because I have a really nice web server set up in 2 availability zones, which is being load balanced by an application load balancer.
In this video,
I'll demonstrate how to install Docker Desktop on Windows 10 development machines. Installing Docker Desktop is a great advantage because from the command line you can create containers, you can upload images to a repository, or pull images back down from a repository. So, for starters, we want to go to the official Docker webpage. If we can go to Docker webpage, you'll see it's docs.docker.com/docker for Windows/install. So here we can view our prerequisites and we can actually download the file. So some system requirements: you need a Windows 10 64-bit, Pro, Enterprise, or Education. Hyper-V and container Windows features must be enabled. And you must have the following hardware: 64-bit processor, 4 gigs of RAM, and a BIOS level hardware virtualization support. That must be enabled. One thing I'd like to note is that if you're installing on Windows Home, your process will be a little different. You're going to need Windows 10, but you have to enable the Windows Subsystem Linux 2 feature for Windows. Then you actually need to have a 64-bit processor, 4 gigs of RAM, BIOS level hardware virtualization, and then you finally must download and install the Linux kernel update package. So it's a couple more steps for Windows Home, but it's still doable. So we'll go back to Windows 10 Pro, and I'll download the setup files from the Docker Hub. I come in, I click Get Docker, and I'm going to put it in my Docker install folder, and it's 391 megs. So it's a relatively pretty quick download. Once we get it done, we can kick off the install process, and I think it involves at least one restart. So once we're down to our final few megabytes, we can kick off the installation process. So the installation process will involve downloading more files and going. So it's not a lengthy process, but it's not short either. So we'll walk through it and see how it goes. So I get my security warning, I'll run it, get my user account control, click OK, and now it goes into the downloading. It downloads more packages, it installs these packages. It's a bit of a lengthy process, but once it all gets done, you should be up and running very quickly. It'll go through and unpack all the resources. One thing to note is your Windows 10 must be up to the newest version. It's the 2004 version. If you try to install without the most updated Windows 10 version, Docker will fail and you'll have to eventually do the update. So we're still unpacking some files. As you can see, it's a pretty heavy-duty application. And when you're in the world of virtualization, Hyper-V, these packages are not small, and they do take a moderate amount of resources to install and run. Now that everything is unpacked, we get into the installing. So we created a Docker users group. We add users to that group. It's enabling the extra features, adding shortcuts, adding binaries and CLI plugins, and now it appears to be clued up and the installation is successful. So we click close and let's come out of here and go into Docker for Desktop. So I click the link, wait for it to fire up. You'll notice it'll come up down here as a little whale. Tells us the Linux containers WSL2 backend is starting. We can always right click it and look at a dashboard. See, it's spinning up. While that's spinning up, we can open up our command line and just be sure that it did install correctly. So it's important to note you should run your command prompt as an administrator. Command control again, and now we're in the command prompt. At the same time, Docker is still in the process of starting, but the dashboard has created. So we're going to go ahead and let that continue starting. But in the meantime, if we just type in docker -- version, we can see that it is installed. It's version 19.03.8, and it has a build of AFAC B8B. Now Docker Desktop is running, and we can open PowerShell or command prompt and start creating our Docker containers and our images. So close that. And now we look at our desktop again. So we've got no containers running, but let's try running container. So copy and paste this into your terminal. We copy it into our clipboard. We come back, we paste it into our command prompt, and we hit enter. It's unable to find the image locally, so it pulls it from Docker. Pull is complete. The newer image has been downloaded, and everything looks to be going pretty successfully. So if I want to check that out, I can go 127.0.0.1, and I'm now hosting on port 80 this Docker getting started. So congratulations, you just started the container. So that's great. We can also run another if we like. You say Docker run hello world. Can't find it locally, pulls the image down. Here we get another confirmation message that shows your installation appears to be working correctly. And one more thing, if we look into our dashboard, you can now see what's running and what isn't. So if I want to start or stop, I can do it from the dashboard, and I can restart the hello world one from inside the dashboard as well. The hello world is only a quick hello that tells you that your Docker is working fine, so it doesn't run continuously as our getting started guide would. So we spin that back up again, and it's running. So you can use the console, you can use your command prompt. There's a couple more commands, such as docker ps-a, which will give us a running list of our containers, their images, what the command is used to create it, and if you see the ports running, then we know that that's currently using ports and redirecting all traffic on port 80 to port 80 in the container. So I hope this video was informative on how to install the Docker desktop app. Test it to make sure it works fine. Run some of the commands from the command line. Stop and start some containers from the desktop application itself in the dashboard. And then come in and run some more Docker command lines just to look at your containers and images. If you know the command line well, you can get around it really quick, and you'll find it to be much more efficient than the actual dashboard itself. So good luck and happy developing. In this video, I'm going to demonstrate how to create an elastic container repository so we can push and pull our Docker images from when creating our containers. So I'm going to do this on our Windows 10 development machine. I just want to make sure that I have Docker running for desktop, which it is, and that's what allows us to run our Docker commands and push and pull our images. So the first thing I need to do is to create a repository. So I'll put in my code, AWS ECR, create repository, and then we have to add the repository name. Now at first I had web server. This will come back as an error because it doesn't like capital letters. So I'm going to use hello world and click enter. you'll see now that our repository is done. It spits out the output. It gives us our repository ARN, gives us our registry ID, gives us the repository name, the URI, created date, if the image tag is mutable, so can people overwrite the image tag with subsequent pushes, and is there any image scanning configuration on push, and it's not. So what do we do now? Well, let's take a look at the repositories. So we'll do an AWS ECR describe repositories, and you'll see we'll get the exact same output as we did below. If I had multiple repositories, we would see these multiple repositories listed. So the next thing we want to do is to be able to get our username and password so we can log into this repository and push. So the first thing I want to do is put in this command. So I'm going to paste the command and we'll talk about it. So it's the AWS ECR get login password. We're passing in the region as US East 1. And I'm saying for my Docker login, my username should be my AWS. My password should be my password and then 09A328 and so on. So this is my user ID, docker.ecr.region.amazon. So I'm sending my AWS username and password to the ECR. Once I click enter, I get my username and password and the login succeeds, so it does the login for me. So from here, I've got a couple options. So first, I want to see what images I have. So if I say Docker images, you'll see that I've got 4 repositories and different images. So I'm going to look at the hello world. So I want to push the hello world to my newly created repository. So the first thing we must do is tag our image. So I want to take this image and I want to tag it. So what I'm going to do in this case is I'm going to say Docker tag hello world, right? This local image in this repository, and I want the latest, and tag it to my repository that I had just created. We click enter, we don't get any errors, so now we tagged it or we associated this hello world with this ECR repository. So now our last step would be to do a push, to push that to our new repository. So if I paste it in, I come in, say Docker push to this repository, hello world latest. So it knows what image to push because we tagged the hello world latest to it. So now when we just say push, then we know that the hello world image has to go with it. So if I push and click enter, the push refers to this repository, it's pushed, and it even gives you a digest. So if I do another Docker image, you'll see my repositories are now Docker images, sorry. You'll notice now that I have 5 repositories. I have the hello world that I created earlier. I have the hello world that I just created, and a couple more. So any that have the 098, which is my account ID at Amazon, you know these are ECR repositories. These are just local repositories. So I can take the image from these repositories and push it to one of my ECR repositories. So I hope this video helped you understand how to create a repository, how to log into that repository, and Once the repository is ready and you have an image ready to go, have to tag that image and then finally push that image to your repository. So one last thing I want to look at is the console. Now that I'm in my console, you'll see that I have one repository, Hello World. If I click on it, we come in and I have the latest Hello World image, and here's my digest. One thing I want to kind of show you is that if you click your repository and click View Push Commands, it shows you, whether it's Linux or Windows, exactly what you need to do. So these were the steps that we did. We retrieved our authentication token and authenticated our Docker client to the registry. We used a pre-configured image already, so we didn't have to build it. But if we had an image that we needed to build it from a Docker file, then we can use the Docker build command. Once the build was done, we tagged it and said, basically associate this image to this repository, and then we pushed it to the repository. So you can copy these commands right away, and it's a really good way of kind of, especially in the early ways, I mean, it's really hard to remember all these commands, so having them there for you is a really good benefit. So just remember, when you're ready to do any Docker pushes and pulls or anything to do with the command line using Docker, make sure your desktop Docker app is open, and then go ahead and push, pull, create images, build, deploy, and have fun. In this video, I'm going to demonstrate how to pull an image from an Elastic Container Registry repository, update that image, push it back to the ECR repository with a new revision. So first thing I need to do is pull my Ubuntu image from ECR. So if I look into my Docker images now, you'll see I have no images. So I want to do a describe repositories just so I can see my repository ID and the URI. So now that I have these, I'm going to pull the image down to my development machine. So I say Docker pull, and you'll see my repository URI, which is my account ID.dkr.ecr.myregion.amazonaws.com / my image ID and the tag of version 1. So I want to pull it down. So I'm going ahead and pulling it from the repository. It's extracting. It's a pretty quick process. It's a pretty small image, but it's just an Ubuntu image. So this HTML server image just installs Ubuntu, and now we want to change that so it installs Nginx on top of Ubuntu. And then with that new revision, we'll push it back up to ECR. So it's done. If we do a Docker images again, we'll see our images now there. So now we want to run it interactively. So we want to run that Ubuntu image interactively with a bash shell so we can install Nginx. So I'm going to say Docker run -I for interactive. Here's the repository. Here's the image and the version I want to run, and I want to open a bash shell inside. So I click enter. You'll see that my prompt has now changed to root. So I'm now working inside that Ubuntu. So I'll make a little room for us. We're still in our Ubuntu. And I'm going to do an apt-get update. And then I'm going to do an apt-get install of Nginx. The update is pretty quick. Once they're all get, they read the list and we're done. Now I'm going to do an apt-get install Nginx-y. And once that goes through, I'll have my Ubuntu machine with Nginx on it. So I create a revision to that image. This is a little bit longer of a process, but afterward we need to commit our changes, then tag it, and then push it back up to ECR. So now the setup is pretty much done. It's asking me where I am for time zone purposes. I'm going to say Thunder Bay. So it automatically sets my time zone, puts the finishing touches on the Nginx, and now we're back to our prompt again. So I'm going to exit the shell. Once we come out of the shell, we should have our regular prompt again. And now I'm going to do another look at the containers. So I'm going to say Docker PSA. So let's look at all the containers. And it's important to get your container ID. So in our case, our container ID is copied. And now we want to save the changes as a new image. So a revision to those images. So I'm going to say Docker commit, paste in my container ID. And I want to call it HTML server image v2. So we're committing the changes that we had previously made. The original image was Ubuntu. Now this image is Ubuntu and Nginx. So it completes successfully. We're going to go ahead and tag this image and then push it back up to our repository. So I say Docker tag HTML server image version 2 to my repository as also version 2. So I tag it. Now the final finishing step is to push it back up to the repository. So that'll be a Docker push command. So we're saying Docker push to my repository as version 2. So you can see right away it says the push refers to this repository, which is ours. It's pushing it. You can see the status bar as it goes. So by tagging our image and version with our repository and image, then we can just say push and specify repository and image. So if we come back into the console now, previously we had v1. Now we have v1 and v2, each with an image URI. You can see the size are different because we did an update on the original image where it was just Ubuntu. Then we updated Ubuntu and installed Nginx, so the size is going to be definitely bigger. So I hope this video showed you the intricacies of pulling from ECR repositories, making revisions to images, committing those images, and then pushing them back up to your ECR repository. In this video, I'm going to demonstrate how to create a Fargate cluster. So once we come into our Amazon ECS, we can click on Create Cluster, and again we're greeted with 3 different options. Our networking only, and the 2 EC2 options. So this is our Fargate option right here. Network only, it's only going to create the cluster, optionally create a VPC in subnet. So this is considered the serverless option. So let's go ahead and select Fargate. We'll go ahead and click Next, and we'll call this cluster Tech Fargate. So for the networking, we can create a new VPC, or we don't necessarily have to. We did that when we did the EC2 back clusters. So for the Fargate cluster, since it's optional, we'll uncheck this box and leave it the way it is. We can add any tags that we wish to use, and we can enable container insight. So it's much like the EC2 back method, but it's a lot less to choose from when it comes to networking and subnets. So we click Create, and our cluster was created. So we go ahead and view our cluster. You'll see it's currently provisioning. We have our ARN. We can come over to ECS instances. Now we can see that it is active. So we have an active cluster. We haven't created any tasks. we don't see any ECS instances because, again, this is Fargate. So if we wanted to deploy a task definition to our Fargate, then we would have to choose our launch type as Fargate. But since this task definition was created in the EC2 mode, it won't work. So we'll cancel and come back out. So I just wanted to show you the difference with regards to a regular back EC2 cluster and a Fargate cluster. So again, if we come back into our Fargate, the big thing to notice is that you don't see these ECS instances. And if we come into EC2, when we did the EC2 back ones, we would always see the EC2 instances. Now, we don't have those. We still have a regular ECS instance from our previous EC2 cluster. As you can see, it says EC2 container service. And these were the ones that we spun up with our EC2 cluster. But there's no EC2 instances for our Fargate cluster. So really, at the end of the day, that's what they mean by Fargate being the serverless option. You don't have to be concerned about the hardware side of things, right? So with our tech cluster, we've got 2 container instances running. This is a EC2. And if we look under ECS instances, you'll see those 2 EC2 instances that were in our EC2 console, because this is an EC2 backed cluster. But again, with our Fargate, it's not. This is considered the serverless option, so we don't have to worry about that. So all we would go ahead and do is create our new task definitions, and possibly a service if we wanted to, and then roll that all out to our Fargate cluster. So I hope this video helped you understand the differences between an EC2 backed cluster and a Fargate cluster, and how to go ahead and create a Fargate cluster of your own. In this video, we'll discuss AWS X-Ray. So what is AWS X-Ray? As the name implies, it's a managed service that allows you to gain very good insight into all the API calls that is going to your application. So it collects data about all the API requests to your environment. It provides tools for filtering and gaining insight for your environment. It also allows you to identify any issues and investigate any unauthorized access incidents. There are tons of detailed information about the requests and response, and you can also see how your application works with other AWS services, such as database and web layers, or AWS Lambda. The AWS X-Ray SDK provides multiple things to actually make it run and integrate with the rest of your service. One of these things are interceptors. Interceptors are what you need to add to your code to trace your incoming HTTP requests. So without interceptors into your custom code, X-Ray cannot go about tracing your requests. Next, you need client handlers. Client handlers allow the AWS SDK clients that your application uses to call other services like S3 or RDS, for example. And finally, the HTTP client, which is used to instrument calls to other web services, whether they're internal web services or they're external web services. Let's look a little bit more into AWS X-Ray. So X-Ray is not in constant communication with your application or vice versa. So instead of sending trace data to X-Ray directly constantly, the SDK will send JSON segment documents to a daemon process. This X-Ray daemon is listening for UDP traffic, and it will take all the segments in a queue and upload them to X-Ray in a batch, so you're not constantly talking back and forth. This X-Ray daemon is available for Linux, Windows, and Mac OS, and if you use some managed services like Elastic Beanstalk or AWS Lambda platforms, this X-Ray integration is already built in. Let's investigate AWS X-Ray integration. We have 4 types of supported integration. We've got active instrumentation, which is when your application will sample and instrument incoming requests. We have passive instrumentation. It's when the requests have been sampled by another service. Request tracing is just when we add a tracing header and then send it on its way. And tooling is when we actually run the X-Ray daemon to receive segments. So some of the AWS services that perform the X-Ray integration is, for example, AWS Lambda. They do active and passive instrumentation of incoming requests. Amazon API Gateway does active and passive instrumentation as well. Elastic Load Balancing, it does request tracing. So any request that gets sent to them, they participate it, and then they send it on its way. And AWS Elastic Beanstalk does tooling. So it includes the X-Ray daemon on that platform. So in this course, we've examined the AWS technologies that provide configuration as code, including OpsWorks, Elastic Container Service, ECS, Elastic Container Registry, ECR, and Fargate. We did this by exploring the concept of configuration as code, the use of AWS OpsWorks for creating and managing stacks and applications, how Docker containers are used to package and deploy apps, how ECS is implemented, and how ECR provides the Docker registry service on AWS, and how to create ECS clusters and use ECS task definitions. We've also learned how to create, configure, and implement load balancing to an ECS service, how to install Docker on Windows 10, create a repository using ECR, and create a custom revision of a Docker image. We learned how to create an ECS cluster using Fargate, and the use of AWS X-Ray monitoring service to analyze ECS application deployments. In our next course, we'll move on to explore how to deploy applications using microservice architecture, using the various services on AWS, such as SQS, SNS, and Kinesis.
In this video, we'll explore message queuing services. Message-oriented middleware is middleware infrastructure that facilitates the sending and receiving of messages as a means of information exchange amongst distributed applications or software systems. Messages, of course, need to be processed, and this is handled by a message broker. A client sends a message to the broker, and the broker forwards the messages from the client to the server application. Middleware forms a communications layer that supports the decoupling of systems such as those in a distributed environment. Message-oriented middleware uses an asynchronous messaging model, which resolves issues related to performance, interoperability, and scalability inherent in a synchronous distributed computing model. Now, let's consider message-oriented middleware versus remote procedure call, or RPC. In the traditional synchronous model, RPC requires that the calling code, the client, suspend processing until the called code completes and returns control. Now, this can be problematic, particularly as systems scale. Here are some of the reasons to use message-oriented middleware in place of a synchronous distributed computing model like RPC. First, availability. Systems that use the synchronous RPC model are interdependent. This means that all subsystems must be simultaneously available. This sets up a single point of failure, since a failure in any of the interdependent subsystems will bring down the entire system. RPC works at the object or function interface level. This results in a model that consists of tightly coupled subsystems. As such, any changes to the interfaces must be reflected across the entirety of the affected code base. As the number of changes to source or target systems rise, so too does the cost. As an asynchronous model, message-oriented middleware involves the decoupling of subsystems, so a huge benefit there. Next, reliability. Any failure outside of the application, including failures related to network, hardware, services, and various other kinds of service outages, can impact the reliability of data transfer between systems. Typical RPC models offer very little to guarantee reliable communications. Rather, they are quite vulnerable to service outages. Asynchronous models, on the other hand, are decoupled, so subsystems can separately integrate infrastructure to ensure reliable communication. Finally, in a synchronous distributed model like RPC, which requires calling systems to block and wait, performance may be significantly impacted where subsystems do not scale at the same rate. Essentially, it means that the whole system is subject to the performance of its slowest participant. Synchronous-based models can have trouble keeping up when components of subsystems experience high-volume traffic spikes. Synchronous interactions also use more bandwidth, as several calls must be made across the network in support of a synchronous function call. The asynchronous model, on the other hand, is comprised of multiple, decoupled subsystems and offers a scalable method of system interaction since each element may scale on its own as required. One of the primary advantages to using an asynchronous message-based communication model like message-oriented middleware is that it provides the ability to store or buffer messages relying on some sort of message queuing system. The message can be routed to the appropriate server application as required, and messages may be transformed while they are being sent and received. For example, some message-oriented middleware systems include logic that can transform messages in transit to match sender and receiver requirements. So, to summarize, client applications in an asynchronous model only have to worry about sending, receiving, and processing messages. It is the domain of the code implementing the message-oriented middleware system to address and resolve any issues related to performance, interoperability, and scalability. In this video, we'll explore Amazon Simple Queue Service, or SQS. Amazon Simple Queue Service, or SQS, is a secure, reliable hosted message queuing service for integrating and decoupling distributed systems. SQS includes typical queuing constructs like dead letter queues, first in, first out, or FIFO queues, and SQS provides a generic web service API accessible by any programming language supported by the AWS SDKs. Amazon SQS benefits include availability. Amazon SQS runs on redundant infrastructure, providing highly available infrastructure for both producing and consuming messages. Amazon SQS is durable, storing messages on multiple servers. In addition, standard queues support at least once message delivery, and FIFO queues support exactly once message processing. Now, don't worry about these concepts at the moment. We'll see these in some detail later in the course. Amazon SQS is also reliable. It locks messages during processing, enabling multiple producers to send messages and multiple consumers to receive messages simultaneously. Amazon SQS is also scalable. SQS processes buffered requests independently, allowing it to scale as needed, transparently handling load increases or service spikes. Amazon SQS is also secure. We are in full control over who can send or receive messages. In addition, SQS uses keys managed by AWS Key Management System to apply server-side encryption to protect the contents of messages in queues. Now, to set up SQS. First, in order to access any AWS service, of course, you must have an AWS account. Next, you'll need to create or use an existing IAM user with administrative access. If you're using Amazon SQS Actions, for example, using one of the supported languages or using the AWS command line interface, you'll need an access key ID and a secret access key. And finally, you write code in any of the supported languages or using the console or the AWS CLI. Now, to use Amazon SQS in the console, you'll first create a queue. And after creating the queue, we can then send a test message to it. Once the message arrives at the queue, it can be consumed, or in other words, retrieved from the queue. When requesting a message from a queue, you don't specify a particular message to retrieve. Rather, you specify the maximum number of messages to retrieve, up to 10, and then SQS can start polling for messages. During processing, the message is not visible to other clients for a specified length of time, known as the message's visibility timeout. Once a message is successfully received, then it's deleted, and this signifies to SQS that the processing was successful. And finally, in the console, you can also delete the queue. We'll go into this in quite a bit of detail and see some demos later in the course. In this video, we'll explore Amazon SQS Standard Queue. The Amazon SQS Standard Queue is the default queue type. It supports a virtually unlimited number of API calls per second for each API action, including send message, receive message, and delete message actions. Standard queues have at least once message delivery. In general, messages are delivered in the order that they are sent, thanks to best effort ordering. But due to its highly distributed architecture, more than one copy of a message could potentially be delivered out of order. Standard message queues have many use cases, but an application using standard queues must be able to process messages that arrive more than once and arrive out of order. Examples of suitable scenarios include decoupling live user requests from intensive background work. For example, allowing users to upload digital media while processing it in some way, like encoding it. Another use case is allocating tasks to worker nodes. For example, processing a vast number of credit card transactions. Another use case is batching messages to accommodate future processing requests. An example of this would be scheduling multiple entries in a database. A standard queue attempts to preserve the order of messages using best effort ordering. However, as mentioned, there is a possibility that more than one copy of a message could be delivered out of order. If an application requires strictly preserved order, then a FIFO, or first in, first out queue is recommended. Or another option is to add sequencing information to each message, allowing them to be reordered when they're received. Standard queues support at least once message delivery. Amazon SQS stores message copies on multiple servers to support redundancy and high availability. Sometimes, though, multiple copies of a message may be delivered. For example, if one of the servers storing a copy of a message is unavailable when a message is received or deleted by the consumer, that copy of the message on the temporarily unavailable server isn't deleted, and that message may in fact be delivered again when a consumer receives messages. For this reason, it's important when using standard queues to design applications to be idempotent. That is, the applications should not be negatively affected when processing the same message multiple times. In this video, we'll explore Amazon SQS dead letter queue. A dead letter queue is a type of queue that may be used by other source queues to store messages that can't be processed or consumed for some reason. They're particularly helpful for debugging applications or messaging systems because they allow us to isolate messages that can't be processed so that we can determine the root cause of a problem. Dead letter queues must be created first as a standard or FIFO queue, then configured as a dead letter queue. Dead letter queues can be created using the SQS console, the AWS SDKs, or the AWS CLI, or the AWS tools for PowerShell. Each of these methods has access to APIs for creating and configuring queues, including designating a queue as a dead letter queue. So how do dead letter queues work? Well, at times, there may be issues or problems processing messages. This can occur because of errors at the producer level or within the consumer application. It could also be due to a state change that was unexpected and not handled within the application's code. For example, say we have an e-commerce application and an end user attempts to purchase a product that's no longer stocked. In this situation, the e-commerce application fails, producing an error. The message containing the order request can then be forwarded to the dead letter queue since it cannot be processed. Or it could be something like a misinterpretation of communication protocols or hardware errors. Whatever the case, dead letter queues provide a store for messages that can't be processed so that we can isolate, analyze, and address the situation. SQS dead letter queues use a redrive policy, which essentially identifies the source queue, the dead letter queue, as well as any conditions that, if present, will cause SQS to redirect messages from the source to the dead letter queue. This happens if the consumer cannot process a particular message from the source queue within a specified number of attempts. So let's say, for example, we set a maximum receive count for a queue to 3. SQS moves the message to a dead letter queue once the message is received and not deleted, that is, processed 4 times. A couple of important items to note. Dead letter queues must be of the same type as the source. So the dead letter queue of a FIFO queue must also be a FIFO queue. And the dead letter queue for a standard queue must be a standard queue type. And finally, dead letter queues must be hosted in the same region as the other queues using that dead letter queue. Now, considering dead letter queue benefits. Let's keep in mind here that the principal reason for using dead letter queues is to handle messages that can't be processed. So configuring a dead letter queue means that we can also configure an alarm for messages delivered to a dead letter queue, so we're alerted any time a message can't be processed. We can look into the logs for exceptions that may tell us what caused messages to fail. We can analyze the content of messages sent to a dead letter queue for diagnosis. Was it a software issue, for example? Or perhaps it was the producer's or consumer's hardware experiencing issues. It also allows us to determine whether we've provided sufficient time for the consumer to process messages. For example, perhaps it takes the consumer 5 seconds to process the message, but we've only allocated 4 seconds for processing. Now let's discuss how different queue types handle message failure. Standard queues keep processing messages until the retention period has expired. This guarantees that messages will continually be processed, reducing the likelihood of a queue being blocked by messages that can't be processed. It ensures that the queue recovers quickly. So consider this example. In a system with thousands of messages, it's a much more efficient and effective process to move failing messages over to a dead letter queue than to continually try and fail over and over until they expire. FIFO queues use exactly once processing, consuming messages in their proper sequence from a message group. So what happens if a message in the message group can't be processed? The consumer may continue retrieving ordered messages from a different message group, but the original message group will remain unavailable until the message that's blocking the queue gets processed successfully. So with this scenario, you can understand why a dead letter queue is so important. Now, let's consider when we should and should not use dead letter queues. First, we should use dead letter queues with standard queues when our applications aren't dependent on message order. We should use dead letter queues when we want to decrease the number of messages traversing the queue and minimize the potential exposure of our system to so-called poison pill messages, which are messages that can be received but not processed. We should not use a dead letter queue with standard queues when we want to have our application keep trying to process a message indefinitely. An example is when our application has to wait for a dependent process to become active or available. We won't use a dead letter queue with a FIFO queue if we don't want to break the precise order of messages or operations. An example would be a FIFO queue with instructions in an edit decision list for a media editing suite, where altering the order of edits would change the context of successive edits. In this video, we'll explore Amazon SQS first in, first out, or FIFO queues. Amazon SQS FIFO queues may be created with or without server-side encryption. Furthermore, like standard queues, FIFO queues can be created using the SQS console, the AWS SDKs, the AWS CLI, or the AWS tools for PowerShell. Each of these methods has access to APIs for creating and configuring queues. FIFO queues are designed to improve messaging for use cases where the order of operations and events is of a critical nature. For example, in use cases where we want to make sure that user-entered commands are executed in the right order, or where duplicates are unacceptable. For example, preventing users from subscribing to a website more than once. FIFO queues ensure exactly once processing. However, they are limited in the number of transactions per second that they can sustain. When using batching, FIFO queues are capable of supporting as many as 3,000 transactions per second per API method. You can, however, request a quota increase by submitting a support request. Without batching, FIFO queues are capable of supporting as many as 300 API calls per second per API method. For specific use cases, FIFO queues improve and complement standard queues. The principal objectives and distinguishing features of FIFO queues are their first in, first out delivery, that is, message ordering, and exactly once processing. With first in, first out, the order of sent and received messages is strictly preserved. With exactly once processing, a message is delivered once and is available until such time as a consumer processes and deletes it. In addition, duplicate messages do not get introduced into the queue. FIFO queues also support message groups, allowing multiple ordered message groups within the one queue. Some key terms associated with FIFO queues include message deduplication ID, which is a token used for deduplication of sent messages. The way this works is if a message with a specific message deduplication ID is sent successfully, subsequent messages sent with an identical deduplication ID are accepted successfully, but they are not delivered during a 5-minute deduplication interval. Also note that message deduplication is applied at the queue level, not to individual message groups. And Amazon SQS keeps track of the message deduplication ID even after the message is received, successfully processed, and deleted. The message group ID is a tag indicating that a message belongs to a specific message group. Messages belonging to the same message group are always processed sequentially in a strict order within the same message group. The receive request attempt ID is the token used for deduplication of receive message calls, and the sequence number is a relatively large non-consecutive number assigned to each message by Amazon SQS. Now, let's consider some FIFO delivery logic concepts that are important to understand. First, let's discuss sending messages. When multiple messages are sent in sequence to a FIFO queue, each having a distinct message deduplication ID, SQS stores the messages and acknowledges it. Then each message in turn may be received and processed in the exact order that they were sent in. Message ordering is based on the message group ID. To preserve the order that messages are sent and received, it's important that each producer has a unique message group ID for its messages. With respect to receiving messages, a consumer can't request messages with a specific message group ID. When receiving messages from a FIFO queue that contains multiple message group IDs, SQS first tries to return as many messages as possible that have the same message group ID, allowing other consumers to process messages with a different message group ID. FIFO queues also allow both producer and consumer multiple retries. If the producer determines that a failed send message action occurred, it may continue to try sending as many times as required with the same message deduplication ID. Likewise, if a consumer detects a failed receive message action, it may try to receive as many times as required using the same receive request attempt ID. An existing standard queue cannot be converted into a FIFO queue. In order to move from standard to FIFO, a new FIFO queue must be created, or the existing standard queue may be deleted and recreated as a FIFO queue. To ensure that things work after the move, we'll need to ensure that the new queue and the consumer application are configured so that they can work together properly. Now, in terms of compatibility, clients not currently supported by FIFO queues include the Amazon SQS buffered asynchronous client. And in terms of services, some AWS or external services that send notifications to Amazon SQS may not be compatible with FIFO queues, even though they may actually allow us to set a FIFO queue as a target. AWS services not currently compatible with FIFO queues include the Amazon S3 event notifications, auto-scaling lifecycle hooks, AWS Internet of Things rule actions, and AWS Lambda dead letter queues. In this demo, we'll create a standard queue using Simple Queue Service. Okay, so I've signed into AWS Management Console, and I've signed in as an administrative user. And I need administrative access in order to be able to create queues and send and receive messages to those queues. To get started, I'm going to start typing SQS in the Find Services field, and when Simple Queue Service appears, I'll click it, and that brings me to the Simple Queue Service. Now I'll click Create Queue. All right, and on the Create Queue page, we have to decide first off what type of queue we're going to create. Do we want a standard queue with at least once delivery, where the message ordering isn't preserved, but we have unlimited throughput and best effort ordering? Or do we want a FIFO queue, first in, first out, where ordering is preserved and very important? We have high throughput, but exactly once processing. We'll go with a standard queue because that's what we're going to create in this demo. So I'll leave standard selected. And now scrolling down, I'll specify a name. I will call this my standard queue. Now scrolling down for configuration, I can set the visibility timeout. It's right now at 30 seconds. I will leave it at 30 seconds. The delivery delay, I will leave that at 0 seconds. I've also got a receive message wait time, and this sort of enables long polling. So I'll specify 20 seconds here because this can be between 0 and 20 seconds. I can also set the retention period here, and if I click the down arrow where days is, I can specify seconds, minutes, hours, or days. I'll leave 4 days the default. And the maximum message size is 256 kilobytes, and it's set at the maximum size right now. Recall that messages are not big binary objects or anything like that. They're short, succinct messages. So that's why the limit of 256 kilobytes. Okay, scrolling down, I can also specify the access policy, and I can use the basic method, or if I click advanced, I can use a JSON object to define my advanced access policy. I'll just select basic for now. Under basic, I can define who can send messages to the queue. The default is only the queue owner, and I will leave it at that for now. Alternatively, I can specify an AWS account or IAM user and role. I can also define who can receive messages from the queue. And right now, it's at only the queue owner, and I'll leave that, which is the default. Otherwise, again, we can specify an AWS account or IAM users and roles. Okay, scrolling down, I have encryption settings that I can specify. So if I expand encryption and I click enabled, I could specify a customer managed key and some other options here, but I will disable encryption for now. Note that SQS provides in-transit encryption by default. Okay, and then we have dead letter queue, which is optional. This is where we specify the dead letter queue to send messages that are undeliverable. And then we also have tags. So I think we're good to go now. I'll click Create Queue. Okay, and the notification appears, my standard queue created successfully. I'm going to close the notifications for now. And this is my standard queue. Now, on the tabs below, I have SNS subscriptions for this account, Lambda triggers, the dead letter queue, monitoring, tagging, the access policy, and encryption settings, all accessible from here. Scrolling up, if I click on queues, in the breadcrumbs, it brings me to a list of queues. So right now I've got my standard queue. That's the only one that I have. Again, the type is standard. It gives the date that it was created. I can see the number of messages available in the queue. Right now that's 0. Messages in flight, which means messages that have been retrieved and are being processed by another consumer. We have encryption settings, content-based deduplication. Okay, so we've successfully created a standard queue using the Amazon SQS console. In this demo, we'll send a test message to a standard queue in SQS console. Okay, I've navigated to the Amazon SQS console, and I'm on my queues page, which lists my standard queue that I created earlier. I've also got a second tab open to the same location. And I'm doing that because when I send the message, I will see it available under Messages Available. And when I process the message, I will see that message in Messages in Flight. Okay, so let's go ahead. Let's go over to my first tab. Now I'm going to click to open my queue. Now from here, I can click Send and Receive Messages. Alternatively, returning to my queues list, from here I can also select the queue, and under Actions, I can click the down arrow and I can select Send and Receive Messages. I can also subscribe to an Amazon SNS topic here, and I can also configure a Lambda function trigger here. I'll click Send and Receive Messages. Okay, and on the Send and Receive Messages page, I'll send a message. I'll just specify this is test message number 1. Now, I can also set a delivery delay here, and I've also got some optional message attributes that I can specify. So if I expand that, for example, for name, I'll specify context, and the type is string. I could also specify a number or binary. And for the value, I'll specify test, because the context is test. Okay, so scrolling up, I'll click Send Message, and the notification appears telling me that the message has been sent and is ready to be received. So let's click Queues in the breadcrumbs, and under Messages Available, I'll see that I have one message available. So now I'll select this queue, and note, actually, before I do that, let's go over to the second tab. I'll refresh the page. So I'll right-click and select Reload Current Page, or press Ctrl-R. And SQS reports, exactly as in my first tab, that I have one message available. All right, so now let's go to the first tab. Now, I've got my standard queue selected. I'll click the down arrow beside Actions, and I'll select Send and Receive Messages. This time I'll scroll down, and I'm going to select Poll for Messages. So I'll do that. So I'll click Poll for Messages, and now quickly go over to the second tab. I'll right-click and refresh again, and now I'll see that I have one message available. Let's keep on refreshing. And now I have one message in flight, which essentially means that this message is being polled by another consumer, and that actually is me. So let's now go over to the first tab. the polling progress is not quite finished. If I click to select this message and click delete from here, click delete in the dialog that appears, now a message is displayed indicating that one message was deleted successfully. Let's click to close this notification. And now I'll go over to the second tab again. I'll right click and refresh. And that shows 0 messages available and 0 messages in flight. And the reason is because I processed that message and deleted it. So there's no messages in flight, meaning there's no messages that are being retrieved and processed by any other consumers, and there's no messages available because I just deleted that message. That is, I just processed that message. Okay, so we've successfully created and sent a test message and then received the test message and processed and deleted it using the SQS console. In this demo, we'll create and configure a dead letter queue using the SQS console. Okay, I've signed into AWS Management Console and navigated to the Amazon SQS console. I'm on the queues page. I have my standard queue, and I'm going to create a standard dead letter queue for my standard queue. So to get started from this page, I click Create Queue. Now, typically, I would choose the type of queue I want, but really I don't have a choice here because the dead letter queue for a standard queue must also be a standard queue. So let's create a standard queue here. I'll give it a name. I'll just call it My Standard DL Queue. Scrolling down under Configuration, one setting that I may want to change is the message retention period. After all, I want to allow ample time for the message to be retrieved and analyzed to figure out why it can't be processed. So I'll set the message retention period at its maximum, which is 14. So 14 days. Okay, scrolling down, I'll leave access policy as is. I'll leave encryption. I'll leave everything as is, but I do want to expand dead letter queue for this demo. So I'll expand dead letter queue. Now we have kind of an ambiguous statement here. It says, set this queue to receive undeliverable messages. So if I click enabled here, basically it's asking me to choose a dead letter queue. Well, that's not what I want to do, right? This is my dead letter queue. So I'll click disabled and I'll close the dead letter queue section. And I'll click create queue. All right, now the notification appears indicating that my standard DL queue was created successfully. I'll close the notification. I'll click queues in the breadcrumbs. And now I have my standard DL queue and my standard queue. Now, I have to specify my standard DL queue, that's the dead letter queue, as the dead letter queue for my standard queue. So I'll click the radio button to select my standard queue, and then I'll click Edit. Now, scrolling down, I'm not going to change any of the configuration settings other than the dead letter queue setting. So I'll expand dead letter queue, and I'll click Enabled. Now I'll choose a dead letter queue. So I'll click the down arrow, and notice that my standard DL queue appears. So I'll select it. And maximum receives, which is my redrive policy, I'll set that at 2. Kind of an unrealistic value, but it helps to be able to demonstrate how the dead letter queue actually works. Okay, so now we're finished. I'll click Save. And now the notification appears indicating that the configuration for my standard queue was saved successfully. I'll close the notification. And now for my standard queue, I'm going to click Send and Receive Messages. I'll send a message, and for the message body, I'll just enter something very simple like test message. Now I'll click Send Message, and if I click View Details, in the dialog that appears, I'll see the message ID. I'll also see an MD5 hash of the message body and the MD5 hash of the message attributes, which is blank. So I'll click Done. And now scrolling down, I want to poll for the new message. Now I see that there's one message available, so I'm going to click Poll for Messages. Now I'll click Stop Polling. So that's one attempt right there. So now I'll click Poll for Messages again. I'll click Stop Polling again. Now if I scroll down, I'll see the receive count is at 2. Well, this is our threshold. If I try to receive this message again, that will cause it to be delivered into the dead letter queue. But first, before I do that, let's just scroll up. I'll click Queues in the breadcrumbs again. And now I see messages available for my standard queue is 1. And for my standard DL queue, I have 0 messages. So let's click My Standard Queue again. We'll click Send and Receive Messages. I'll scroll down. I'll select Poll for Messages. And then I'll click Stop Polling. So we've exceeded the threshold, our redrive policy. So now this message will be delivered into the dead letter queue. So scrolling up, I'll click Queues again. And now I'll notice that the messages available are 1 for my standard DL queue, my dead letter queue, and 0 for my standard queue. So our redrive policy worked. I tried to receive the message more than 2 times, so it was delivered into the dead letter queue. Okay, so we successfully created and configured a dead letter queue using the SQS console. In this demo, we'll work with Amazon SQS using the AWS CLI. Okay, I've navigated to my SQS console in AWS Management Console. I have 2 queues. My standard queue has 0 messages available, but 1 in flight. Now, if that message isn't deleted, it's going to end up back as an available message. My dead letter queue has 1 message. Okay, so down in the taskbar, I'll click the Visual Studio Code icon to bring up Visual Studio Code. Now here, I have a readme.txt file open with some commands that I'm going to issue. So first, on line 1, the command is AWS SQS. So this is the SQS API that I'm going to be accessing here for list queues. So let's highlight line 1. I'll right-click, select Copy, and down in the terminal session, I'll right-click to paste that command in and press Enter. And that returns my 2 queues. So I've got a standard DL queue and my standard queue. All right, so now I'll type clear and press Enter. Now, from lines 3 through 6, I'm issuing the send message command. And with the send message command, I have to indicate the queue URL. That's on line 4. In line 5, I specify the region, although it's strictly not necessary because the default region for my user on the AWS CLI on this machine is US-East-1. So again, not exactly necessary, but I just wanted to include it to show that you can, if need be, specify a different region. On line 6 is my message body. Okay, so let's highlight lines 3 through 6, right-click, select Copy. Down in the terminal session, I'll right-click to paste that command in. And note, the backticks are necessary in PowerShell just so that I can separate the parameters on a different line so that we can easily see what I'm doing with the different parameters. Okay, so I'm going to press Enter to send the first message. And it returns the MD5 hash of the message body as well as the message ID. Now, I'll up arrow and press Enter to send another message, an identical message, but it's okay, it's a standard queue, we can do that. I will also up arrow again to send a third message. Now I'll type clear, and now let's go down to the taskbar, click on the browser icon to bring up the SQS console, and now let's right-click and refresh. Okay, so now it shows that I have one message available in my dead letter queue and 4 messages available from my standard queue. I had one message in flight earlier, so that message was not deleted, so it goes back into the available messages. Okay, so now back down to the taskbar, I'll click on the Visual Studio Code icon to bring up Visual Studio Code. And now lines 8 through 13. In lines 8 through 13, I'm making a receive message call. Now here I also have to specify the queue URL. Now if you're wondering where I got the queue URL from, I can get it from the AWS SQS list queues command, but I can also get it directly from the SQS console. So if I bring up the browser one more time, I'll click to open my standard queue, and the URL is front and center. So if we click the copy icon, it copies the URL and we can paste it directly into our command. Okay, but I don't have to do that. I've already done that. So basically in this command, on line 9 I specify the queue URL. On line 10 I'm specifying the wait time in seconds, which is 15, setting the visibility timeout to 30 seconds, setting the maximum number of messages to 5, and setting the region to US-East-1. Now here's something to understand. Short poll is the default behavior, and this means that a weighted random set of machines is going to be sampled on a receive message call. So only the messages on the sampled machines are going to be returned. And if the number of messages in the queue is small, for example, fewer than 1,000, then you'll most likely get fewer messages than you requested in any particular receive message call. And if the number of messages in the queue is extremely small, then you may not receive any messages when making a receive message call at all. And if this happens, you just repeat the request. Okay, so let's highlight lines 8 through 13. I'll right-click, select copy. Down in the terminal session, I'll right-click and paste that command in, and I'll press enter. And it returns a message with a message ID. I've got a receipt handle. I've got the MD5 hash of the body, as well as the body of the message. Okay, so we've successfully sent and received Amazon SQS messages using the AWS CLI. In this demo, we'll create a FIFO queue using SQS console. Okay, I've navigated to my Amazon SQS console. I'm going to create a FIFO queue. And actually, I'm going to create a FIFO dead letter queue. All right, so let's click Create Queue. And from here, I'll select FIFO as the type of queue. And for the name of my queue, I'm going to call it my FIFO DLQ. Now, notice that it indicates very clearly that it has to be a .FIFO extension. Okay, so again, the name is going to be my FIFO DLQ.FIFO. Okay, now scrolling down, I have some configuration options. Now, since this is going to be a dead letter queue, I'm going to set the message retention period to 14 days. So I'll specify 14 days. I'll leave the rest of the values as they are. Now, we could optionally specify content-based deduplication here. We won't do that at this point, but we will come back and edit this value later. Okay, the rest of the values we're going to leave as is, and we'll click Create Queue. And a notification appears indicating that the FIFO queue was created successfully. Let's close the notification. And now let's click Queues. And now we see that we have the new queue, my FIFO DLQ.FIFO. The type is first in, first out, or FIFO. And of course, 0 messages available, and in flight, 0 messages. We haven't sent any messages to this queue yet. And content-based deduplication is disabled. Okay, so at this point, I'm going to click to select my FIFO queue, and I'm going to select Actions and click Send and Receive Messages. Now, with a dead letter queue, we don't really want to send messages this way, but we're going to do that to test our queue and to demonstrate how a FIFO queue actually works. So for the message body, I'll specify message 1. And for a message group ID, I'm just going to specify my group ID. Now for a message deduplication ID, this is the token that's going to be used for deduplication of messages within the 5-minute deduplication interval. So I'll specify 111 for my message deduplication ID, and I'll click Send Message. Okay, so now I'll specify another message. So in the message body, I'll specify message 2. I'll use the same group ID, and I'll use the same message deduplication ID, and I'll click Send Message. All right, now if I go back to queues, I'll see that my FIFO queue still only has one message available because I used the same deduplication ID within the 5-minute deduplication interval. So that's why it wasn't accepted. All right, now let's click to open the FIFO queue, and I'll click Edit, and under Configuration, I'll leave most of the configuration the same except for content-based deduplication. So I'll click to check content-based deduplication, scroll down, and click Save. Okay, so now I'll click Send and Receive Messages. So for the message body here, I'll type message 1. And for the message group ID, I'll specify my group ID again. And because we're using content deduplication, message deduplication ID itself is optional. So we'll leave that empty for now. And let's just send this message. So now if we go back to queues, we should see that we have 2 messages available for my FIFO queue. Okay, so let's select it again, click Actions, select Send and Receive Messages. Let's send another message. This time we'll say message 1, and the message group ID is going to be the same as before, which is my group ID. And again, the message deduplication ID is optional, and we'll leave it blank. Now, because this has the same message body, then it's going to reject this message. So I'll click Send Message. Now if we go back to queues, I'll see that I still have just the 2 messages available in my FIFO DL queue. Okay, so before we end though, what I'll do is I'll click to select the myFIFO DLQ.FIFO, and I'll select Purge. In the dialog, I'll confirm by typing Purge, and I'll click Purge. Okay, so now if I right-click, refresh, I'll see that my FIFO dead letter queue has 0 messages available. However, I also see that content-based deduplication is enabled. Okay, so we've successfully created a FIFO queue using the SQS console. In this demo, we'll create a FIFO queue using the AWS CLI. Okay, I've opened my browser. I've navigated to my SQS console. I have 3 queues. Most notably, I have a FIFO dead letter queue. I'm going to refer to this dead letter queue when I create my FIFO queue from the AWS CLI. Okay, so down on the taskbar, I'll click the Visual Studio Code icon to bring up Visual Studio Code. I have 2 files open here. In the readme.txt file, from lines 2 down through line 7, I've specified the syntax for the AWS SQS create queue command. So on line 3, this is the only mandatory parameter, and that's the queue name. Then we have optional attributes, tags, CLI input -JSON, and generate CLI skeleton value. We won't worry about these values from 5 through 7. But note on line 9 that FIFO queue names must end with the .FIFO extension. So here's the command we're going to use to create our FIFO queue. And that's on lines 12 through 14. So I've highlighted it. I'm just going to right-click and select Copy. Okay, so what am I doing here? Well, I'm calling the SQS create queue command, and I'm specifying the queue name. It's going to be called myfifoqueue.fifo, and I'm specifying the attributes flag. And for the attributes, I'm referencing a local file in the same directory called create-queue.json. I happen to have that file open, so I'll click the create-queue.json tab, and here is what I'm going to do. Now, I'm specifying a redrive policy. And why am I doing that? Because I'm specifying a dead letter queue for this particular FIFO queue that I'm creating. And the syntax is like this. You've just got some key value pairs here. So redrive policy, I've got a dead letter target ARN, and I specify that ARN. And I'm also specifying the max receive count, and I'm setting that to an unrealistic but legal value of 2. Now, to specify a FIFO queue type, you have to specify the FIFO queue attribute and set it to true, like I've done on line 3. And my message retention period is 86,400 seconds, which is 1 day. Now, to get the ARN for my FIFO DLQ.FIFO, if I go down to the taskbar and bring up the browser, if I click on myFIFO DLQ.FIFO, I'll see this queue's ARN listed in details. If I click the copy icon, then the ARN is copied to the clipboard. Okay, so I've already done that and set up accordingly. So now I'll go back down to the taskbar. I'll click the Visual Studio Code icon again to bring up Visual Studio Code. Now, since I copied the ARN from the SQS console, that overwrites lines 12 through 14 that I copied earlier. So down in the terminal session, if I right-click to paste what's in the clipboard in the terminal session, then that will be my ARN. So I'll go back to the readme.txt file and copy lines 12 through 14 once again. So I'm going to highlight lines 12 through 14, right-click, select Copy, and down in the terminal session, I'll right-click to paste that command in, and I'll press Enter. And it returns with a queue URL. So it looks like we were successful. So let's go down to the taskbar, click the browser icon to bring up the SQS console. Let's go back to queues, and we'll see that I now have my FIFO queue.FIFO. So now let's click to look at the details for this queue. So if I click More, I'll see the date that it was created. I'll see the message retention period, which was 1 day. And if I scroll down further and click the Dead Letter Queue tab, I'll see the dead letter queue listed as myFIFO.DLQ.FIFO, and the maximum receives is set at 2. So we've successfully created a FIFO queue using the AWS CLI. In this video, we'll explore Amazon Simple Notification Service. Amazon Simple Notification Service, or Amazon SNS, is a web service from Amazon that allows applications, end users, and devices to send and receive notifications in the cloud. Basically, Amazon SNS organizes and manages the delivery of messages to subscribing endpoints or clients. With SNS, you have 2 types of clients: publishers and subscribers. They are also known as producers and consumers, pretty similar to SQS in that regard. Publishers communicate in an asynchronous manner with subscribers by producing and sending messages to a topic, which is simply a logical access point and communication channel. The messages or notifications are consumed using one of the supported protocols, which could be AWS Lambda, Amazon SQS, HTTP, HTTPS, email, or SMS, provided they are subscribed to the topic. In order to use Amazon SNS, you must, of course, have an AWS account and an IAM administrative user. The IAM user uses their AWS credentials, that is, their access key ID and their secret access key, and they must have the Amazon SNS full access policy associated with their IAM user. A user with the administrator access policy associated with their IAM user has the Amazon SNS full access policy. Amazon SNS includes support for logging the delivery status of notification messages sent to topics with specific Amazon SNS endpoints, including application, HTTP, Lambda, and SQS. And once the message delivery status attributes are configured, log entries are sent to CloudWatch logs. Logging provides operational insight, including confirmation of delivery to the Amazon SNS endpoint, the response sent from the SNS endpoint to Amazon SNS, and determination of the message dwell time, which is the time between the published timestamp and the point in time just prior to handing off to an Amazon SNS endpoint. Amazon SNS defines a delivery policy associated with each delivery protocol. The delivery policy determines how SNS retries message delivery when the system hosting the subscribed endpoint becomes unavailable. Once the delivery policy has been exhausted, SNS no longer retries delivery and discards the message. The exception is when there is a dead letter queue attached to the subscription. Each delivery policy consists of 4 phases. First, the immediate retry phase. This occurs immediately following the initial delivery attempt. In this phase, there is no delay between retries. Next, the pre-backoff phase comes right after the immediate retry phase. In pre-backoff, SNS attempts retries before applying a backoff function. This phase details the number of retries and the delay between retries. The backoff phase manages the delay between retries using the retry backoff function. In this phase, there is a minimum delay, a maximum delay, and a retry backoff function that specifies how quickly the delay will increase from the minimum to the maximum delay. The backoff function may be arithmetic, exponential, geometric, or linear. The post-backoff phase, which is the final phase, comes after the backoff phase and is used to specify the number of retries and the amount of delay between them. An Amazon SNS dead letter queue is an Amazon SQS queue that an Amazon SNS subscription can use to send messages to that can't be delivered successfully to subscribers. Messages are placed in the dead letter queue for subsequent analysis or reprocessing. The Amazon SNS subscription and SQS queue both reside under the same AWS account and region. And currently, Amazon SQS FIFO queues are not supported as dead letter queues for an Amazon SNS subscription. An encrypted Amazon SQS queue can be used as a dead letter queue, provided a custom CMK with an appropriate key policy exists, allowing service principal access to AWS KMS API actions. Amazon SNS also supports the use of message attributes, which can be used for structured metadata items like timestamps, signatures, and identifiers. Each message may have as many as 10 attributes. Message attribute data types determine how the message attribute values get handled by Amazon SNS. So, for example, if the attribute type is a number, Amazon SNS validates that it is in fact a number. SNS supports strings as Unicode values with UTF-8 binary encoding. SNS supports a string array, which is an array formatted as a string, which may contain multiple values. The values may be numbers, strings, or the keywords true, false, and null. SNS supports the number type, which are positive or negative integers or floating point numbers. And SNS supports the binary attribute type, which can store any binary data. By default, an Amazon SNS topic subscriber will receive all messages that are published to the topic. However, a subscriber can receive a subset of messages by applying a filter policy to the topic subscription. A filter policy is a simple JSON object that contains attributes defining which messages the subscriber wants. Topic subscriptions may use consolidated message filtering criteria, essentially eliminating the need to filter messages by creating a separate topic for each potential condition. In this case, a single topic may be used with messages differentiated using only attributes. In this way, each subscriber will receive and process only those messages permitted by its filter policy. In this demo, we'll create a topic and subscription using simple notification service. Okay, so I've signed into AWS Management Console. Now under Find Services, I'll type SNS and I'll click on Simple Notification Service when it appears. So here I am in my Simple Notification Service. I'm going to create a topic. So I'll click Topics in the left nav menu and I'll click Create Topic. For the topic name, I'll call this topic Test Topic. The display name is optional. I'll leave it empty. Now we can specify optional encryption. We can specify an access policy right here. We can specify delivery policy, delivery status logging, and tags. Now these are all optional, so I'm going to make this easy. I'm just going to click Create Topic. Okay, so the topic has been created. Now under Subscriptions, I'll click Create Subscription. So the topic ARN is populated for us automatically. The type of endpoint to subscribe, I'll click the down arrow and make note of these. You've got HTTP, HTTPS, email, JSON, Amazon SQS, AWS Lambda, Platform Application Endpoint, and SMS. I'm going to select email for this demo. And for the endpoint, I'm going to enter my email address. And in the information box, we're alerted and reminded that after the subscription is created, we have to confirm it. Now, also here, I can specify a subscription filter policy, which is optional, and a redrive policy, which is optional. We're good to go though, so I'll click Create Subscription. Okay, and the notification indicates that subscription to test topic was created successfully. Let's close the notification. So I'll click the X to dismiss it. And now I've opened my email in the second tab. So I'll click to open my email, and I have one new email. Let's open it. So this email basically is asking me to confirm my subscription. So I'll click the Confirm Subscription link. And now in a new tab, the subscription has been confirmed. Notice also that here, if we didn't intend to subscribe, we can actually click to unsubscribe. Okay, so I'll leave it subscribed, of course, and I'll go back to Simple Notification Service. Now I'll click Topics in the left nav menu again. I'll click to select my test topic, and I'll click Publish Message. So the subject is optional, but I'll enter test message for the subject. We can optionally specify a TTL setting. We don't have to do that at this point, so I'll just leave that blank. And now the message body. So I'll enter the raw message. This is a test message from SNS. I can also specify some message attributes if I want. I won't at this point, so I'll just click Publish Message. Okay, so I published the message to the topic, test topic, successfully. Okay, so now let's go back to the email. And look, now I have another email. So let's click the inbox. And notice that the subject is test message. And the body is, this is a test message from SNS. So let's click to open it. So here we go. This is a test message from SNS. So we've successfully created a topic and a subscription to that topic using AWS Simple Notification Service. In this demo, we'll work with the Simple Notification Service in the AWS CLI. All right, I've signed into AWS Management Console and I've navigated to my SNS console. I have my topics open and I have one new topic called Test Topic. These other topics were created earlier when I was working with CodeCommit and DynamoDB. So Test Topic is the one that we're going to work with. Now, we're going to be working with this exclusively in the AWS CLI. So down on the taskbar, I'll click the Visual Studio Code icon to bring up Visual Studio Code. Okay, so here I have a couple of files open. First, the readme.txt file. In this readme, I've got some commands that we're going to issue. First, I can list topics, I can list subscriptions by topic, and I can subscribe, and I can publish. Okay, so let's go ahead first and I'll highlight line 1, right-click, select copy. I'll right-click down in the terminal and press enter. Okay, and I can see those same 4 topics that I saw earlier in the SNS console. Now, if I was looking for an ARN for the topic here, I could just highlight my topic ARN and right-click and then paste it. Now, I've already done that, so I won't do it again, but that's just one way that you can get the topic ARN quickly and easily from the AWS CLI. Okay, so let's clear. Okay, so now let's list subscriptions by topic. Now, at one point, I had subscribed via email protocol to my test topic, but I have subsequently unsubscribed from that topic. So if I list subscriptions by topic and I'm listing the test topic as the topic ARN, then really I shouldn't see anything returned. So I should see an empty set returned. So let's highlight lines 3 and 4. I'll right-click, select copy. Down in the terminal, I'll right-click to paste that command in and press enter. And there we go. So we have an empty list of subscriptions. So I'll clear, and now I'll subscribe right from here. And to do that, I use AWS SNS subscribe, and I'm specifying the topic ARN, the protocol, which is email, and the notification endpoint. So right now it has a generic my email at example.com. I'm going to highlight and I'm going to enter my email here. Okay, so now let's highlight lines 6 through 9. Right-click, select copy. Down in the terminal, I'll right-click to paste that in, and I'll press enter. Okay, and it returns with pending confirmation. So now down on the taskbar, I'll click the browser icon to bring up my browser. I'll open my email, and I have one new email. It's an AWS notification, and it's asking me to confirm my subscription to test topic. So I'll click to confirm the subscription. And a new tab appears with the message indicating that the subscription was confirmed. Okay, so now let's go back down to the taskbar. I'll click the Visual Studio Code icon to bring up Visual Studio Code again. And first, let's clear the terminal session. And now I'll publish a new message to the test topic. And realistically, I should see that distributed to my email since I've subscribed to that topic. And to do this, basically, I'm just calling AWS SNS publish. I'm specifying the topic ARN, and I'm also specifying a message file. So it's named message.txt. It's in the same directory. I happen to have it open, so I'll click the message.txt tab. And here's the message, hello SNS from AWS CLI. Okay, so let's go back over to the README. I'll highlight lines 11 through 13. right-click, select copy. Down in the terminal, I'll right-click to paste that in, and I'll press enter. Okay, and I get back a message ID. So it appears that we were successful. So now let's go back down to the taskbar. I'll click the browser icon to bring up my email one more time. And I see that I've got one new email. I wonder what that could be. There is the message that I just published from the AWS CLI. All right, so we've successfully subscribed to an SNS topic and published a message that was distributed to the subscribers using the AWS CLI. In this demo, we'll create and manage Amazon Kinesis data streams. All right, to get started, I've signed into Management Console. I'm going to go to the Kinesis dashboard. So under Find Services, I'll start typing Kinesis. And when Kinesis appears in the list, I'll click Kinesis. And this brings me to my Kinesis dashboard. Currently, I have no resources defined. So to get started, under Get Started, ensure that Kinesis Data Streams is selected and click Create Data Stream. Now, the first thing I need to do is enter a data stream name. I'll just call mine My Kinesis Stream. All right, now scrolling down under Data Stream Capacity, we've got a shard estimator, which is a handy estimator. If we expand shard estimator, we can specify the average record size, the maximum records written per second, the total number of consumers, and this helps us determine what value we should use for the number of open shards. For this demo, I'm going to specify 1 because that's all I need. So under number of open shards, I'll specify 1. Now this still gives me 1 megabyte per second and 1000 data records per second in write and 2 megabytes per second in read. So I'm good. So I'll click Create Data Stream. Okay, and now AWS is creating my Kinesis data stream. And now once that's done, we're going to go over to Visual Studio Code and start working with our data stream. In the meantime though, under Applications, you'll find Producers and Consumers. Under the Monitoring tab, you'll find all the metrics associated with this stream. Under Configuration, you'll find the configuration for the stream, and under Enhanced Fanout, you'll find the Enhanced Fanout consumers. Now that's beyond the scope of this demo, but it's good to know that it's here. All right, and the Kinesis stream was successfully created. So now let's go over to Visual Studio Code. So down in the taskbar, I'll click the Visual Studio Code icon to bring up Visual Studio Code. Now not only do I have a README open, but I've got a terminal session open. And there's some good notes here in the readme.txt, so make sure that you have a look at that. Now starting on line 25, note that for information, for example, on put records or any AWS CLI commands, you just specify AWS, the resource that you're using, for example, Kinesis, the command, put-record, and help. Okay, so now, starting on line 28, we're going to list streams and shards. So the first command on line 29 is AWS Kinesis list streams. So let's see what we get here. So we should get the one stream, right? Because that's the one stream that we just created. So I'll highlight that command, right-click, select copy. Down in the terminal session, I'll right-click to paste that in and press enter. And there we have the first stream that we created. Okay, so I'll clear. Now let's list our shards. So I'll highlight line 30, right-click, select copy, paste that into the terminal session, and have a look. That lists our shards. This returns the shard ID, the hash key range, and the sequence number range. Right now we have no data records, so let's type clear. And now let's put some records into the stream. So from lines 33 through 35, I'm specifying the put records command, and that allows me to put multiple records in my stream. So the syntax is just AWS Kinesis put-records, then the stream name, and then the records. And for data, I've got blob data 1, and that has a partition key called partition key 1 associated with it. and data equals blob data2. And for that, I have partition key named partition key 2 associated with it. So let's go ahead. We'll highlight those 3 lines, right click, select copy. Now we'll paste that into the terminal session and press enter. Okay, and that returns the failed record count, which is 0, and it returns the records, and we have 2. And each record shows the sequence number and the shard ID. Okay, so now again, let's clear. Now going back up to the README. Now, what we want to do next is to get the streaming info so that we can get the shard ID. Now we know what the shard ID is, so this is just for practice. But in order to do that later on, for example, let's highlight lines 38 and 39. I'll right click, select copy, paste that into the terminal session. And that returns all of the information about the stream. So describe stream is very helpful, including the shard ID, which is just shard ID dash and a number of zeros here. Okay, so we're good. What we need to do now is we need to get a shard iterator because we want to list the records, right? In order to do that, we use AWS Kinesis get-shard-iterator, and that starts on line 43. Here we specify the stream name, the shard ID, which I already copied, which is the shard ID with all those zeros, and then the shard iterator type. Now I've specified trim horizon here. And the reason why I did that is because that tells Kinesis that we want to start reading at the oldest data record in the shard. So we want to basically list everything in the shard. So let's highlight lines 43 through 46. Right click, select copy. Now down in the terminal session, first I'll clear, and then I'll right click to paste that command in and press enter. Okay, so that gives us our shard iterator. It's the real long string afterwards. Now we want to copy the entire thing, right, including the quotes. But before we do that, let's get the next command. And that's on lines 49 and 50. And that's basically AWS Kinesis get records. And for this, all we have to specify is the shard iterator, which we just retrieved. So let's go ahead and copy the command. So I'll highlight lines 49 and 50, right click, select copy, paste that into the terminal session. Now I'll replace the angle quotes and the shard iterator with the real shard iterator that we discovered in our previous command. So I'll highlight the shard iterator value, right click to select it and copy it to the clipboard, and now I'll right click to paste it in the command and press enter. And there we go. It returned our 2 records. So we have partition key with partition key 1, partition key with partition key 2, and the data associated with each. Now, one last thing, make note of the note on line 53, because this lists some very important information about Kinesis. Now, for scaling in production, we want to use an auto scaling group, and we want to base the scaling on the CPU load on the consumers rather than the number of shards in a stream. This is very important. And the KCL on the consumers creates a record processor for each shard consumed on an instance. And when we increase the number of shards, the KCL adds more record processors on the consumers. So a couple of important things to be aware of before the exam. So we've successfully created and managed Amazon Kinesis data streams. In this video, we'll explore the Amazon Kinesis client library. Amazon Kinesis data streams may be used to collect and process large streams of data in real time. Data processing applications, referred to as Kinesis data streams applications, can be created and used to read data from a data stream as data records. These applications can leverage the Kinesis client library and may run on Amazon EC2 instances. Kinesis data streams may be used for rapidly and continuously ingesting data and for aggregation. Typical use cases for Kinesis data streams includes accelerated log and data feed intake and processing, which allows producers to push data directly into a stream. For example, System and application logs may be pushed and made available for processing within a matter of seconds, preventing the loss of log data if the front end or application server fails. Kinesis data streams offer accelerated data feed intake because the data does not have to be batched on the servers before being submitted for intake. Another use case is real-time metrics and reporting. Data collected into Kinesis data streams can be used for simple data analysis and reporting in real time, avoiding the need to wait to receive batches of data. Real-time data analytics is another use case, combining the convenience and power of parallel processing with real-time data. Kinesis data streams can also provide complex stream processing. Directed acyclic graphs, or DAGs, of Kinesis data streams applications and data streams may be created, typically involving the placing of data from multiple Kinesis data streams applications for downstream processing. We can use Kinesis data streams to address various streaming data problems. However, a common use for Kinesis data streams involves the real-time aggregation of data and then loading that aggregated data into a data warehouse or a MapReduce cluster. Data is placed into Kinesis data streams, and this ensures durability and elasticity. The put-to-get delay is minimal, meaning that a Kinesis data streams application may begin consuming the data almost immediately. With Kinesis data streams, we can create streaming MapReduce type applications. The elastic quality of Kinesis data streams means that we can scale the stream up or down as required. Multiple Kinesis data streams applications may consume data from a stream, and so multiple actions such as archiving and processing can occur independently and concurrently. The Kinesis Client Library, or KCL, is designed to help with the consumption and processing of data from a Kinesis data stream. This type of application may be referred to as a consumer. The KCL handles many of the complex tasks related to distributed computing, like load balancing across multiple instances, for example, and frees developers from such complexities so that they can focus on writing solid record processing logic instead. The KCL can perform many tasks, including connecting to the stream, enumerating and coordinating shards, instantiating a record processor for each shard managed by the KCL, pull and push data records in the stream, and checkpoints processed records. The KCL can balance shard worker associations whenever the worker instance count changes, or when shards are split or merged. In this video, we'll explore Kinesis data stream services, including analytics and firehose, and we'll also have a look at security. With Amazon Kinesis Data Analytics for SQL applications, we can process and analyze streaming data with standard SQL for performing time series analytics, for feeding real-time dashboards, and for the generation of real-time metrics. Similarly, Amazon Kinesis Data Analytics for Apache Flink allows us to use Java or Scala for processing and analyzing streaming data, for performing time series analytics, for feeding real-time dashboards, and for the generation of real-time metrics. In addition, Kinesis Data Analytics is a managed service, so it auto-scales, and it alleviates us from having to provision and manage servers, and we only pay for what we use. Kinesis Data Firehose Delivery Stream is also a fully managed service, so there's no admin or maintenance required. We can use a Kinesis Data Firehose to read and process records from a Kinesis data stream in near real time. To configure Kinesis Data Firehose, we open AWS Management Console and navigate to the Kinesis Data Firehose console. From here, we select Create Delivery Stream. Then, subsequently in step 1, which is Name and Source, we specify a delivery stream name and choose a source, which could either be a direct put or some other source, or a Kinesis data stream. Now in step 2, which is Process Records, we can transform records or convert record format before delivery. Then we choose a destination so we can load the data into Amazon S3, Amazon Redshift, Amazon Elasticsearch, or Splunk, which is a tool for analyzing machine-generated data in real time. Also, for this service, we pay for the volume of data that we put through the firehose. Now, security is a shared responsibility between us, the users, and AWS. The shared responsibility model describes this concept as security of the cloud, for which AWS is responsible. This includes protecting the infrastructure running AWS services in the AWS cloud. The shared responsibility model also describes security in the cloud, which is our responsibility. And this includes securing sensitive data, aligning with the organization's requirements, as well as applicable laws and governing regulations. Kinesis security allows us to leverage IAM policies to control access. It allows us to encrypt data in motion with HTTPS endpoints, encryption at rest with key management service, and we can use VPC endpoints for providing Kinesis with access within the VPC. In this video, we'll explore step functions and simple workflow. AWS Step Functions is a web service that allows us to coordinate components of distributed applications and microservices. With AWS Step Functions, we're leveraging the power of visual workflows. We can build applications from individual components, each of which performs a discrete function, allowing the scaling and changing of applications very quickly. The Step Functions web service is based on tasks and state machines concepts, and accordingly, we define state machines using JSON-based Amazon state language. The Step Functions service integrates with other AWS services, allowing us to call API actions and coordinate executions directly from the Amazon states language. We have a variety of ways to call an integrated service. We can request a response, and the step function will wait for an HTTP response and then progress to the next state. We can run a job and have step functions wait for a request to complete before progressing to the next state. And we can wait for a callback, which offers us a way to pause a workflow until a task token is returned. A typical task may have to wait for human approval, may integrate with a third party, or call legacy systems. To work with Amazon Step Functions, we create a state machine, we start a new execution, and then we can update our state machine for future executions. The Amazon Simple Workflow service simplifies the building of applications that coordinate work across distributed components. With Amazon Simple Workflow, a task is a logical unit of work performed by a component of our application. The coordination of tasks within an application involves managing dependencies between tasks and managing scheduling and concurrency. Amazon Simple Workflow provides us with full control over implementing tasks and coordinating them while avoiding underlying complexities like tracking task progress and maintaining their state. To use Amazon Simple Workflow, we must implement workers that perform tasks. Workers can run on cloud infrastructure like Amazon EC2 or on-premises. We have a variety of options for implementing our workflows with Amazon Simple Workflow Service. We can use any of the supported AWS SDKs. We can utilize the AWS Flow framework, which is basically an enhanced SDK designed specifically for writing distributed asynchronous programs that are capable of running as workflows on Amazon Simple Workflow. AWS Flow framework is available for Java and Ruby languages, providing classes that simplify writing complex distributed programs. We can leverage the HTTP Service API, which provides service operations accessible via HTTP requests. And we'll also need to configure a development environment based on the programming language that we'll use. For example, if we're going to develop for Amazon Simple Workflow using the Java programming language, we'll need to install a Java development environment like the AWS SDK for Java on our development workstations. This also means that if our programming language needs a runtime environment, we'll also need to configure that environment on each machine that these processes run on as well. In this video, we'll explore the differences between SQS, SNS, and Kinesis. Amazon SQS is a distributed queuing system. Kinesis is for managing data streams and may be used to collect and process large streams of data in real time. SNS is a distributed publish-subscribe system, or pub subsystem. It's important to be able to distinguish between these services, so let's have a closer look at each of them. First, SQS is a distributed queuing system. With SQS, messages are not pushed to consumers or receivers. Rather, those consumers have to poll SQS to retrieve messages. Messages can't be received and/or processed by multiple receivers simultaneously, and any specific receiver may retrieve a message, process, and subsequently delete it, and other receivers will never be able to retrieve that same message again later. Polling also introduces latency in message delivery in SQS, unlike SNS, where messages are immediately pushed to subscribers. SQS is used primarily for decoupling or integrating applications, and messages may be stored in SQS for short duration storage. The maximum duration period is 14 days. SQS includes the capability of delaying message delivery, and it also scales automatically. Amazon SNS is a fully managed push notification service that's fast and flexible. With Amazon SNS, messages may be sent individually or in bulk. And essentially, SNS is a distributed pub sub system where messages are pushed to subscribers. SNS supports several endpoints, including email, SMS, HTTP, and SQS. And finally, with Kinesis, consumers pull data, and Kinesis Streams offers guaranteed delivery. But after the retention, which can be up to 7 days, events are removed automatically from the stream. Kinesis is really designed for real-time big data analytics. Kinesis streams are based on a capacity unit called a shard, with events being partitioned and stored in different shards. Kinesis streams don't automatically scale. Rather, external efforts are required to add more shards, so maintenance with Kinesis can be a little bit higher than either SQS or SNS. In this video, we'll explore the Amazon MQ service. Amazon MQ is a managed message broker service designed for Apache ActiveMQ messaging server, simplifying the creation of a message broker with flexible computing and storage resources. We can create, manage, and delete brokers using the AWS Management Console, the Amazon MQ REST API, or the AWS CLI. A broker is a message broker environment on Amazon MQ. The broker represents a basic building block of Amazon MQ. A broker instance type is the combination of the broker instance class, for example, M5 or T2, and size, large or micro or others. And a single instance broker consists of one broker in one availability zone, while an active standby broker consists of two brokers in two different availability zones configured as a redundant pair. The brokers use synchronous communication with applications and with Amazon EFS. We can access our brokers using any programming languages supported by ActiveMQ and by enabling TLS explicitly for AMQP protocol, MQTT, OpenWire, and STOMP. Amazon MQ broker attributes include, for example, a name, an ID, an Amazon resource name, or ARN, an ActiveMQ web console URL, and wire-level protocol endpoints. A broker's current condition is determined by its state. So, for example, here we have in the console creation failed and an equal state in the API, creation underscore failed, and this indicates that the broker couldn't be created. Then for creation in progress, that state indicates that the broker is currently being created. For deletion in progress, the broker is currently being deleted. For reboot in progress, the broker is currently being rebooted. And for running, the broker is operational. So in this course, we've examined the AWS services used to deploy applications using the microservices architecture. We did this by exploring message queuing services, including message-oriented middleware, and how the AWS Simple Queue Service, or SQS, implements queuing services. We looked at how to implement SQS standard queues, dead letter queues, and first-in, first-out queues using AWS SQS. We explored how to work with queues using the AWS CLI and with the Amazon SQS console, and how to send a test message in the SQS console. We also considered the AWS Simple Notification Service, and we looked at how to use AWS Simple Notification Service to create a topic and a subscription to the topic. We explored the AWS Kinesis streaming services, including creating and managing Kinesis data streams, the Kinesis client library, and Kinesis supporting services such as firehose, analytics, and we also explored AWS Kinesis security. We looked at the use of step functions in simple workflow service. We looked at how to distinguish and select between AWS SQS, SNS, or Kinesis, and how Amazon MQ is used to create a message broker. In our next course, we'll move on to explore the AWS Lambda Serverless Compute Service and how it's used to implement the serverless compute model on AWS Cloud.